Hello everyone, my name is Stephen Hill and I'm a contributing editor at Data Center Knowledge. We're coming to you live today from Data Center World, the Expo Center, which is in Austin, Texas. And there's lots of times to still register to attend in the virtual environment. So you can go to datacenterworld.com, and it's your premium choice for finding out what's going on and how we're going to be evolving the data center world today. So first we're going to be talking with, and my first guest, his name is Stephen Smith. He's a director of physical IT network at the community-based institution Arvis Bank. And it serves more than 110 communities across Kansas, Arkansas, Missouri, and Oklahoma. It's established in 1961, and it's committed to continually investing in the communities and offering a growing list of digital services as the banking industry has evolved. So my first guest here is Stephen Smith. You're the director of the physical IT network and facility management at Structured Cabling. You name it, it seems like you cover everything, right?
Yeah, we try to put the ops in operations, right?
Right, exactly. And so, first of all, we do share a background in retail. You started, I believe you're based in Bentonville?
Yes.
Which is, I believe the bank was an offshoot of Walmart to a certain extent.
It was. Sam Walton bought the bank in 1971, and it has grown from that single location to, I believe, over 300 now. It's kind of hard to keep up with, honestly. The change is rapid.
So, how large is your data center facility today? Because again, banking is different than retail, but it's kind of not. So, the first question, and I ask this of everybody because we have a shared background, is do you still involve any mainframe technology?
We do. We have an AS400 on the floor and a certain amount of storage, but we're beginning to transition a lot to partial to cloud. So right now we have 2 data centers. You asked about size. It's not that big. Banking doesn't have the kind of requirements as like retail, where
Sure.
we have, hundreds of thousands of square feet. We have one facility that's about 24,000 square feet, and then we have another one that resides in the 5,000 square foot of raised floor range. So the 5,000 square foot is the older facility, and that's the one that we're actually scaling back and moving applications to cloud.
All right, and that brings up an interesting question: is where does cloud fit into your mix from a processing standpoint, from a production?
It's early right now. We've only been engaged in moving to cloud for about a year, but ultimately we want it to help us get a nationwide. So it's intended to be a much larger part than what we're using now.
Right, and so you're finding that cloud is also, from a security standpoint, perfectly usable in banking environment, because I'm assuming that you have a lot of compliance issues you have to meet.
Absolutely. One thing about banking, everybody needs their debit card to be available. You want your account to be secure, and we care about that. I have a very vested interest because that's where I bank.
Yeah, right? Exactly.
So it needs to be secure. Everything needs to be available. You need to be able to go to the store, have your debit card work. I mean, it's expected, right?
Right.
I had a vice president once tell me the lights are supposed to be on. Same thing in banking. It's supposed to work.
Yeah,
so
exactly.
Uptime and availability are critically important for us.
Yeah, and that's one of the things that's one of the main features of any data center is having that lights on. But also that means that there's a lot of work involved in keeping everything going on.
That's right.
So much of your time is spent just making sure that the lights stay on. Now, as you've been evolving the banking environment, realistically, you've been acquiring banks and expanding your territory. How big of a challenge has that been from an IT perspective?
It's pretty substantial. We will grow either organically through building new facilities, or we'll make acquisitions. When we make acquisitions, they're very timed. You have to agree with a lot of agencies on, here's the time to the minute that we're going to close the old facility.
Right.
Arvest will go in, take over, take everything that relates to the old bank out, and then we have to retool, rebrand, get all the operating systems in place and open back up at a preset time, no matter what.
Yeah, no kidding.
You may have to do several of those on one weekend. So
Right.
it can be very challenging. The logistics and the speed and the accuracy that are required are pretty daunting.
Yeah, no kidding. And then it's a matter of how do you integrate the existing bank's technology into your own.
Right.
I mean, it's a matter of making a transition, and now this is where it becomes challenging with databases, right? Because ultimately, it doesn't mean because you've got a database, it will easily fit into another database. So I'm assuming that there's a transition process from a software standpoint, not to mention the hardware standpoint that you're working with.
Yeah, leading up to acquisition, there's always a lot of preparation work that goes in, and several of the teams, we're very fortunate to have a fantastic IT department. They're very good at what they do, and we tend to be really successful.
Right. So what's your day look like? What type of work do you do generally throughout the day? Is it mostly the physical aspect of keeping things connected, uptime for the network, and or is there a lot of personnel challenges involved?
It's a degree of both. We've got a really robust maintenance program, so every Monday morning starts off with our beginning preventive maintenance. We run generators every week in the branch environment that actually has generators. We do have some.
All right.
And then, of course, in the data centers, there's a full test that goes on every Monday morning because it's only as good as the last time it worked.
Right, exactly.
I mean, you've got to make sure that things are functioning properly. But we're really big on method of procedure, or MOP. We follow the MOP. Everything is planned. Everything is expected. And we follow a really rigid regimen of testing and validation because we want to make sure that, again, availability.
Right. Because again, that's always a big challenge in BCDR is, and you hear about, excuse me, you hear about people that, oh, we have a great plan, but we don't really test it.
Right.
You know, and ultimately you can't, it's the same thing with backups. You don't have a backup unless you're ensured that you can actually recover it.
Yeah.
And all too often you find that companies just don't keep up with the regular testing to validate that your system actually works like it's supposed to. And there's always going to be little things that show up along the way, right?
Yeah.
So for the most part, what are the biggest challenges that you're seeing in terms of staying in communication with all of your different branch offices, because again, this is the same thing that we experience in retail. You have individual stores located all over creation, making sure that they're still connected to the environment and to your primary systems, and then still working within their own environment as well.
Right. One of my areas is field service, and that's the folks that work on all the computer equipment
Right.
in all the branches and support the systems. We regionalize that. So we're in 4 states. We've broken that out into 6 offices, and those offices have support staff that handle a segment of those 6 regions.
Right.
So we always keep besides the daily operations, you've got that group of people who are on call for issues that pop up overnight or on the weekends when we're not open, things like that. So we always keep a regiment of staff ready to respond if there's a network outage or we have a power outage. Heaven forbid the generator didn't come on or something like that.
Exactly.
It happens, right?
Mhm.
Everything from lightning strikes and takeout equipment to just a common equipment failure, you can have that happen. So having the trained staff and having those programs in place to respond quickly when that happens goes a long ways towards keeping the ATMs and the interactive teller machines available for our customers.
Right.
We need them to definitely be available for them. Again, the lights are supposed to be on. But I've got 6 departments now. IT service management is one of them, so work order tracking systems fall into that, as well as change management and major incident response, root cause analysis, all that rolls up in there.
Sure.
All those things lead towards making sure we're operating as efficiently and effectively. And we're not only fixing a problem when it occurs, but we're getting to root cause, remediating root cause, and doing our best to make sure it doesn't happen again.
Right.
That's a failure a lot of people have, is just fix it and move on.
Right.
It doesn't fix it.
Yeah, exactly. And it's different from a physical perspective than it is from dealing with the cloud. Because as you mentioned, you're moving into the cloud. Have you had any issues with having availability of and an understanding of the resilience of the services that you're starting to depend on in the cloud?
We have not. We've been pretty successful with it so far. We've been taking a real small phased approach.
Right.
And moving in pieces and then doing a full validation on those components to make sure they're operating as we expect them. So we have had, honestly, very low fallout related to anything that we have moved.
Nice.
I think people get into trouble when they try to just dump everything and expect it to work.
Exactly, especially when you start talking about a completely complex production environment.
Right.
Because again, you've got your customer-facing stuff, you've got your internal-facing stuff, and then you've got the large underground underlying data center technology for the databases that pull everything together.
Right.
Right. So what do you run into, what's your most common challenge that you run into? Is there anything that keeps popping up for you?
For my departments, really it's making sure that the systems that we own integrate well with we're moving to GCP, so
right.
We need to integrate well with their systems. And I have in IT service management, my folks at home like the integration of Gmail back to our service management platform.
Right.
And that can be kind of challenging, making sure that everything is configured correctly and your emails are coming in and getting notifications out like you expect.
Right.
That's probably been our toughest thing from my department's perspective so far.
Right.
But there's a lot of people doing a lot of work for this.
Wow, yeah, no doubt. And again, this is always an ongoing process. Technology keeps advancing, and guys like you and I have been doing this a long time. Nothing surprises us really anymore. So the biggest challenge that I always see in this transition to cloud is being able to continue to follow those philosophies as you move from one physical environment to a much more virtual environment.
Right.
Well, I think that's the time that we have for today. I really appreciate talking with you, and best of luck moving forward.
Right. Thank you for having me.
Take care, sir. And that was Steve Smith from the Arvis Bank, located in multiple states in the South. Now again, excuse me while I collect everything up here. First of all, business professionals who build, operate, and develop strategies that involve data centers, including co-location, cloud strategies, can rely on data center knowledge for the latest information on how to plan, buy, and manage products and services they need to successfully run the data center. And now, our next guest here is, excuse me while I take it, checking notes here, Jenna Connor, your unit manager for the data centers at the HCSC, which is a large healthcare provider licensed by Blue Cross Blue Shield, and your largest customer-owned insurance company in the United States. Wow, that's fascinating. Operating in plants in Illinois, Montana, New Mexico, Oklahoma, and Texas. So first of all, and again, the challenges of keeping all that going is you, Jenna Connor. You're responsible for managing the data center facilities in multiple states as well, and which also includes all the cabling and all the physical layer one stuff, correct? So the first question is, and this is fascinating, is that along with what you do and all of the things that you're involved with, you're also involved in the local AFCOM chapter.
I sure am. Actually for 9 years. 2014 was the year that I started. And to be honest with you, I just showed up at a couple meetings, and then
the next thing you know.
I know.
Exactly.
We had a board meeting, and they voted me in, and that's just all she wrote. So I've been actually the president since the get-go.
Oh, no kidding! Wow. And so, and on top of everything else, juggling that is always a little bit fascinating, right? So you've seen a lot of evolution in the data center environment. Ultimately, you've been in IT for how long?
Actually, I'm on the other side, on the facilities.
On the facilities aspect of it, right? Which is honestly, you can draw a line, yes, but really you can't, because everything connects to everything else, correct?
For sure.
So the first question is, do you still operate mainframes? I keep asking this because I run into so many companies that still require it.
We do. Actually, we just had a refresh last year.
Nice.
We were actually getting end of life, and there was some talk within the IT department, what do we want to do?
Right.
And IBM came up and said, hey, we got a great deal
We
for
got,
you.
oh yeah,
So we actually refreshed both. We have 2 data centers that have the mainframes, and so
Right.
we ended up refreshing both of those.
because again, if you have one, you kind of need another one,
Absolutely,
right?
correct.
Exactly. And it's fascinating because, again, being someone familiar with mainframes from my earlier days, it's fascinating how many environments still depend on it. And it's an I/O issue. There's a lot of reasons why a mainframe is still a really viable thing, although nobody still talks about it.
That's correct.
So you went into the new, what is it, I'm trying to remember what the current level is. Because IBM's continued on and on
They have.
with the mainframe technology. And again, they look at it as an extremely complex, powerful and resilient
Right.
cloud platform too, which is
correct.
fascinating because, again, that was the one thing that mainframes did in the early days that still applies today, is that they can parcel out percentages of their processing power, yet keep access to all of these different complex environments under one roof.
It is.
So the first question I would have is, how big of a challenge is compliance issues, such as HIPAA and other security issues that are involved in what you do?
That's interesting. Because we are a health insurance company, it's basically in our DNA, so to speak, as soon as you join
Right.
the company. I don't think of it as an extra, it's just what we do, and this is how we handle things.
Exactly.
So security and everything about it is absolutely top notch. It's just how we learn. That's how we're trained every year.
Right, exactly. And again, this is, the medical environment has probably been one of the most compliance organized
Absolutely.
environments. They first, and ultimately we've been signing off on those HIPAA releases for, what, a decade or more now?
Correct.
Exactly. So going back to what you do for HCSC, run through what your typical day is like.
Sure. First of all, I'm in the facilities side, and so what I do is, over these many years, I've been in the data center side of it, about 11. I have been the liaison between facilities and IT.
Right.
So we have really good, strong teams. IT brings in the equipment, the devices, and then we install it with the infrastructure in. So every day it's something new.
Yeah, no doubt.
For sure, but we do have several data centers. One's in Illinois, and that's our
Okay.
on-prem. And then we have a DR site, which is also at a colo in our Texas
Right.
area. And then we have a couple of control rooms, we call them little mini data centers.
Sure, exactly.
That are scattered. We have in their headquarters.
Right.
And so I manage those as well.
Wow. It's quite a handful, I would imagine.
Yeah.
So when you start looking at how have you seen your data center environment shift over the last decade, let's say?
Okay, first of all, I think just the high density part of it
Right.
has been extremely you just got to think through everything, because before, we're doing the DL380, a billion of those little pizza boxes,
Right, exactly.
And now we're really looking at the blade chassis, and they're just power hogs.
Right.
And so looking at a facility that we have up in Illinois, which is it's a little bit older, it's a 20-year building, and you just got to look at the power and cooling. And so what we're looking at is just like, how do we keep up with the IT needs?
Right, exactly.
And frankly, we're going through a business case right now that we're adding more trays, and we're adding some UPS capacity
Right.
and PDUs. And so it's been kind of an exciting time, because you don't want to be behind the ball.
Right.
You want to be ahead of the ball.
Right.
And so we're doing a lot of that up in, like I said, in Illinois.
Right, no doubt. And so how much of the adjustments that you're making involves monitoring and visualization of the way that the environment is behaving?
Well, we're in a colo in Texas.
Right.
So we actually owned that building.
Oh, no
Which is
kidding.
an interesting fact.
Uh,
And I'm sure I could say this, but QTS bought the building
Sure.
about 2016, and what we decided is we downsized we had about 40,000 square of active space, 40,000 square feet, and we went down to 10,000.
Oh, wow.
So we're leasing back. But what's great, because this building is awesome.
Yeah.
And I used to work in this one solely, and it's just a beast of a building. So it's been really fun to work with QTS, but it's become a DR site.
Right. So, and again, the challenge is dealing with the compression of the IT environment.
Yes.
Like you say, even though you're using a quarter of the space, you're probably using more energy
Yes.
in that quarter of the space than you had when you entire thing filled. So, how have you been adjusting to that that compression, that condensation?
Well, because it became a DR site, it was a really interesting transition because I helped with the migration.
Sure.
And it was difficult. We went from 2 data halls down to just the 10,000 square feet, and it was IT was guiding us of what they felt like needed to be in that site. So it was a lot of moving things around and getting things ready. It is interesting. We are more of a energy hog now than we were before. You hit it
Sure.
right on the head.
Right.
Obviously, with being at a colo, it helps a lot because we get whatever we need. Right.
Right. Exactly.
So that's been fascinating. Our other one in Illinois, our on-prem, is constantly moving. And I'm sure this is natural across the entire data center industry, but it's in and out all the time. There's just so much movement of different servers, different blades, just different equipment that's coming in. And the focus on IT right now is a lot of the cloud. Like, what can we put into the cloud?
Right.
Now, we are health insurance, so there are things that probably can't go to the cloud.
Well, yeah, security issues.
Correct.
And again, the decisions that go around putting something in the cloud is not just about, well, can we save ourselves this resource?
Right.
Is it a matter of, can we get the performance we need? Can we get the security that we need? Can we get all the things that we need in the same way as when we have it on our own physical location?
For sure.
Right. So what are you seeing in terms of, because again, like we were talking about, it's the tightening up of the amount of space required, yet still requiring the same amount of power and cooling or more.
Mm-hmm.
So how are you evolving with increasing your power and your cooling capabilities as you evolve and expand?
Well, because we're going through this business case, we started looking at it probably a year ago, because what was happening is we were chasing the tail.
Right.
IT would come and say, hey, we've got all of these VDI, the synergies coming in, and they're power hungry.
Right.
And so we had to figure out on the floor plate of where they could go, where we had the power, where we had the cooling. And as we built up the environment, there's just areas that are not as healthy, or I shouldn't say healthy, as dense as others.
Right, exactly.
So we started looking at what do we need to do, because it is really mind-numbing and having to constantly, like, what is IT going to bring in?
Right.
Because a lot of times the people that we work with, they sometimes don't know, because it's like so many different levels above them.
Right.
That has ordered the equipment and coming on in.
And and it's, by the way,
Yeah.
here you go.
At the dock, here they are.
That's right.
No, it's not quite that bad, but a lot of it is it's hard to do strategy when some of this stuff is kind of coming at you really quick.
Right.
So one of the things is building out this business case with more power and more cooling, I think is really going to solve a lot of sort of initial problems.
Sure.
Where you don't have to think so much of, okay, we can only put it here on the data center because that's where we have power and cooling. Now we'll have it sort of an even flow across.
Right. Now, have you, because again, you said you reduced your amount of square footage substantially. And then again, because it builds up, instead of having a rack that would use maybe 10 kilowatts, you're talking about racks that can easily get up to 40 or 50 kilowatts. So are you finding that, I'm assuming it's a raised floor environment, yes?
Yeah.
So how do you do that? I mean, ultimately, it's not like you could just create more floor space. I mean, so again, how do you adjust a raised floor environment to meet these higher cooling challenges?
Well, first of all, they built the first data center, like I said, about 20 years ago, and they
Sure.
built it really well. And so when we built the second one in Texas,
Right.
it was kind of like lessons learned. And so our raised floor space is 36 inch,
Oh, okay.
and it goes down to a 30 inch at both sites.
Right.
These are the two big data centers that we have.
Sure.
And so that gives us a lot of flexibility. I do know that a lot of overhead is happening right now in the industry,
Sure.
but underfloor, the guys, we have stellar data electrical
Nice.
groups that work with us, Terrence and Morley Moss. They are stellar. I mean, everything is so crystal clear and clean.
Right.
And I mean, literally, you can pull up a raised floor tile.
Right.
And find just wonderful lines and beautifully coded.
Oh,
and
that's
labeled,
nice.
which I love.
'Cause-
But to that is, it's a matter of being organized and coordinated. We have a really, really healthy relationship with our IT folks that we work with on a daily basis. So there's no secrets between us. Like what
Right.
they know, we know, and we work together as a team to do whatever we need to do.
Right, because again, so much depends on the physical environment.
Right.
And so are you finding that there's a lot of, I guess you use the term churn, in terms of where you're placing racks, how you're moving things around? Because it's not that easy, right?
It's
I
not
mean,
easy.
when you're talking about all of the cabling that's required, and then all of a sudden they want to add all this stuff to it.
Right.
Are you finding that you have legacy areas and then you expand in areas?
Yes.
Right.
Yes, that you hit it perfectly. So there's rows of whatever it might be, and then what we're doing right now is adding either another row if it's possible,
Sure.
or adding onto the existing row. Adding the MDAs has been important too.
Sure.
We've had to add some PDUs on
Right.
the floor as well. So yeah, it's like a puzzle
Yeah, no kidding.
all the time.
Do you have any what tools that you use to manage that, to keep track of the power distribution in your environment?
We're using decent. We're using Nlight
Okay.
from the Nlight is from the IT point of view, and they have all the devices in. We've got them
Nice.
all labeled.
Oh, so that you've got a general idea of how everything is,
do.
even before you get started, which
That's
is kind of
correct.
nice, right? Exactly. And again, the challenge you mentioned, and it's fascinating, is that how often raised floors can get really complex underneath, right? I
Yes,
mean,
for
sometimes it's just easier to leave a cable there after you change than it is to pull it out. But if you have a good cable environment that you keep hygiene,
Yes.
it's always a big challenge. And I've even heard stories of where they'll pull up a tile and they keep their beer under.
Oh my goodness, we don't do that. We
No, don't do that, right? Well, and again, it depends on so many. And it's really all about the philosophy and the way that you look at keeping your data centers running, making sure that everything remains efficient. How you been adjusting your power efficiency? Is this something that you're monitoring on a dashboard?
We do. I'm going to be honest with you. We pull the dashboard into reports. And
Oh,
that-
sure.
So of course, that's what I'm working with our consultants. It's definitely one of those things that we have to keep on, just to the minute. We just need to keep up on that.
Right.
So I look at more of the reporting. Our in-house guys look at obviously the dashboard and
Right.
all that. And like I said, I work with a lot of the consultants. We have MVP that come in, and some of them have been there since the beginning of our full data centers,
Right.
20 odd years ago.
Wow.
So-
So it's nice to have that kind of history with
sure.
your partners,
Yes.
and to make sure that, again, you're doing the best you can to keep things efficient and sustainable, because that's a new term today.
You know it.
And I think that's all we have time for today. It's been wonderful talking to
Nice
you. Thank you
meeting
so
Steve.
much.
Thank you.
All right. Another fascinating conversation. Thank you so much. And we'll just take a pause for the cause here, and let's say data center knowledge informs cloud co-location data center operators, their customers and investors in the digital infrastructure and professional world, and it gives you the information that you need to know to keep progressing as far as keeping up with a large technological environment like we're in today. And hi there, I'm looking at our next guest today, and our next guest is, and forgive me because I wrote this stuff the night before last, so I'm still looking at things, but you're Greg McAtee, you're Senior Research Analyst, Infrastructure Systems, Platforms and Technologies at IDC.
Yes.
How you doing?
Very nice.
Good. You're a Senior Research Analyst at IDC's in the Infrastructure Enterprise. Your coverage consists of a mix of server storage, converged PBBA markets, and hardware space, in addition to contributing to a variety of IDC's enterprise infrastructure trackers. So this is it's been a fascinating time for us in this industry, right?
It sure has.
So what do you focus on? Do you focus on basically the physical aspect of it, or all aspects of the data center?
So these days, I mean, yeah, that was a great introduction. Thank you for that. So I started off in the hardware space specifically, and over time I've gotten, involved coverage into the software space as well.
Sure,
So
because again, you can't have one without the other, right?
Exactly. It's all part of the same platform. So over
Exactly.
time, adding on, some data protection, disaster recovery, coverage area services there, as well as operating systems, virtual machines, containers, all that
Right.
stuff, the core infrastructure stuff.
Right, and again, the complexity of that has just been expanding and expanding. This is the one thing that I talk about regularly, because I've been an analyst too, and yikes, right? It's a matter of being able to look at where technology is going, and trying to anticipate where things are going, because that's what people come to analysts for. Is that, all right, what are we not seeing? What are we looking for? And the first and I think that the most interesting thing over the last 2 years, and that's a bad way of putting it, but is the COVID epidemic.
Yes.
And that changed dramatically the way that we look at the way the business runs. And fortunately, and I always tend to think that we would have never been able to survive as well if it had happened even 5 years earlier, because we could transition into an environment where people could stay at home, where our systems could expand outward like that. Even though it was a scramble, it was still something that was possible, because it wouldn't have been possible, like I say, even 5 or 10 years prior. So what do you think, how did COVID affect the current environment, and do you think it's something that's still going to reciprocate or resonate down in the next couple of years?
Yeah, and absolutely, like you said, the story continues to change and evolve every 3 or 6 months, and of course COVID was a just massive shift in the way that we observed IT systems and infrastructure being run. On our side of the house, that a lot of the spending that was available in the market had to shift to the infrastructure in order to be able to support the workloads for
Right.
enterprises as well as consumers at home. So, in that regard, kind of taking a look back at the numbers that we saw, there was a tremendous amount of growth across, all of our coverage areas, specifically in the cloud as well as, on-prem spending, in order to be able to accommodate, those individual things that were going on. It was, and we'll talk a little bit more about operating systems later on, but, for a market that was, somewhat stagnant for a while, we really saw, the dynamics at play, it catapulted the market into double-digit growth territory for,
Right.
One of the oldest markets that actually exists in technology.
Yeah, no kidding. And again, this goes beyond the typical ebb and flow of the way the market would normally run. So ultimately, it seems that even though there was a major investment in technologies to make things work during COVID, now everybody's playing catch up, because it's easy to get behind the technological area, as it were. You can get what's called there's a penalty for getting too far behind. And ultimately, a lot of companies had to put off all kinds of investments during COVID, because even though people, even though they needed it, they didn't have the people to actually do it.
Right.
So, and again, we're still dealing with some of the challenges of supply chain and everything else. What are you seeing in terms of availability of technology hardware?
Yeah, I mean, compared to what it was, I think, conditions have improved to a certain extent.
Right.
That said, there's still challenges out there. We're seeing, customers facing higher prices and, longer wait times to get the components that they need. There's a bit of mismatch, across the board, across the data center. It's not, perfectly in harmony,
Right.
if you will. So I think that's had an impact as well.
Right. What emerging what emerging trends are you seeing right now that companies should be looking forward to in the near future? Because again, this is part of the challenge of being an analyst, right? Is give us the crystal ball of what we're supposed to be looking at next.
Yeah, so I think there are two things, and one, kind of, emerging from the pandemic and, all of that massive growth in spending, it's a little bit of a hard time in the economy right now.
Yeah.
Inflation's definitely kind of taken its toll, and being able to find that new balance, as conditions get back to normal is, kind of one thing. The other area in the data center that I, see, and, for my coverage area, I'm happy that folks are focusing on is cybersecurity.
Right.
Time and time again, we run these surveys, and security is always the number one concern for the IT and developer side. But now it's a critical piece of what data center operators are being tasked with as well, and
Right.
paying attention to. After all, if the backup and disaster recovery workloads aren't being supported by the data center, what are you going to do if something bad happens?
Right. Exactly, because BCDR is really one of the key issues that we need to focus on. This is something where it's one of my areas of coverage too over the years. But ultimately, it's one of those things that's easy to let it go by the wayside, especially if things are just going okay, because, we never needed it, so it's not going to happen. Well, yes, it does.
Yeah, and I would add to that, we've run multiple surveys, and, a majority of organizations will say that they are prepared if they get hit with ransomware. And in actuality, if you survey them again after the fact,
They're like-
a small majority of them,
Right.
about a third or so.
Oh, we
were
had
able
no
to
idea it would be this
successfully
bad.
recover from it, or ended up having to pay some sort of ransom along the way.
Right. And again, that's always the debate, do you pay, do you not pay? A lot of it depends on how prepared you were prior to it. Because it's one of those things where it's insidious. Ransomware has been around a long time, but it doesn't mean that it's gotten any easier. And ultimately, even though the tools to deal with it are in place, people don't always think about it that way.
Exactly.
Yeah. So, and again, going back to the issue, because again, I remember backups are one of the things that I'm a big fan of, is that you also have to check to make sure that the backups are recoverable. Because again, putting a system in place and not validating it on a regular basis, not checking the efficiency of your security posture are things that can lead to serious trouble.
Yeah, exactly. It's the full spectrum. It's not just a set it, forget it thing. It's something that you have to constantly keep an eye on it. It's a mission critical workload in and of itself.
Right, exactly. And honestly, one of the balances and one of the benefits I've seen from the cloud is it is actually a really good tool for being able to do BCDR. Not only can you move data into the cloud that you can access from anywhere, but ultimately it's also about production workloads and things that can be moved to the cloud quite easily, as opposed to dealing with the physical infrastructure at the location that you're at. But again, it requires a lot of work involved to get that set up, but once you do, the cloud is a resource that we had begged for 10 years ago.
Exactly.
And now it is pretty common today.
Yeah, just for those cheaper costs, and we find that most customers, almost all of them, want a cloud-like experience when it comes to backup and disaster recovery.
Right.
Not only for the efficiencies that it offers, but also the costs.
Right. And again, it's one of those things where it's the cloud, I'd say a cloud-like concept is one of the things that IT was moving toward anyway, right? I mean, it's the abstraction that pulls away all the underlying complexity. We don't need to know all the machines that are all the stuff that's involved, or the average user, or even the developer should have access to these high-level tools without worrying about all of the connections underneath. But that also puts the challenge on the people who deal with that stuff underneath.
Yeah, that's exactly the value of the cloud right there.
Right.
I said it better myself.
Exactly. Just a curiosity, because again, this is something that I did a little bit of writing on recently, and it's a matter of where does open source fit in the enterprise environment? And this is the one thing that I found interesting, is that the people who are worried about open source don't realize that a huge chunk of IT operates off of Linux.
It is on open source, yeah, exactly. And I could go on for hours about this, but the value of open source has been well documented for a long time.
Right.
It has allowed customers to acquire technology for much cheaper. These smaller customers, and be able to compete in the digital economy.
Right. Because that's the way that's what the cloud did too, is it democratizes resources, right?
Yes.
I mean, you can have access to amazing equipment without buying that amazing equipment. Basically, you can just put it on your credit card, and it's that simple that you can have access to high-level services and resources. But going back to the idea of where Linux fits into the cloud, into the data center in general, are you finding that majority of customers are moving to Linux, or is this something that's a constant thing that changes?
I would add to that a majority of customers already have.
Oh, sure.
Our numbers show, in terms of the installed base, that inflection point happened a couple years ago.
Right.
Specifically in the cloud, there are other workloads that are still on Windows or Unix or whatever you might have, but customers really have embraced Linux over the past decade or so. It's by far the majority of the operating systems in the enterprise environments that we're seeing these days. Almost I would say about 3/4 or so.
Oh wow! And again, you could look at all of the numbers and the estimates of what kind of market penetration some of these things have. It's not always, I don't think, accurate information, but for the most part, it seems to be a regular trend that's been going on for over a decade now, especially since Linux, because again, there's two major enterprise Linux companies. There is RHEL or Red Hat, and then there's SUSE, and it seems to me that SUSE is pretty much on the European side or the EU side, where Red Hat seems to be more dominant in the United States. Is that a fact?
Yeah, that would be along the trends that we're seeing as well. SUSE is a German company; they have a strong foothold in Europe, but we also, they've been, able to make inroads,
Right.
In other geographies as well.
Right. So now, in terms of the way that they're using Linux, it's not just for an operating system. I mean, ultimately, these companies are also providing storage capabilities and other kinds of aspects. Do you find that they're also adopting the open source in terms, say, for example, storage?
Yeah, they do as well. I think for these companies, Red Hat, SUSE, and so on, it's about building out an ecosystem for
Right.
customers beyond what just plainly open source offers. That's a huge differentiator for them. They're mostly in the compute side, but storage as well.
Right. Because again, this is one of those things where, to a certain extent, some of these Linux environments kind of can be referred to as build your own, right?
Yes.
I mean, for the most part, it gives you the tools, but fortunately, companies like SUSE, like Red Hat, have kind of enterprised their environment in such a way that there's support, there's development support, there is a lot of resources that enterprises need to be able to utilize an environment like that, like you say, to create a consistent environment for companies or for your IT to work with.
Yeah, and I would underscore, the word consistent there. It's the same user experience, whether you're, on, bare metal server, a VM, a cloud instance at the edge. It's that same consumable, reliant, performance intensive, experience across environments, and of course, the other side of the coin is the support that they offer for it as well.
Yeah, exactly. So, are you seeing any shift in terms of moving toward Linux and away from the traditional Microsoft or even VMware? Because VMware has made established a substantial space in the data center, partially because it provided an operating environment that was extremely consistent from day one, except that it was always under development. I mean, realistically, the tools, the resources that you had with VMware were great, except for the fact that you were tied to VMware.
Right, and those legacy workloads, are always going to exist. Customers are going to continue to want to consume them. But as our research has shown time and time again, the market still continues to pull over time toward Linux. Over the next couple of years, we're going to continue to see that. I think, just thinking back to our numbers, a 14%, compound annual growth rate through 2026, for the Linux environments. So,
Excellent.
That's where the market's headed for sure.
Well, this has been great. Thank you very much for your time today. We'll move along. Enjoy the rest of the show.
Will do. Thank you so much.
Thank you. And moving along to our next guest. First of all, a little bit of information here is that Data Center Knowledge recently published an acronym cheat sheet by DCK contributor Christopher Tossi. On May 3rd, it's already been downloaded by hundreds of data center professionals. I remember doing the same thing because I was fascinated with acronyms and IT, and it was dozens of pages long. My favorite was PEBCAC, P-E-B-C-A-C, which means the problem exists between chair and keyboard. and that being said, our next guest today is, you're Raymond?
Oh, no, I'm Kelly.
I'm sorry, I don't want to jump too far ahead. Okay, this.
I'm Kelly Fleming, CIO at Cirrus Nexus.
Oh yeah, okay, I'm sorry. My pages are all messed up here. As usual, Cirrus Nexus. Darn it.
Uh-oh.
Oh, you're still here though, we haven't lost you.
Oh,
There we are. Excellent. So again, thank you for joining us today. Our guest here is first of all, Cirrus Nexus is a software development company dedicated to empowering businesses through its AI-driven cloud management platforms. They offer direct control of monitoring and optimizing cloud spend across multiple different cloud service providers. And joining us today is Kelly Fleming, who's co-founder and chief information officer at Cirrus Nexus. Now, looking at your flagship product, which is, I believe, TrueSpend,
That's
correct? It's designed to mitigate the complexity of underlying cloud environments and to have a visualization into where your cloud spend is going, how you're actually using resources most efficiently. How many cloud services are you capable of tracking today? Because again, this is such a flexible environment.
Yeah, that's true. It's getting more complicated by the day as all these cloud providers provide more and more services and more players get into the field. At the moment, we primarily optimize AWS and Azure Cloud. Our product is pretty much plug and play with those.
Sure.
We also have a little bit of flexibility with Google Cloud, but it requires a little tweaking before setting up. And we can deploy on ServiceNow instances for many clients or just through a web-based application as well.
Right, because one of the benefits of the cloud is the flexibility, but that brings flexibility brings along complexity.
Exactly.
And so there's a challenge of being able to mitigate that complexity. And I'm guessing that's what you focus on, is being able to mitigate that complexity.
Exactly. Yeah. So a lot of our clients, the excitement of moving to the cloud in the first place from their on-premise situations was that they weren't trapped into one data center.
Right.
The cost may have been lower. There are a lot of advantages for scaling up and scaling out really quickly, but then quickly after a couple of years, things get out of control. Things get really complex. They forget where resources are. Tagging becomes a real problem. Large organizations are facing these challenges all across the world.
And then they get their monthly bill and have a heart attack because they did not know that, oh my God, we're either buying resources that we're not using, or we're buying resources all over the place without an intelligent model for doing that.
Exactly, yeah. The guy who pays the bill isn't necessarily the one who's deploying the resources.
Right,
It's a
exactly.
recipe for disaster.
Exactly. So how long does it take for a company to show an ROI when they start using a product like yours?
Oh, very quickly for ours. There's multiple layers. The first thing the product kind of identifies are just disconnected resources, ones that have been left behind in the cleanup process, like data disk, load balancers, IPs, stuff like that.
Right.
Those can quickly be removed through the tool, or they could be like re-provisioned to cheaper, less expensive versions. If you're not sure who owns the resource, you just make it put it on an archive situation before actually deleting it. And then quickly after that, through analysis of all the metrics, the AI will identify various right size opportunities and relocation opportunities.
Right.
In the public cloud, you can quickly re-provision a database or a virtual machine to a different SKU, or you can even move it to a data center, which often has different price points.
Right, exactly.
And after that, the most impressive part that blows my mind is the dynamic optimization aspect of it, where it will identify patterns of usage,
Right.
rather than provision a resource to be at like the maximum capacity you needed for one type of job that might happen once a week or once a month. The platform will identify what size it needs to be at different times of the day, different times of the week, the month, and will allow you to continuously re-provision it to those different sizes to make the most of your workload without hurting your budget.
Right. Now, assuming most companies who adopt a cloud environment are using a hybrid cloud environment as well, I mean, is it rare to find companies that are purely cloud, or the vast majority, is it a mixture of on-prem and traditional resources and cloud, right?
Yeah, much larger enterprises in the Fortune 500, they're often multi-cloud, hybrid cloud. A lot of them still have a lot on-prem. They don't want to get rid of those data centers immediately.
Right.
So we do two things. One, as they make the migration to cloud, we help them quickly or continuously monitor those resources to make sure that they aren't over-provisioning them, so we can quickly corral in any excessive spending. And B, although it's not plug and play, with a little extra work from our engineers, we can connect the platform to your data center management system and analyze essentially the same metrics in that case.
Right.
At that point, it's not so much about saving money by reducing over-provision workloads there. It's about freeing up capacity for other jobs to take place and also reducing your energy bill.
Right. And how do you visualize their existing on-prem environment then? Because again, that seems to be what, part of the decision-making process is, how much is it costing me to do this here versus somewhere in the cloud?
Well, we see the cloud workloads are very much approaching a commodity status.
Sure.
Where different cloud providers, different on-prem providers will offer seemingly very different services, but they all still rely on very similar hardware, very similar metrics of CPU usage, IOPS, throughput, RAM, stuff like that. So we try to provide a way to kind of visualize all that in one platform, and so you can kind of make comparisons and decide, like, all right, this workload running on an on-prem environment would most likely be running in a very similar fashion in an Azure or AWS environment.
Sure, exactly. Because again, that's always a challenge. Of the difficulty with the cloud is the fact that there's so many different options, and being able to compare non-identical services service envelopes. But again, there's enough similarity that I think that it does give people the kind of flexibility that the cloud promised in the first place, right?
Exactly. A lot of flexibility, but with that comes a lot of complexity. So it's a double-edged sword, really.
Right. So I was looking at, you had a new offering called True Carbon.
That's correct. Yes, we just launched this out last summer, and essentially we, in addition to offering the same cost optimization that the TrueSpend product offers, we're throwing in a bit of a sustainability kick to it.
Right.
So we can identify down to the workload level in close to real time what the energy usage and, as a result, carbon emissions would be a database or virtual machine running in a cloud environment.
Because again, I've been doing a lot of research into data center sustainability and focusing on the reduction of greenhouse gases, which is ultimately what the carbon issue is all about. The problem that I've been running into as I do research is that it's very difficult to pull that information out of an environment where you're utilizing carbon in so many different ways that you don't even realize.
Yeah, it's very tricky. Yeah.
So same for an example, if are you focusing specifically on the electricity aspect of carbon generation, or do you look further into the different sources of carbon?
So for our clients, we're primarily just looking at the electricity side of it from a carbon standpoint,
Right.
not what they call the life cycle emissions, which would be the carbon involved in producing the semiconductors and stuff like that.
Right.
But we look at the energy consumption at the workload level, and then we also look at what the composition of energy being used by that data center in that region at that point in time.
Right.
And that way we're able to determine that your virtual machine, because it's located in this data center and it's running at high utilization, has X amount of carbon emissions.
Right.
If you were to size it properly and move it to this data center location, which typically runs on cleaner energy at the times you're running it, there's a whole lot of ways you can leverage where and how you're running your workloads to reduce your carbon footprint.
Right. So is that information commonly available? Do you actually have to go down to the utility level and find out what the nature of their power generation is? Because again, there's such a broad mix right now of the way that, whether it's still running on coal, which unfortunately there's a lot. There's nuclear. There's renewable like solar and hydro. So ultimately, there's got to be a relatively complex database that you need to build about power providers in terms to get that information out there.
It's very true, and the cloud providers themselves, like Google, AWS, and Azure, they provided some insights into what sort of on-premise energy production they have, like solar panels on the data center roofs and stuff like that.
Right.
But the vast majority of the power still comes from the grids.
Right.
And this information we gather from a variety of different sources around the world. It's quite a complex process. And
no
trying
doubt.
to do it in real time is quite challenging. It took us a few years extra to develop this product as opposed to the
No doubt.
product.
And again, and so now how is your product being used as far as being able to validate a company's carbon footprint? Is that part of what the goal is? Is that
Yes.
you look at their environment and say, oh, they could publicly say, this is what our carbon footprint looks like. This is how we're making that less impactful, making ourselves more efficient?
Exactly, yeah. I mean, not only do we identify the carbon emissions, and we do it at a much more granular level, looking at the actual usage of these workloads and not just the overall cloud bill,
Wow.
like some other solutions do out there. But we also identify ways you can reduce your carbon emissions without increasing your cost considerably.
Right.
So it's it's a very interesting area, and one of the reasons I'm here this week is to explore what all these different data center engineers are doing to improve the sustainability of their environments.
Exactly, because again, it's having followed this industry a long time, it's pleasing to see the fact that they're thinking about this at all.
And it's one of those areas where, I mean, the amount of energy consumed by data centers is just going to start spiraling
Sure.
over the next decade, especially with the spread of machine learning and AI technologies, which are very, very energy and compute intensive.
No doubt. By comparison, because again, I've gone from the mainframe days through client server to an environment now where we're talking about extremely dense, extremely high energy environments, and then you start adding AI and some of these other analytics features that are out there, either as cloud services or on-prem for that matter. The numbers are stunning. But along with that is the amount of production that you get out of that. I mean, it may sound extreme, but on one side you're talking about systems that would have required supercomputers only a short while ago. Now you can have it running in your own environment, or you can easily go out and get them out of the cloud without having to invest in any hardware at all.
Yeah.
So now, where do you see the next level of efficiency is in terms of, because again, you focused on resource efficiency, then you're focusing on carbon efficiency. What do you think is the next big thing that data centers can do to try and manage their sustainability?
That's a very good question. I think just electricity consumption efficiency in general, right? So one of the problems with renewable energy not being able to meet all these demands is that we have a lot of renewable energy production out there.
Sure.
But we have trouble getting it to
where it's got to go.
And a lot of it isn't consistent all the time. We still need to have, coal, gas at the moment meets those peaks in demand you have during heat waves in the summer or frost in the winter. And in the middle of the day, there might be a lot of solar power, but at night you're not getting that solar power,
right.
So you're meeting that demand with other sources. So I think we really need to have better battery usage. We need to leverage when we're running workloads that don't need to be run at times when the energy's dirty. You just run it when the energy's clean.
Right.
We've seen a lot of. I think and also just consuming less energy in general will allow the clean energy to be used in other areas where it's currently a little more challenging.
And we can only hope that more sources of clean energy start showing up, right? Because again, this is something I've been focusing on. I'm fascinated by it, number one. Unfortunately, power generation is probably one of the largest creators of greenhouse gases. So, and you start going down the path, power generation is dirty, data centers eat tons of power, and so it makes them, like I said, that therein lies the difficulty of them understanding what their carbon footprint actually looks like. Is there any kind of mandate for them to produce this information, or is this all basically a logical adjustment to the way that data centers run?
Well, at the moment, it depends on where the data center is located. We see more regulation on the reporting of these emissions, energy efficiency in the European Union for the moment. We're hoping the United States pushes for more reporting and accountability in that area too, and other places around the world as well. We definitely think we're moving in that direction. I think
right.
Everyone I speak to is actually very concerned about this issue. I think the next couple decades, especially with the ability of AI to help us determine how to run workloads more efficiently, I think it will consume more energy, but it will figure out an efficient way to do so.
Right. Again, it's a fair trade in a lot of ways.
Exactly.
It's been interesting, I've been looking at water too. Water is something that's not often considered as one of the challenges for data centers, but clean water definitely is.
That certainly is.
That's the time we all have today, so thank you so much. It's a pleasure talking to you, sir. Enjoy the rest of the show.
Will do.
And now a word from the folks over at DCK. Each Friday, as your week slows down and the meetings start to trail off, check out our Friday afternoon Data Center Knowledge News Roundup, where our editorial team curates all of the hottest news for you and you just might possibly have missed throughout the week. And now you are our next guest. Are you Raymond?
I am.
Excellent. I finally got that right. It's been an interesting morning so far. Raymond, nice to meet you, sir. You are the Data Center Strategy and Operations Chief over at the University of Chicago.
Close. Yes, I am.
And excellent. And just a quick thing about the University of Chicago. It's a private research facility located in Chicago's Hyde Park, but that's not all. It is located around the world for the most part.
We do have a global presence. Yes.
Yes, exactly. London, Paris, Beijing, Delhi, and Hong Kong. Not to mention your connections between Fermilab and Argonne National.
Yes.
Because again, this is what's fascinating to me is that University of Chicago is where the first atomic pile was built. I knew that back when I was a kid, close to when that actually happened, and it was fascinating to me that under a squash court I can't remember the field, but
Stack Stadium.
Stack Stadium, right, is where the first nuclear reactions actually took place.
First controlled, sustained nuclear reaction was done in a racquetball court, yes.
Pretty fascinating. So ultimately, and looking at it, excuse me, Looking at the way that dealing with the educational environment in general, it seems to me that the university environment can be one of the most complex IT environments that you can imagine. Is that something that you've been experiencing along the way, or are you just steeped in it so much that it's just the way things are?
One way to look at it, IT is IT.
Right.
It doesn't matter what you're doing with it. The difference in the research in the academic world is the volume and the scale that we're doing things at. Traditionally, if you look at hyperscalers, colos, data centers, they're doing small cabinets, 3, 4, 5. In the last couple of years, we've seen that increase. We designed a data center about 10 years ago to operate at 25,000 watts per cabinet.
Wow.
And that was unheard of, but we were planning for it.
Right.
We're now already being told we're running at 25, 35 kW cabinets today.
You could see 50 to 100 in the future.
And we know they're coming right around the corner.
Oh my God. So what does your data center environment look like right now?
So I have, under the university side, we've got 5 separate spaces on campus. One ranges from late 90s, which is our administrative compute, through what we designed, like I just mentioned 10 years ago, our research and high performance data center. And so we got 5 spaces that we manage. I've got, I always get the numbers wrong, 14,000 square feet, 3.5 megawatt of mission critical space. But then some of the divisions still have smaller schools or smaller data centers
Sure.
inside them as well. Little things, 100 watt, 100 kW type things.
Especially when you start talking about some of the research environments that you run into, is that they may have a specific need to match a piece of equipment that they're working on, for example.
A little bit. We don't really see it because compute has become compute. When
Really?
you're looking at DNA sequencers or some more specialized equipment, they're sitting on the network, but they're streaming that data across the network into a storage system
Right.
or to a compute cluster, to one of our high-performance compute clusters.
Right.
So it's as much as the data center, it's the bandwidth on the network that is also key for us.
So the interesting question is it looks like you're basically based in high density urban environments for the most part.
Very much, yes.
So it's interesting, it's like we're looking at a data center environment where the density is compressing so much that you don't need as much space, but you need a lot more resources in terms of dealing with the heat management and everything else involved in it.
Right.
So how difficult has it been to be able to expand or to adjust your environments in all these urban areas?
Well, we're kind of unique in that we have such a large footprint in Hyde Park. We are challenging now to look for the next space.
Right.
And we do have a building. We bought an old AT&T building, or Ameritech. It was one of the very first Ameritech buildings in the city.
Oh, no kidding.
It was very large. Anyway, there's a lot of history behind the building, but we put 3 megawatt of data center in that space.
Wow.
We have figured out how to bring 5 more to that same building.
Oh, no kidding.
The challenge, fortunately with us, we've got central chilling, we've got capacity, easy enough to put in, and Chicago has a lot of power.
Right.
So we can get the power. So from our challenge, it's really been, when do the researchers need it? What is the right size? What is the right type of data center to build? And should we be building a data center?
Right, exactly. Because again, so many cloud resources are available. Where do you see the mix falling for you right now? Is it a majority showing up in the cloud? Is it kind of a mixed bag between on-prem and in the cloud? Again, do you have any kind of idea of where the mix is?
Our mix is really switching. A lot of our administrative compute. When I took over the data centers about 15 years ago at the university, we had about 140 racks of gear. We rapidly collapsed that into about 10.
Wow.
And in the last couple of years, we've collapsed all of that into like a rack and a half.
Wow.
So we're running 3,000 plus machines virtually in a hyperscale environment.
Wow.
What we're seeing is administrative compute, timekeeping systems, payroll, student systems, all those commodity type systems, email, those are becoming SaaS or cloud-based. Where we're seeing still exponential growth is in research. So
Yeah.
quantum computing, supercomputing, and those types of areas. It's still economical for us to do it on-prem.
Sure.
A lot of the colos talk about tax incentives and benefits. We're tax-free, tax
Yeah,
exempt.
exactly. So you
Doesn't
have,
apply.
exactly.
So, and we're also grant-based, and so much of where our funding comes is a 3-year grant or a 4-year grant. The other challenge we have is when that grant money runs out, the colos want us to pay them.
Yes.
And there
Details.
comes a time where we can't.
Yeah,
So
exactly.
We're able to keep those systems running.
So are you getting support from vendors in terms of some of this high-end system? Because again, we're talking about, and it's not difficult to get some serious power in place right now.
Right.
I mean, if you're looking at some of the, like, I'm fascinated by the DGX platform by NVIDIA. You could literally have a supercomputer in about 8 to 10 RU, and then you could stack those things up in cabinets till you get bored. So ultimately, are you finding that vendors are working with you a lot in terms of being able to support this research?
Yes, in a high, the answer is yes.
Right.
Ironically, I've got 4 of the DGX units being delivered.
The most recent one?
Yes.
Excellent.
In fact, I just got text while I was standing waiting in the wings. Are we expecting a delivery today? And I'm like, yeah, I think that's our DGX boxes.
Nice.
But the manufacturers, again, IT is IT from our perspective. And what we're looking at is how do we support, so like you're talking about, high density and power and cooling. Direct DLC cooling coming along. How do we reject that heat?
Right.
We're doing some unique things with rear door heat exchangers and fans that a lot of data centers aren't.
Right.
So my job is to try to be ahead of what's coming and always be prepared for what's coming, and we'd have no idea what's coming.
Right, and then added to the fact that you're also making stuff up as you go along the way, right?
Right.
From a research perspective, it could be anything. I would imagine that a lot of this research, because again, if you're looking back at history, it was mostly bespoke. They would have to design the systems that they needed to be able to do it. Now, again, given the nature of some of these extremely powerful high-density systems, it's just a matter of matching the system to the right thing, because again, we're talking serious horsepower. It's hard to imagine that, you know, what's coming out of these machines right now compared to even 5 years ago.
Yeah.
So,
you would see, as I interrupt you, sorry about that.
that's okay.
Historically, you'd see the university and the researchers would actually write their own code, write their own operating system.
Sure.
Do a whole lot of development work to make the machines do the science that they want.
Right.
And we've seen a trend in the last 15 years where the younger researchers coming in and the postdocs and the PhD students, they don't really care about that because, to your point, so much of this hardware is commoditized.
Right.
They want cycles and they want lots of
Lots
them.
of cycles, right, exactly.
So we've been able to move into a more standard platform, which helps. It's easier for us to support, but at the end of the day, we'll support everything.
Sure. Now, how much communication are you finding between all of these teams? Is there a good process involved in planning this stuff out, or do you still get surprised on a regular basis?
Yes, we still get surprised. We try to get involved. We try to have our researchers involved. But we're an institution that challenges everything.
Right.
It's our core nature to question everything. And we support you questioning everything, but the side note of that is then you better be ready to be challenged, because we're going to challenge everything that you say. But that's our mantra, which makes it an absolutely incredible place to work.
Yeah.
The research community, they're moving so fast and they're so dynamic, and that was the other thing that kind of makes the university unique is we let our researchers, we give them a lot of autonomy.
Yeah.
So we have, over the years, continued to work with them every chance we can to try to be one step ahead of them. So when they're bringing something in, we're prepared, we know where we can put it, we have space, we're not running out of space.
Yeah, so one thing you got a lot of, I bet.
Actually, we don't, surprisingly.
Oh, no kidding.
Yeah, we're actually running out, and we're looking at our next data center, trying to decide where, when, how.
How, right.
But to you were talking with your previous guests about greenhouse and efficiencies and economies. We're also in a similar mode of how do I get rid of the old stuff and get the new stuff in?
Right, exactly.
Because one of the challenges at the university is you literally will have somebody's life's work sitting on a machine,
Oh, no kidding.
who have spent the last 20 years of their life and it's still running on the same machine they bought 20 years ago.
My God.
So we work very closely with them to make sure, yes, it's backed up. Yes,
Yes.
you're getting redundancy. And hey, have you ever thought about upgrading that? Let us help you.
Exactly, but some of these guys will not. I mean, it's amazing how often you run into legacy stuff. Is like, you're seriously still running on that? Yeah, but again, it's one of those things where technology is just, it should enable you. And if
Right.
you're comfortable with working with something, provided it doesn't become end of life or whatever, you
Right.
should be able to continue doing it as long as you're comfortable doing it. And again, this is different in a university environment because if you're in a typical enterprise, no, you should really, enterprise is going to dictate what resources that you have for the most part.
Exactly.
And again, this is where we're talking about a cloud environment where you can pretty much find anything that you want in the cloud. So there's no need to build out a hardware infrastructure on your own environment and you're on-prem. What is are your data centers like? Are they raised floor, typical kind of environments now?
We have a little of everything. We've got traditional raised floor crack unit, perimeter crack unit. We've got pumped refrigerant cooling systems basically on slab. I've got rear door heat exchangers both on raised floor, on slab.
Right.
So
and
we're
again,
cool
that's
of
to deal
everything.
with the density issue, right?
It does.
Because again, you don't, in-rack cooling is something that's been around, in-row cooling has been around for probably a decade and a half.
Yes.
So ultimately, it was easier to be able to place cooling where it was needed. And then the back of rack is also around for that. Are you using chiller for that? For the back of rack stuff?
We're just using passive doors.
Oh, really?
Yeah,
Okay.
And we found we can do up to 34 kW with a passive door.
Seriously,
Yeah.
really? Wow, that's substantial because again, going back in our history, a 5 kW rack was pretty much average.
Right.
And now you're talking about 5 to 10 to 20 times that potentially showing up, especially when you fire up those DGXs because, again, for what they do, it's an awesome
amazing.
trade. Yeah, but for the most part, you're also talking about, and it's hard to get this across to people. I say, oh, it's only a 50 kilowatt rack. Okay, turn on 50 hair dryers and
Right.
stand in front of it. Because again, that's the problem with IT is that in goes energy, out comes heat, and almost a
Right.
perfect mesh.
It's almost 1-to-1.
Yes, exactly. So, I mean, even though the results are cool data, ultimately you have to deal with all of those challenges of getting rid of that heat.
Right.
So, you said that you mix of refrigerant, your mix of, are you also doing evaporative cooling?
So at our chiller plant, we do evaporative. We're trying to, we've actually raised water temperatures.
Oh, okay.
So we're pushing water temperatures up to 59, 60 degrees.
Oh, no kidding.
We've actually had water temps as high as 70 degrees.
Wow.
In some testing and failures.
Well, yeah.
But we've, based on our design in using water in our in-row cooling units, we've been able to use much warmer chilled water. And so we've
Right.
been, over the last couple of years, we've been slowly creeping those numbers up to try to find the sweet spot for us.
Right.
And I don't want to say it's the sweet spot for everybody because you have DR time, response time. In the event, if you're running 70-degree water, your response time to a failure is minutes. Versus maybe an hour or two.
Exactly.
So what's the risk to the IT load that we're trying to balance out?
Wow. And again, these are, because again, the numbers keep going up even though, you're not really increasing the amount of space that you need to actually
Not
do
at all.
that. Right, yeah.
A lot more in a little space.
So, what do you see on the horizon for data center operators? Do you see anything that is like really exciting to you?
Yeah, I think what we're looking at is what we're calling the chillerless data center.
Really?
And that is, how do I put in a supercomputer with no chiller? But the technologies are almost there. When you look at some of the things that the National Renewable Energy Labs are doing, Sandia's doing,
Right.
With direct processor cooling,
Yeah, exactly.
with higher temperatures, being able to raise significantly your ambience and your chilled water.
Right.
We think from a greenhouse gas and emissions, and the list goes on and on. How do we really put all that energy to use? And not only that, is what do I do with all that waste heat? As you just said,
Precisely.
it's 1-to-1.
Right. And if you don't have an option to reuse it for some other purpose, you just got to get rid of it
Right. But why am I just getting rid of it? Why can't I use it
for something else.
for something else?
Exactly.
That where I'm using gas or energy to create. So I think the higher ed environment will have the opportunity to do that, where industry is still very conservative.
Right.
Because they want to make sure they're protected. So we'll see what higher ed does in the next couple of years is to take advantage of all these great technologies.
Sounds absolutely fascinating. Sir, thank you so much for your time today. It's been a pleasure. Have a
Thank
great
you.
day. Enjoy the show.
Thank you.
All right, and back to a word from the folks at DCK. Oops, sorry about that. Tomorrow and Thursday we're going to stream the show floor as we connect on Fast Chats. I'll be doing 2 of those with industry insiders. You don't want to miss it, and of course you can register for the virtual event and the ticket at www.datacenterworld.com. And do we have a next guest? I'm not sure. We're taking a break now, and hallelujah, thank you very much. We'll be back shortly with more fascinating people to talk with. Hello again, and we're back at the news desk at Data Center World. My next guest is going to be an analyst from Omdia. His name is Vladimir Golubov. He's a research director of cloud and data center technologies. Vlad's responsible for the cloud and data center research practices expanding roadmap focused on disruptive trends such as the shift to edge computing, the evolution of compute silicon, and the need for efficiency and improvements in sustainability in the data center technology. Welcome, Vlad.
Hi.
Pleasure to meet you.
You too.
We're in a fascinating point of time today. I mean,
Yes.
if you look at the way that data centers have evolved over the last couple of decades, because I've been around to see that crazy stuff.
Yeah.
Ultimately, now we're at a point where compute has evolved to such a massive point that it's no longer the sticking point in terms of IT.
Yeah.
You know, it's easy to get a server with dozens or even hundreds of CPU cores.
Yes.
And the big challenge then is being able to be efficient in distributing all of that processing
Yes.
power. We're also seeing that efficiency being moved out into the operations of the data center in general.
Yes.
Because as we looked at it, data centers have been slowly compressing in size, but expanding dramatically in terms of heat, power.
Absolutely.
It's the challenges. So you've been focusing on, I guess the first thing we want to talk about is, and this is something is the way that the industry has been challenged by COVID. Because again, COVID is something that really put a wrench in a lot of companies' plans. I
Yes.
mean, they may have planned to do expansions, they may have planned to do certain things. From an IoT perspective, I think that it put the brakes on IoT development as well. Or do you think that it actually improved the environment?
That's a very good question. I think it kind of depends in a way on the company. So we've met some companies who said that during COVID, they had some staffing challenges.
Right.
So one way to solve staffing challenges in data centers was to deploy more sensors. And there was a lot of very interesting innovation that I saw. So there was some I recently met with a startup in Israel, and they basically were inspired during COVID and the staffing shortage to create a camera that also has sensors on it, but it also can go and inspect the data center instead of a staff.
Oh, no kidding.
So it's actually also a drone.
I was
So
going to say, it
comes
had to
from
be a
the
drone to
ceiling
be.
and then it flies around. So I think that actually what COVID did is it did make people more creative, right? Because they would have a staffing challenge. The Great Resignation is real, by the way, absolutely. And as a result, people, I think, got a little bit smarter. Now, there is no question that some projects were delayed.
Right.
We did see that some enterprises really struggled during COVID. It really depends on your industry. So I think if your industry was related to helping people survive at home,
Right.
so if you're, a e-commerce, for example, absolutely huge improvement during COVID in terms of how you operate your supply chain and your data center, by the way, as well.
Right.
But if you were an industry that was impacted by COVID, that maybe before COVID was an innovator in IoT,
Right.
say the airline industry, incredible innovator in IoT before COVID, but during COVID, companies barely survived.
Everything shut down, right?
Exactly. So I do think I have seen both kind of some levels of acceleration and some levels of deceleration. Within the data center, I actually would say that COVID inspired the use of IoT more than before.
Well, exactly, because we had no choice but to distribute
didn't.
the way that we offer our
Absolutely.
services, right?
Absolutely, yeah.
So this is, and again, I've been following IoT like
Yes.
you for 5 or 6
Yes.
years now. And obviously there's two IoTs. There's industrial IoT,
Yes.
which has been around a long time. And then there's IoT in the context of either the consumer market or the enterprise market as it evolved. Because again, COVID changed things in that regard. But the thing that I always found fascinating is figuring out where the edge is. And they talk about the edge as if it's something that you
do.
can point your finger to.
Oh my God, yes.
But it's not. What's your definition? Where do you think the edge is?
Okay, so that's a very good question. So I think that there are, to me, I look at the problem in two ways, and I think it's important. So the edge really is the need to put computing close to the end user or device because the application is, the performance is dependent on the latency.
Right.
So the perfect example of the edge is whenever you use a server to support radio equipment, the latency is non-existent. It has to
Right.
be near zero. So from that perspective, you don't have a choice but to put the computing in the edge. Now, what people, and cinemas, retail stores, shopping malls, right, hospitals, these are very mature environments where there would be multiple levels of edge computing, right? There might be some smart routers, there might be some computers, there might be some servers. Now, so the edge is kind of mature. The problem is that I think my clients as an analyst often think about what is the new opportunity at the edge. Now, the new opportunity at the edge, that is very different from what is the edge. The edge is a very mature environment, and some of the edge is actually moving to the cloud. So the question is, how do you grasp the new equipment?
Right.
And I think there are a lot of new use cases. We see them all the time. But as analysts, we try to give very practical examples of what are the immature parts of the edge that are maturing, and those exist. But they're not. But broadly, the edge is mature. So one of the immature parts is actually the radio access network, right? So virtualizing some of the functions that are done. There is a huge kind of smart city edge that is fairly mature.
And are we seeing growth in the smart city
area?
Oh
my God, absolutely.
Seriously,
so
wow.
I just came back from China, for me it was a very interesting experience. I think that, as you know, they are a little bit more frivolous in their use of, let's say, surveillance equipment.
Sure.
But also within their smart cities, they have a very similar challenge as that we have here and in the UK where I'm based. Lack of people, right? In terms of being able to operate, like not enough police people, not enough people that maintain the streets. So what some of the cities in China do is they constantly map, potholes. Is there a need to fix something?
Oh wow.
And some of the checking whether your car has paid its, tax for the road. Everything is done with cameras and smart cameras. And I just thought that is fantastic and just such an example of smart city. And other stuff that they look at is, traffic. What's the fastest way to move here and there and guide some of the public transport? I mean, in many ways, that is just the type of IoT that makes our life easier as individuals. It makes our cities cleaner and safer. And I actually tend to think that has arrived and it is growing fast. I think that it's going to grow at different paces at different places. Because it's expensive. It's a big investment.
But again, this is one of these things where the more that it gets adopted, the more it's available, the wider the product options are. And again, every technology goes through these growth phases.
Yes.
Right. And again, going back to it, because from a consumer standpoint, it's just ubiquitous. I mean, and you from the UK, talk about coverage in terms of cameras in London.
Yes.
I was in London a couple of years back, and it's like, wow, they're all over the place.
They're all over the place.
And again, as they should be. I mean, ultimately, if you look at the safety of a large city like London, the needs to be able to provide the services, goods, and protections necessary for it, I can understand where it would fit perfectly on that.
And the camera is cheaper than a policeman. I think that is the essence of it, right? Even if investment in IoT is a lot, it is actually worth it. So I think very often it's this example of like high ROI, right? This is the edge that is growing the fastest, and it absolutely is there. So we are seeing quite a lot of very, very interesting use cases.
And again, this is something where, and going back to the edge, because when I looked at the problem about the edge, to me, I always said the edge is where the latency and horsepower needed to be managed, right? So again, it may not be a physical location, it is the area where the data first affects a decision. And that's always difficult, right? I mean, it depends on it. Say for example, in a smart car, the data processing is so theoretically a smart car is its own edge because it has a mini supercomputer that does all of the managing, monitoring, and data. So then it becomes a data transfer issue rather than a computational issue.
Oh yes, there's basically several different reasons why you would do something at the edge. So latency and latency that impacts the computational performance is one. Data gravity is a really big driver.
Oh, huge.
A lot of our clients that have asked for advice on kind of their strategy. They are running, say for example, an oil rig, and they just have so much data that they would need like these huge trucks of like a storage from Amazon to come and kind of take it. So what they found is that it's better to do your computing at the edge so that you don't move the data. So the data gravity became the issue. So data gravity, security is another one, of course. Many banks have a security kind of driver and a regulation of
Sure.
the driver for why their computers at the edge. So there's kind of some very specific drivers like that would encourage you to deploy it.
Right. Because, I always found it interesting when we first started talking about the edge probably 5 or 6 years ago. We started seeing vendors coming up with, well, we have an edge solution server for you. It's like, it's a server, my friends.
It is.
I mean, what I could not imagine, unless there was a specialized, say for example, co-processing for signal processing or something like that. That might be a quote unquote specialized edge, but they're just selling servers and saying
Absolutely.
it's an edge, and it didn't make any sense to me. Because to me, ultimately, you have to look at what the application is. So the location doesn't drive it as much as the applications
Absolutely.
needs drive it.
Great observation. So most of the servers at the edge are your regular, same as the data center server. Now there are some very unique environments, right? So some of the telecommunication edge has perhaps the need for an antenna with its own wireless. Some of the servers that go on ships might have need for satellite connectivity.
Sure.
But broadly speaking, like let's say the lion's share of the servers at the edge and even the regular computers at the edge are exactly the same as
Right.
what we would use at a data center at home
Precisely.
or in our office. There just isn't the need to over-engineer something.
Right.
And what I have also found very interesting is even in some of the more, should we say, challenging environments where there is a lot of dust, a lot of heat,
Sure.
vendors have been very inventive with chassis
Sure.
enclosures that help you to actually have a data center grade environment even at a antenna.
Exactly.
So that actually has ensured that some of the form factor evolution hasn't happened because we've figured out how through enclosures we can address it.
Exactly, and it's one of those, because again, that's not a new technology. We were seeing semi-trailer based data centers
Yes, absolutely.
20 years ago.
Yes,
Because again, it
yes.
was just the rare occurrences where you needed it for emergency
Yes.
purposes or whatever. But now, if you're talking about, and again, this I also found as a conundrum for Edge is that we've spent the last 2 decades building beautiful, expensive, carefully crafted data centers, and now we just want to grab that stuff and toss it anywhere. I don't think that's the way that it should work. But now that we're seeing, like you say, the micro data center, we're talking about edge-based data centers that include things like data redundancy, power redundancy, cooling redundancy. Because again, that's what makes a data center. It's not just a place where you put computers. It's a site that is specifically designed to deal with the challenges of computing.
Yes, high reliability, and people I think what is available today as the options, what we've seen in Omdia is incredible.
Right.
You can go from a credit card sized, phone sized PC at the edge. It can go very little to, you have your kind of edge server, then you can have a micro data center. It's like a rack that's in a special enclosure.
Sure.
Of course, then you have, these prefabricated modular data centers are becoming very mature. I recently was in a 1 megawatt prefabricated modular data center. That's
Really?
liquid cooled.
How many units was
Fully.
it? Was it?
100 servers, fully liquid cooled.
Oh, no
it was,
kidding.
It was beautiful to see. to be
Wow.
honest.
You gotta be impressed by stuff. I
yes.
mean, the engineering that goes into thinking through all of
Yes.
that, and the miniaturization that's involved in services
Yes.
and resources.
Yes.
What was the application for that? Just out of curiosity.
Actually, it was top secret, so I couldn't
Okay,
tell you.
fair enough.
I believe that it was a research institute in Europe because it was in Barcelona, but it was fantastic.
Okay. Well, we've reached the end of our time today. Vlad, it's been a pleasure talking to you,
too.
sir. Let's keep computing, right?
Yes.
Have yourself a great day.
Thank you.
Thank you. And now we're going to take a bit of a break, and we'll be talking to you very shortly. Thank you very much. Welcome back, everybody. And today I have the pleasure of speaking with Dr. Moises Levy. Is that correct? Moises Levy. He leads data center power and cooling research at Omdia. He's a seasoned engineer, a data center subject matter expert, a trusted advisor, and an entrepreneur. 25 years of professional experience in infrastructure products, in the industry in general, and he has a diverse background in planning, design, management, risk assessment, commissioning audits, strategic consulting of engineering projects, and he's a man after my own heart. And in addition, he's a researcher and a contributor to the standards bodies, covering a number and authors a number of publications, as a regular speaker at major data center conferences. Hello, Moises. Pleasure to talk to you, sir.
Thank you. The pleasure is mine.
That this is a data center conference, we're looking at ways of strategizing how companies can be more effective, how data centers can be more sustainable, and ultimately dealing with the new challenges of the way that hardware is evolving in such a way that keeping up with it from a power and cooling perspective can be a real nightmare.
Absolutely, that's a great question. And it's also a broad scope because nowadays we are looking into more efficient and more sustainable data centers. But what does it mean? At least to me, efficiency, sustainability, productivity, operation are part of performance. So we're looking into highly performance and lower risk data centers. But most of the people nowadays are talking about sustainability. What is that? I will try to make this in simple words. Sustainability is about reducing greenhouse gas emissions. But how can we achieve that? There are different strategies that nowadays data center stakeholders are targeting. For example, they are using more efficient IT equipment, more efficient physical infrastructure equipment like UPS, cooling system. For example, new technologies nowadays, it's a driver for more sustainable data centers. One technology that I would like to mention is liquid cooling. That will enable us to improve the effectiveness of how we use the energy. So if we use liquid cooling, we can be more efficient. And at the end of the day, if we are reducing our energy consumption, we will be reducing greenhouse emissions. But also we have to take into account other concepts about the circularity, circular economy. What it means, like how about recycling or trying to use a second life, giving second life to equipment. When I mean equipment, I mean IT equipment, namely servers, storage, networking, and also physical infrastructure, UPS, PDUs, RPPs, cooling system. And also another enabler for sustainability is automation, because we need to collect data, and to collect data in real time to really understand what we are doing. And I would like to mention like data center as any other facility when we build it. As the Greek and Romans said, there are three basic principles: firmitas, utilitas, venustas. And I would like to emphasize utilitas. Why are we building data centers? Mainly to process, store, and share data centers. And in addition, we live and breathe by a word, reliability. We want highly reliable data centers, but nowadays we want more efficient and more sustainable. So we are targeting different strategies, as I mentioned. Other strategies could be microgrids. Let's say, for example, we can be powering our data center with energy coming closer to the facility. Sorry. So we'll be reducing distribution losses. So there are multiple strategies using more sustainable energy resources, integrating renewable energy resources into the power equation. For example, more wind farms, more solar power, more geothermal, hydropower, and so on. Changing our fuels of our gensets, maybe using natural gas or HBO or more sustainable fluids or fuels, and so on. So I am a great believer that new technologies are enabling more sustainable data centers, but also automation and data-driven decisions are key to achieve those goals.
We're kind of in the second stage, or maybe fourth stage or whatever, of data center progress, and it's nice to see that a lot of the focus is on being more efficient and actually dealing with sustainability, because we live in a world where there's a limited number of resources. Now, you mentioned liquid cooling. Obviously, I would think from an efficiency standpoint, a directly liquid cooled environment is the most efficient, but then not having that, you're still dealing with the refrigerator type data center. Ultimately, how do we become more efficient in that? Because the challenge of data centers is that they eat electricity, they generate heat, and that's almost a one-to-one basis. How do you reduce both of those?
Yeah, that's a very good point. It's about resource utilization. We need to optimize resource utilization, and as I mentioned before, data centers are related to workload. So it's about workload management and it's about resource utilization. We need to optimize those. But it's a multi-parameter optimization strategy. It's not only about one parameter. It's like a non-linear equation where we are dealing with cost, with operation, with efficiency, with reliability, and cooling, and so on. So, for example, liquid cooling nowadays, independently if it is direct-to-chip or immersion liquid cooling, is a very promising technology. I'm a great believer that now we are at an inflection point to use that technology for a specific application, but not for the broader data center market yet. What it means that nowadays the manufacturers are providing us power-hungry servers. What it means, for example, the latest NVIDIA Grace Hopper, what they call super chip, is consuming about 1 kilowatt, and the next gen is expected to consume 1.5 kilowatts. How are we dealing with those new super chips to be air cooled? There are not so many options, so we are going to move those to liquid cool. The main target for that technology are servers with coprocessors.
Right.
What I meant, is that the main of all the data centers? Not really, but we need to satisfy those fast-growing workloads, like for example, AI, ChatGPT, and so on. And nowadays, we need to keep in mind, like the global economy is a digital economy.
Right.
Data centers are going to be here.
So, and ultimately, a lot of the challenge in technology is proximity to, whether it's proximity to a heat source, proximity and reduced latency within the environment itself. Ultimately, like you said at the beginning, there are multiple facets that you have to take into account. Efficiency is one of them, but it's also a matter of continued reliability. It's a matter, again, of sustainability, and that's tied to efficiency. Ultimately, it's refreshing to see that the industry is looking at sustainability and being more efficient, because ultimately, not only is it good for the world, it's good for them because it results in less costs.
Yeah, and we're very lucky that we're an industry with high-skilled professionals, so we can look to other alternatives. For example, grid interactive UPSs are enabling to integrate renewable energy resources into the power equation. In addition, other technologies, there are numerous technologies. For example, you mentioned something very meaningful about what about the waste, the heat that we are producing. So one target that there is a lot of research nowadays going on is about heat reuse.
Right.
But as you can imagine, if you are producing heat in your data center, it's a challenge to transport that heat to be reused far away.
Right.
So we are looking to our neighbors, so we need to communicate to them. For me, the main message for data centers stakeholders about sustainability is we should add more transparency. So there will be not a disconnect between intentions and actions.
Right.
So we need more transparency. This industry is doing a lot, but there is a lot of room for more to be done.
And an interesting point and something that I've focused on recently is the amount of water that's consumed by data centers. And the problem is again, looking at a data center, it eats electricity, generates heat. All of the work is just basically inconsequential. It's a 1-to-1 almost ratio. So the problem is, how do you do this cooling? Now, you mentioned liquid cooling, and ultimately the vast majority of high density data centers are using evaporative cooling technologies, which are unfortunately very energy efficient, but very water inefficient. So I did a piece recently, and that's going to be showing up in the next digest, is we're talking about data centers that are consuming on the order of 1.5 billion gallons of water a year. And these are being placed in areas that are already experiencing water shortages and water difficulties. How do we move away from the idea that water's just not an issue? Water is a serious issue in a lot of parts of the world.
Absolutely. You touched a very good point. You touched it previously, but I didn't mention it. Water is another constraint. When we talk about sustainability, it's about water consumption. Nowadays, we're looking also to air cooling options, but with no water, or mainly no extra water consumption with closed loop system and so on. But absolutely, liquid cooling is a very promising technology.
Sure.
Because it's reducing or even eliminating the use of water in the data center. And that is one of the main drivers of this technology. And also it's about embodied carbon, it's about life cycle assessment. So when we talk about sustainability, it's a very broad aspect. And we need to do better. We need to keep in mind that we will be leaving this for the next generation, for our kids.
And you have a few little ones that you're thinking about, right?
Absolutely. So they will be in charge, and I'm confident that next generation will do better, but we need to keep up the good work.
I'm glad that smart people like you are on the problem. Moises, it's been a pleasure, sir. Thank you very much. Enjoy the rest of the show.
Absolutely. Thank you, and it's always a pleasure. And I would like to encourage new generation to be involved in our data center industry.
Absolutely.
Thank you.
All right, and now a word from our sponsors again. Data Center Knowledge has partnered with AFCOM to interview 4 of DCM's keynote speakers. We'll be talking with Compass Data Center CEO Chris Cosby, Oracle Industry Labs Burson, and I'm not going to get it right, and author and futurist Clan Gohar, and Cloudflare's Rebecca Weekly. Check out one of those one-on-one interviews with DCW's own Master of Ceremonies, Bill Clayman, and AFCOM's Jordan Sutliff. And now, today we have, and forgive me, I'm still behind here, you're Ellen Howard.
Yes. Steve.
Excellent, from Omdia. Steve Hill, how do you do?
Good, nice to meet you.
Nice to meet you too.
Yeah.
And another analyst. I mean, I've been an analyst for quite a long time, and it's always a fascinating pursuit looking at what analysts do. And in your case, Alan focuses on cloud and co-location service provider markets, covers service revenues, data center locations and new construction, and the distribution of data center CapEx. Coverage includes current service provider revenue performance, service offering trends and insights, and data center construction and expansion. So, it's quite a handful there, right?
It's a lot there. Yeah.
I mean, ultimately, the interesting thing about being an analyst is not only looking at the technology, but the business of technology.
Yeah.
Because ultimately, the two are tied together. So where do you find most of your research goes into? Is it mostly following the market and the way that it's evolving? Or do you find spending as much time looking at the way the technology is evolving?
You know, for my coverage area, I mean, a large portion of it is really tracking the market. So tracking the individual companies, their data centers, their financials, things of that nature. So in terms of technology, I work with a team of very bright analysts that track a combination of physical infrastructure technology along with IT infrastructure technology. And so we get to collaborate on those things together. But I think in my line of work, I think one of the more exciting things that I get to do is, I get paid to look into new things, start studying things and researching things that, might not, come up to the top right away.
Right.
So, just as an example, we've been doing some research and publishing on nuclear power, SMRs, as a way of managing power availability, in the future.
And it's nice to see it back. I mean, the nuclear industry had a really bad series of issues. But again, nuclear actually represents one of the most efficient models and typically one of the safest models for energy production. However, of course, it involves nuclear materials, which have to be addressed.
Right. Although, just staying on the nuclear subject for just a minute, I want to give a shout out to Rich Miller. It was funny. Rich Miller, as much of our audience probably knows, founded Data Center Knowledge a long time ago. And
right.
He wrote an article in 2008 on nuclear small modular reactors as it applies to the data center industry. So it's just in terms of nuclear, it's not new. It's been around for a while, and so like I said, shout out to Rich for covering that.
Exactly.
Was that 14 years ago?
Yep. And the nice thing is they're getting smaller in terms of concept. Ultimately, there's a lot of energy to be tapped, and you don't need to have, a 50-acre facility to be able to do things that can actually be utilized for a number of use cases that aren't the same as what we're looking for. Plus, again, the efficiencies, right?
Yeah.
I don't know what early nuclear plants were around the 20 to 100 megawatt range.
Possibly.
Yeah, again, there's vary so much. I grew up near two of them, so I hadn't focused on it a lot because, again, throughout the 60s and 70s, nuclear power got some really bad press out of it. And again, it's from our own fault, because again, we had some pretty substantial issues that occurred in the 70s and 80s. But that being said, the challenge for data centers is that they're major power consumers. That's what they do.
Right.
They consume energy and generate heat and produce data, which is awesome, but it's only a small factor of the physical process of running a data center. So the next challenge that I've been looking into and I've been seeing is how to how do you locate your new data center? What considerations do you have to have for placing a data center in the US today?
Well, there's a long laundry list. It all obviously really depends on who your target customer base is.
Sure.
And what kind of services you're trying to deliver. So primarily if we look at the amount of CapEx that's being spent, we'll just focus on the United States for a minute. It's still going into tier one major markets where a majority of the growth is. But more and more, service providers are spreading around.
Right.
The country into different areas. But let's divide it into two groups.
Sure.
So if we look at the co-location market, of course they are typically trying to locate in markets where there is a known customer base or a potential customer base. Okay, so that keeps us in primary tier one and tier two markets. Now that said, some of them go a little bit off the rails. So for example, a couple of years ago, CyrusOne built a pretty big campus, and I can't remember the Midwest state it was in, but a couple of the hyperscalers were going in there.
Right.
And CyrusOne decided, you know what, this is a good place to go, because there's an interesting dynamic in the cloud business. Google, Amazon, Microsoft, and Meta build data centers. They lease a lot of co-location space, but they're known for big data center construction programs.
Right.
But then a lot of their competitors, IBM, Oracle, Salesforce, SAP, there's a long list of them, they typically lean on co-location.
Yeah.
And so
why pay for real estate that you don't need, or might vary pretty dramatically?
Exactly. But if some of my biggest competitors, Amazon, Google, Microsoft, and Meta, kind of a competitor, are going into a particular market, then there's services to be sold to those tier 2 cloud service providers, and that's where co-location comes in.
Right.
So that's kind of the co-location market. On the cloud side, it's really different. If they need something in downtown Dallas or Chicago or New York, they're typically going to go co-location. And so Amazon local zones are a great example of that, because they don't want to build in downtown New York, but it's a perfect place to use co-location for a local zone.
Right.
Otherwise, they're building out in the middle of nowhere.
Yeah.
And-
Because
and-
again, proximity isn't an issue for a lot of things.
For a lot of that, yeah, it's not latency sensitive. And there's
Right.
a large volume of processing that goes on that doesn't require a latency sensitive positioned data set.
Right.
Right. But the other thing is that these hyperscalers are building at such scale that they need a lot of space. So they're building great big campuses, sometimes over, up to 2 million square feet.
Right.
So we see a lot of them going out into Midwest states, southern states, Georgia, Tennessee, places like that. And so there's ample land in the right places. There's ample fiber running.
Right.
The power rates are competitive.
Reasonable. Right.
Reasonable, yeah, exactly. And the other thing too is that many of those states are really looking to attract that kind of, any kind of business of that scale.
Exactly.
We all know that data centers don't employ that many people, but the construction, the long-term tax benefits are good. But the point of where I'm going with this is that, anytime they go to build one of those big scale data center projects, if the state doesn't have statutory tax incentives, then they negotiate with the local government.
Sure.
And that's who gets those deals. In other words, tax incentives play a very big role in where they locate their
Seems
data
to make
centers.
perfect sense.
Yeah.
Another interesting thing that I've been covering recently is water usage. This
Yeah.
is something that people don't realize. Data centers are very water thirsty. I mean, if you talk about a big mega scaler like an Amazon or a Google or even Meta, they're building one in Mesa, Arizona, of all places, that is going to pull about 1.5 to 1.9 billion gallons of water a year. That is a lot of water out of a place that really has some challenges. Mesa is not water friendly, as it were.
Yeah.
So again, how do they make these decisions in terms of placing it when it comes to the natural resources like that? Are they aware of this, or is it just they're using other issues that they seem to be more important to them?
Well, there's a number of things there, and a lot that I won't be able to cover. But
Fair enough.
First of all, I live close to Mesa, Arizona. I'm in Phoenix, and so the water issue in the Southwest in general is significant. And I'll tell you that the city of Chandler, Arizona. Well, first of all, Arizona, the cities in the metropolitan Phoenix area adopted statutory tax incentives to attract data centers.
Sure.
And Digital Realty and Cyrus One, we're out in Chandler, Arizona. And as they expanded, more companies came in, and then Chandler put the brakes on data centers because it was a water issue.
Right.
It was a water issue. So, a couple of things. I mean, I think on the one hand, there's a reckoning coming in a variety of markets around the globe. I mean, particularly in the Southwest, California, for example. It's hard to tell how it's going to evolve and what's going to be the upshot, in the end. And so for a project like the one you're talking about, the city is making decisions based on long-term water planning and how focused they are on getting a data center in there. But you know what? There's so much unknown.
Right.
That's really kind of the issue, and that's why I say that I think, eventually there'll be a reckoning in some of these markets.
Absolutely.
But at the same time, I would say that I would be shocked if these operators of these huge data centers aren't looking into the future and saying, what happens when?
When? Yeah, because ultimately, you can't argue with the math and the science of it, right?
Yeah.
I mean, it was interesting. I've got a piece that's going to be published in the next AFCOM journal about this exact issue, and I pulled up 2 world maps, and I mapped where there is water shortages, water stress in the world, and then I mapped where the data centers are built. And the data centers are not to blame for the water shortages. It just so
Right.
happens that they're being built in areas where water is going to become, if it's not already, a serious issue.
Yeah.
And again, this hopefully is part of the planning that companies go through when they make their decisions in terms of placing. Now, again, it really depends on the type of environment when you're talking about a mega scale cloud data center versus a generalized colo or even a generalized privately owned data center facility.
Yeah.
But the problems are the same. Again, energy, electricity equals heat equals, oh Lord, what am I going to do with all of this heat, right? So ultimately, how it's
Well, sorry to interrupt you. Let's back
Sure.
up for a second. So, when we're talking about, I forgot, we're talking about Meta in Mesa.
sure, right, exactly.
Yeah. So, of course, I mean, that's been some interesting big news recently. Between 3Q22 and 4Q22, they made this decision to put this big pause on their data center construction.
Right.
And so that came out to be roughly about a $4 billion drop.
Shift, right?
Yeah, shift in their capital expenditures. Now, the funny thing is, and one of the reasons for this is that, their big shift to artificial intelligence. Now, you've seen the numbers that
Oh, yeah.
they're going to get a certain amount of water, but one would think that, if we're working on an AI intensive deployment, we'd be looking at more liquid cooling.
Right.
So there's something. I'm not pointing fingers at Meta, but the other thing that came out in 1Q23 is that the CFO during their 1Q23 earnings call was saying, these new data centers that we're building to handle artificial intelligence, pardon me, they're in the works.
Right.
So they're not going to open for 2 to 3 years, which
Sure.
is the construction cycle, which, again, I'm not just reading between the lines here. The pause in data center construction implies we've got plenty of capacity, perhaps we've overbuilt some,
Right.
and now we're going to re-architect, and it'll be a while before we start deploying more heavily AI-intense capacity.
And that's an interesting point because when you look at the way that the market evolves based on things like AI, everybody tries to anticipate where it's going to go, but ultimately, AI is still a relatively gray space. I mean,
Yeah.
everybody's using it. It's the big buzzword right now. Ultimately, we could spend an hour debating what AI actually is, but when you start talking about the systems that are required to run it, again, big systems from companies like NVIDIA, they are, like I say, major power consumers.
Mm-hmm.
And again, in very tight, and it's a fair trade. I really believe that the amount of processing that you can get out of one of these DGX boxes is plenty of a fair trade over the amount of electricity they use, because ultimately that's the same philosophy, the same engineering that they use to build the biggest supercomputers on Earth.
Right.
But they're putting it into an 8U box or putting it into a rack of these things. They may generate a lot of heat, they may draw electricity, but man, talk about the amount of performance that they can get out of these new systems.
It's hard to fathom.
Yeah, exactly. So, and again, to be fair to them, it's like, would we rather not have that and instead keep running it on older machines or traditional technologies, or do we keep advancing even though it involves a cost and a new challenge in terms of resource planning and management?
Yeah. Interesting.
So it's, I don't envy some of these companies. And again, I believe part of Meta's problems were issues with metaverse. They didn't get what they were hoping out of that. And it's true of every company. I mean, because like you mentioned, there's a 2-year, 3-year lead time between when you specify doing this, and you can perfectly cost justify it at that point. And then in that 3-year lead time, the market shifts, and then what do you do with it?
Well, yeah, I mean, the thing is that a combination of information technology evolution and the data center construction evolution, so much can change in just a year and a half or 2 years.
Absolutely.
Right? And so often the best laid plans, right? We get out to where we're trying to go. We've made adjustments and structure changes along the way to accommodate changes in the market. So
Right.
it's hard to tell where we're going to be. And
But-
that's the other thing about water is that it's hard to tell, man. I mean, anyway.
Well, yeah, it's an interesting part of the factor that honestly wasn't being considered. I grew up in the Midwest, and water is never an issue. I grew up in sight of Lake Michigan. and I looked at it, it's got 1 trillion gallons of water in it. I read something that you'd have to take out 2 billion gallons of water for the water level to drop 1 inch. 2 billion or 5 billion, some crazy number.
Well, hyperscaler could take care of that.
Oh, sure. We'll just put them all, along Lake Michigan shoreline. Well, and again, you see that looking where, because, and I'll pick on, and I'm not pick on, is that I'm fascinated by what Switch has done. If you're familiar with Switch,
Oh, yeah.
They've built beautiful data centers in Reno, and good grief, the SuperNap in Las Vegas. And they are utilizing all the different aspects that available in the area, where it's evaporative cooling. They're looking at alternative energy resources. They look at all the different facets of building out a very large scale environment, and they're talking about millions of square feet. And the fact of the matter is that they're doing this in areas that have challenges. In fact, they're looking at being water positive at a certain point. How they'll do that, I have no idea, because literally, most of the water does not come from surface water, comes from aquifers deep in the ground.
Right.
And they don't replenish as fast as, say, Lake Mead does. And we both know where Lake Mead is at right now.
Yeah, it's kind of a wreck.
Well,
But, just speaking about cooling technology, in general, I mean, there's the market is very, very active in terms of advances in cooling technology, right? Not just liquid. And when liquid cooling, we're obviously talking about direct-to-chip and immersion cooling.
Sure.
I'm sure Moises and you had a great conversation.
Yeah, we
about
did.
that. Yeah. But there's other things too, and running a data center in Arizona where I live, or in Las Vegas where Switch is, there's
Sure.
lots of different things you can do to mitigate, the expense and just the overall cost of cooling. So at Switch, for example, I mean, I toured one of their super naps a few years ago in Las Vegas. They've got this custom patented cooling technology that they use. So they're real high density areas,
Yep.
use chimneys. They've got this incredible roof plenum
Yep.
for circulating air.
They're not just a data center, they're a data center machine, I call it.
Yeah.
It's
Yeah,
a
yeah.
data center hosting machine.
But I mean, there's so many other companies that are doing innovative things. So Align Data Centers, for example, has a very innovative cooling design in their data centers that uses what they refer to as a fan wall.
Sure.
I couldn't describe the exact technical details, but then Meta too. If you look at Meta's data center designs, with the second story they use for circulating air,
Right.
they're still consuming water and whatnot, but highly efficient. And obviously, everybody knows that you look at the PUEs for some of these hyperscalers, and they're insane. Less than 1.2. I would toss in that, when we talk about co-location data centers like Switch and everybody else, they're at the
Different
mercy of their
factor.
customer deployments. Yeah, so they'll do the best they can with their PUE. They create a lot of operational rules for their clients about the ways racks face, dampers they have to have on stuff. But at any rate, there is a lot of innovation going on, and hopefully that will. We'll see in a few years where that goes in terms of controlling water
Exactly.
usage.
Again, I find it satisfying that it's actually front of mind, that they're actually looking to be more efficient. And it sounds like when I talk about these big facilities, I'm not picking on them. It is what it is. They need what they need. And again, the fact that they're mindful of it, that they're actually, I think that they're being as efficient as they possibly can, because it's in their best interest too.
Oh, certainly.
Again,
yeah.
sometimes physics is the law, like they say, right?
Yeah,
You can't break the law of physics no matter what you do. So,
Exactly.
So it's a fascinating time for data centers purely because the environment has changed, the scale has changed so dramatically, but then there's also tools and resources that allow you to control this and monitor this more closely. So now, what role do you think that DCIM and other data center management platforms play in this? Are you finding, and again, I don't know how often you cover this area, but are you finding that companies are keeping extremely good track of their resource utilization?
That's a good one, Steve. I mean, it depends on what areas we're talking about, what kind of companies we're talking about. You know, when we talk about enterprise, either enterprise data centers or enterprise deployments inside colocation, you know, there's some very smart people that do a very good job at it. But overall, the broader market is doing a very pathetic job at monitoring, particularly, you know, IT infrastructure resource utilization.
Right.
And you know, from a sustainability perspective, we're talking about this at DC Build this morning. That lack of understanding is one of the biggest killers of sustainability. In other words, if you could just increase the resource utilization of not just your IT infrastructure, but your data center space, that's in fact, maybe it was Chris Crosby from Compass that was talking about that at the keynote. Yeah,
right.
Yeah. But that's one of the greatest things you could do to improve sustainability. Is just
know what's going on.
Yeah, just know what's going on.
You can't fix what you can't see, is the way I say it.
Exactly. But the other thing I would say is that, you know, obviously the hyperscalers are deep into this. I couldn't tell you exactly what their software deployments are that manage that stuff. Although, I don't know, a year or so ago, I watched Peter DeSantis from AWS talk about some of the monitoring and software stuff they do to monitor and manage their data center environments.
Right.
Super fascinating. That kind of video is available from their reInvent event.
Right.
But in general, the other thing I think that is really fascinating is that, you know, as the co-location market has evolved, right? I mean, in the old days, co-location was a space and power paradigm.
Right.
That was it. And as time went on, interconnection became critical mass.
Right.
And so now you have to be space, power, and interconnection, and deep interconnection. But the other part of the evolution too is that as co-location has finally gotten more momentum in the marketplace,
Sure.
right, they found, I mean, the majority of companies have found that they have to offer things that their customers feel like they can find everything in one place. So for example, co-location companies, as a general rule, don't provide a lot of specific managed services, right? But they've developed these partner ecosystems.
Sure.
Right? And so in some place, for some data center companies like CoreSite, for example, they have a partner marketplace where a client can go and find somebody that provides backup as a service, security,
And that's been
whatever.
kind of vetted by their colo provider.
Yeah,
Right.
exactly. Anyways, where I'm going with it is the conversation was about monitoring and
Sure.
managing, and that's one thing that I think still has a lot of room to evolve.
Right.
So, you know, one of the things that the colo providers have been doing is building dashboards and ways to interface with their customers. Right?
Sure.
And so some of those are ordering things, some are real-time self-provisioning of cross-connects, whatever. But the other one is monitoring and management of physical infrastructure, efficiency, power usage, and things like that.
Right.
And that's very early stages. In fact, if I recall, I think QTS has a pretty comprehensive platform. But off the top of my head, I couldn't quote exactly, you know, who else. I would imagine Digital and Equinix, you know, have something along those lines. And,
Sure.
whatnot. But yeah, I think that from a co-location standpoint,
And it's a
That's
new
a-
area that has a lot of potential to be pursued.
yeah, and you know, we've talked about DCIM for a long time, but it really hasn't evolved. And you know, one of the issues is that you got to get down to the point. I mean, depending on what you want to manage, you can manage the physical infrastructure or the IT infrastructure. When you get right down to the rack level, you know, now we're talking about having equipment that is outfitted with sensors, you know, that are all, you know, IP set up and whatnot. So, yeah, there's some evolution to go there before
Sure.
we get that kind of comprehensive built-in monitoring and management.
And again, I agree with you that a mega scaler has a different set of considerations and criteria.
Yeah.
And they can look at their environment and say, wow, a 2% increase in efficiency here is going to equal this in the bottom line.
Yeah.
Because they know, I mean, believe me, I'm sure they know. But if you talk about a colo environment, like you say, the customer is always right. They need what they need, they contract from you what they need, and basically it's up to you to solve those problems. That's why they go to a colo.
Right.
So ultimately, that's a different philosophy, and you know, so the question then becomes: Are customers, their customers, starting to think about this as well? Because I believe, and this goes to back my decades of messing with IT, is that the IT was the beast that must be fed.
Ah, yes.
Right. So ultimately, you know, the accounting department will complain about the bill, but guess what? The bill's the bill, and that's what they were always told. Now, of course, there's always been pushes for efficiency along the way, but again, this efficiency combined with a concern for sustainability, I think it's actually a pretty good mix. Because again, it pays both ways. You know, if you're more efficient, you're more sustainable, which means that it's easier for you to continue doing what you're doing. But you don't keep doing stupid things in hopes that you can get away with it longer. Because face it, there will be a time when the chickens come home to roost. I believe
Yes.
this.
Yes.
You know, there's a limited amount of water availability in parts of the world. There's a limited amount of real estate. And you see the big ones being built in Texas and in Arizona. There's a lot of land there, but there's not a lot of much else.
Yes.
So the challenge becomes,
Prairie dogs, maybe.
yeah, but that's exactly, until they can harness a prairie dog UPS, just get a million of those little guys running on.
Technology innovation.
That's right,
what it's at.
exactly. So yeah, it's a fascinating time again to be in the data center world. Do you see anything on the horizon that people should be considering?
Oh, goodness gracious. Yeah, I mean,
Yeah, let's have it all.
Yeah.
We'll solve everything right now.
so much. I mean, one of the things is that, you know, what it costs to, you know, install and make infrastructure operational is significant.
Yes.
Right? And so changing, retrofitting, refreshing, those are complicated processes, and they can be very time consuming, right? I mean, and I hate to be a broken record, but, you know, looking into the future is so critical, right? And so one of the things that happens is that we're waiting for certain things to evolve. But by that time, sometimes it's too late. So,
Right.
for example, you know, we know that liquid cooling is going to become a much more prevalent technology, but you know, it's very difficult to retrofit. You're waiting for new builds and whatnot. But you know what? There's just a laundry list. We should set up another time to chat.
All right, we can get
about
into this.
innovations for the future.
I love talking technology. Sir, it's been a pleasure talking to you. You
So
take care
much.
and keep following these guys. Make sure they do the right stuff,
I
okay?
will. Great job, Steve. We'll
Thank
talk to
you.
soon.
All right. Hello. Are you Calvin?
I am Cal.
Excellent. Great. It's I've been trying to keep my schedule going pretty much all day, and it's working out pretty well.
Yeah.
We're ready to get. Okay. Joining me today now is Chris Nicholson, is VP of Product Management at Legrand.
Calvin.
Pardon me?
Calvin.
I'm sorry, Calvin. Yeah, there it is. I'm sorry. I'm getting so late in the day, I could
no, I
throw anyone in
understand.
there.
I
Calvin, thank you
completely
for coming
understand.
today. First about Legrand, he's at it's a large company. It's
It is.
worldwide.
Yep.
You work with the North Central and Central America group, I'm assuming, yes?
Well, we work with everybody globally because I run product management for the server technology and the Raritan brands
Oh, okay.
globally.
Great.
So,
Legrand of North Central is one of Legrand SA's largest subsidiaries. It's a global specialist in products and systems for electrical and digital building and structures. Brands such as Wattstopper, Patz and Seymour, Wiremold, everybody are available through you.
bunch of names you'd recognize.
Oh yeah. Oh my God. You know, and again, we've seen a lot of conglomeration, I guess
Sure,
is a better word, throughout the industry, because obviously it makes a lot of sense to group these things together
Absolutely.
from a
yeah.
corporate standpoint.
Yep.
So Well, welcome, Calvin. Thank you very much. Given the extremely broad range of the products that you offer, is it safe to assume that you primarily focus on both the commercial construction area and the data center area?
We do. Particularly power and then KVM access control. But
Right.
our group, those are the two primary products. So we do the PDUs that are really the last chain in the critical physical infrastructure.
Sure.
That power all the devices in the cabinet. So we're located in the hot aisle in the back of the cabinet.
And again, that's a technology that's been evolving to smart all the way along.
It has been, yes. Yeah.
I mean, ultimately, it's at first, if I remember, because I was a rack guy myself, so it's kind of fun to think back about the
Sure.
days, right? Because
Yeah.
again, no one thinks about powering all these guys,
Oh, yeah.
And
Yeah.
I remember we were focusing a lot on three-phase in the data center
Almost everything is three-phase
now,
today.
and we're talking about 15 years ago, right?
And that was a big change. That
Exactly.
was a big transition.
Well, and again,
Yeah.
there's some variables involved in that. And a weird story, I just have to throw this in because there's not a lot of people who would appreciate this, but I work for a large retail company, and they're an IBM mainframe company.
Okay,
And
yeah.
they built a new facility. When the local utility hooked them up, they hooked two phases incorrectly out of three-phase, which meant that the phases were wrong as the electricity went through it,
Sure.
and it killed their mainframe.
Oh,
And
yeah.
go figure. But again, if
Yeah.
you look at the way that harmonics behave, especially in the case where you're utilizing all three legs of a 380 circuit or whatever it is,
Yeah,
man,
yeah.
oh man, it can mess up a lot of stuff.
It really can. Yeah, as long as the plug is set right, we actually bring the three-phase into our PDU and distribute out over the branches as single phase.
Right. And again,
handle that for
making
you.
sure having the right legs
Yeah.
connected to the right lugs makes a lot of sense up
Yeah,
front.
yeah.
So what are you seeing in the industry that drew you to the data center environment? I'm assuming, because again, Raritan, I have a Raritan KVM
Sure,
at home, so
sure,
it's something, obviously that's something, I don't know how recently the Raritan acquisition was. Have you been with Raritan with you the whole time?
So our group originally, Legrand acquired Raritan, I guess about 5 years ago or so, and then Server Technology was acquired about 3 years ago or
Okay.
so, roughly. So if you take both of those brands, well-known brands, and put them together, we're the largest global PDU supplier for intelligent.
Oh, no kidding.
And we're the largest intelligent PDU supplier for North America.
Wow,
as
very
well.
nice. So then the data center is a logical place for
The
it.
data center is our bread and butter, right?
Right.
And we've introduced some new products, really adding some new features around power quality and power quality metrics just for the data center.
Because again, that's something that people don't realize. They figure they just plug stuff in and the lights go on, it's fine, right?
Oh, absolutely. And I was listening to some other presentations earlier today, and harmonics is becoming a bigger and bigger issue.
And again, it's something that people never see.
Yeah, and the fact that there's more edge compute, in some cases people are generating their own power and other things, you just can't have guaranteed perfect quality power anymore. And
Exactly.
So really what we're doing is we're adding some features and functions that'll measure the power quality 7 by 24, 365, and they'll have those metrics. If they have a problem, they can do a waveform capture, they can look at their historical data and understand what happened.
Exactly, because to figure out, we had grounding problems too. And again, this is something that people don't realize until they start, number one, things start going horribly wrong.
Sure.
But number two, it's a matter of, you don't, especially depending on old versus new construction.
Yeah.
In old construction, you just never know what you're going to run into in terms of your power environment. And no matter what due diligence you have, the older the building, the less likely things are going to be what you think they are.
Absolutely.
So
Absolutely.
ultimately, now I'm assuming that you focus primarily on the distribution and monitoring of power, but you don't do any power conditioning, or do you offer that as well?
Only on a few unique cases. Typically within the data center, it's good enough. You either can't or it won't fit in the product, or you don't, right? So it's usually
Right.
kind of outside the data center. But if you're getting losses in efficiency or heating or power supplies going dead or those types of problems, our new products will tell you that information by looking at total harmonic distortion, press factor, those types of things. So it's no longer, oh, I think I've got a problem, I've got to go get an expensive meter, hook it up, check it out. We're going to give you all that data down to the device level all the time. So it's a fairly big change in what's going on in the PDU market right now.
Absolutely. Now, so basically, again, you're looking at from a monitoring aspect only. Do you offer anything in terms of control as well?
So we do. So you can turn outlets on and off, and
Sure.
you can reboot devices.
Because again, that's the most basic form of remote management, right?
It is. So the reboot
Bounce the
has
server.
always worked. It's always worked, and I think will continue to work. Also, what's a nice feature on a switch PDU is once you set it up and you load it, then you turn off the unused outlets.
Oh,
and so
yeah.
people can't go in the cabinet and plug stuff in they shouldn't. Or
No, there's no
you know,
guarantee of
things
that,
are out
mind
there.
you.
No, but if they do, the outlet won't be on, and
That's
therefore
exactly
they won't have
right.
an issue of blowing the breaker or whatever.
Oh,
so,
right.
So there's other uses for switch PDUs as well.
So you also focus on the energy efficiency aspect?
We do. I mean, that's becoming a bigger and bigger issue, right? And we help with you can't manage what you're not monitoring, right? So once you start monitoring, then you understand where, okay, maybe there's stranded capacity, or the load on the server never changes. Maybe it's not doing anything, right? Maybe
Right.
we should take it out, that kind of stuff. So the zombie server concept, essentially. So, but if you're not monitoring that kind of stuff, you'd never know,
Right.
And over time, as the data center evolves, you end up with a lot of legacy equipment that's not really doing anything, and it's better to measure and understand it than to unplug the network connection and then wait for some angry person to call you.
Yeah,
if it
exactly.
doesn't work,
'Cause
right?
again, that's the
your
way-
alternative. That's your alternative. So yeah.
So let's take a minute and talk about harmonics, because that's not something that I have typically addressed. It's not something that people were aware of really as much of an issue. But we're talking about new equipment today that's kind of dependent on much cleaner power than it was in the past.
It is, and it's kind of a catch-22 because the switch mode power supplies that are on all the devices, whether it's servers, a network gear, storage, whatever, are famous for creating harmonics. So
Yes.
you've got a kind of perfect
Well, again,
storm
because it's an
there.
on-off cycling thing that can go on.
Exactly.
And not to
yeah.
mention even larger stuff like fan equipment and other things that are tied into the same power environment, right?
Absolutely, yeah, exactly. So you've got to come in from a bunch of different angles, and frankly, I can't count the number of times there's been new data center builds, old data centers, where we have to put 4 or 5 engineers in a car with about $1 million worth of measuring equipment
Right.
and go into a data center and figure out what's actually happening.
Right.
And now you can do a lot of that with the PDU right
Oh, sure.
there.
Because
And-
again, you have the sensors in the right places,
Exactly,
and then it's just a
exactly.
matter of pulling all that information
Yep,
together.
understanding the data.
Which
Yep.
which goes hand in glove ultimately with what you do in terms of KVM at Raritan, right? Because
Sure.
again, this is a matter of a centralized management platform.
Yep, yep,
So
yep,
the ability to be able to do KVM services as well as power monitoring and management.
Yeah, Raritan's famous for remote management, right? That was
Yeah, like
that
I say,
was-
I have a
that
big-
was,
I have a
that
big
was
one at
really
home.
what they started on before they went into the power side. So those products are still going very strong today, and actually with COVID we've seen a resurgence, and we
Right.
actually have a huge spike in demand on the KVM products.
So now KVM is extended undoubtedly through the internet. And
Yes, most of these are over IP.
Yeah, exactly.
Yeah,
So,
yeah.
and again, I go back to the older days. I have got some ancient KVMs that had cables thick as your thumb. Seriously. So,
Yeah.
I've gone through multiple generations of KVMs, and it's fascinating to see where these things are going. And again, putting in an IP makes perfect sense, especially when it's something you can route it.
Yeah,
And
yeah,
that
yeah.
also adds a security aspect, correct?
It does, and we're doing two things, both in high-speed KVM and then some secure switch stuff for the government. So those are two areas where we're innovating right now, as a matter of fact, on the KVM side.
Excellent, because again, no matter where you go, having remote access to your systems is important.
Yeah.
But security is, it has to go hand in glove with whatever kind of openings that you provide to your systems.
It does, and we're one of the few manufacturers that does our own third-party independent vulnerability and penetration testing on our products, just to make sure that, so we usually take it to the kind of the nth degree on the security side.
And I remember writing about this, oh my God, it's got to be 10 or 15 years ago, talking about how many companies still have POTS connectivity. Because again,
Sure.
face it, the internet is not everywhere.
Yeah, yeah,
But
no,
telephone pretty much is. So
Yeah, yeah,
having a having a dial-in modem for it still
Oh my
exists,
God.
right?
Yeah, oh, it's so funny. Yeah. I did that in college.
Yeah, no kidding.
And I remember my roommates thought it was black magic. And they're like, we don't have
What?
to go to the university.
Take it
You
on,
can-
turn it
yeah,
off.
you can- yeah, well, we can do our homework from home. It was
Yeah,
huge.
yeah, we're old guys, but we still love this stuff, right? Oh my God, so ultimately what role do you think that proactive monitoring and proactive visualization plays in being, because again, a lot of this is about DRBC, right?
Yeah, it's really where we're going, right?
Right.
I mean, if you look at especially a lot of our customers who are deploying globally,
Right.
so there's a lot of cases they're not guaranteed any certain level of power quality and or dual grids anyway, right? So you've got that variable. Now you've got people generating their own power because they can't get it.
Right.
You've got much more edge, which can be storefronts or warehouses or whatever. So it's really looking at that, understanding those applications and what we can do to help our customers and what our customers have asked for us. And that's really more accuracy and power quality metrics, and it's where it's going in the future. We're the first ones doing it, and 5 years everybody will be doing it, I think.
Pretty awesome. Do you have a cloud component to what you do as well?
So we have some storage there. We support a lot of the cloud providers and
sure.
provide custom products, and in fact that's a use case for these products in the sense that just because it's cloud, and let's say it's a cloud product that's going on a customer site, it doesn't mean that equipment's going actually in the data center. It could go
Right.
wherever, and therefore you're back to power quality and the harmonics again.
Sure, exactly.
So it's just it's widening up and creating some more challenges for our customers.
Because again, the neat stuff is, like you say, being able to go out and do this remotely in the old days. Now you can do it from your cell phone.
Yeah, or from whatever you want.
Yeah,
exactly.
and you can, and
Yeah,
again,
yeah.
you can get an indicate. Because again, the biggest challenge from a BCDR perspective is sorting through the noise, right?
It really is.
If
Yeah.
you look at any kind of production environment, you could come into 100 or 1,000, warnings,
Sure, what
notifications.
really happened, yeah, oh,
and being
absolutely,
able to sort through that noise is part of a challenge too. But from a BCDR standpoint, I also believe that the rapid response is a huge challenge.
It
so
is,
for a data center admin to find out this just went down almost real time can be a huge benefit for a
absolutely,
company.
Absolutely, and we're doing our standard open APIs. We're doing SNMP, but we also added the Redfish API to these products as well. So kindly the first, do the work once, deploy many. So as long
Right.
as somebody else has done the Redfish API, you could swap the products out and it would work, just plug and play. So
Right.
it's been a long time coming, I think, for technology like that.
Absolutely. And the market's still huge for KVM systems, right?
It is, absolutely. Yep,
Because again,
yep.
when you start looking at an environment, and again, depending on the environment, basically they can either run around with a crash cart, which
Yeah.
is the slow way of doing it, but
Sure.
it's there.
Yeah,
Or,
yeah.
Ultimately having the ability to actually individually control systems and everything like that from a centralized location is huge.
Absolutely, it is. Yep.
So, are you experiencing any challenges in terms of availability due to supply chain and everything else?
We've had some challenges. Really, very, very strong demand.
Sure.
Is part of our problem, and then chip shortages, right? And
Oh,
unfortunately,
yeah.
some of those chip shortages have forced board redesigns, which often forces new firmware. So to go
Right.
through that cycle of relaying out the board and getting it right, and then getting new firmware, and then testing it, and then building those boards in quantity in production has been a huge challenge.
Oh, no doubt.
Huge
And
challenge.
it's
So-
difficult at best, but when you start talking about the chip shortages we're seeing right now,
Oh, it's unbelievable.
Yeah.
Yeah.
well, hopefully things will keep getting better as we go. Pleasure
think so.
talking to you, sir.
Hey, thank
you
you. I
so much
really
for your
enjoyed
time
it.
today.
Thank you.
All right, have a great day
Yep.
and a great show.
All right.
All right,
We out?
I
you hear
believe
me?
so. And now we're going to take a short break, and we'll come back to our next interview shortly.
All right, let's go ahead and get started. So I know you've all heard this today, but I need to read the obligatory statement. Your feedback is important to us. It enables the DCW team to improve the conference from year to year. You can rate sessions and speakers in the mobile app. Please rate me as a 5-star. That'd be great. Simply pull up a session and click on a link titled Complete Your Session Evaluation. Thank you for your time. On the mobile app, be sure to download the Data Center World mobile app by scanning the QR code in the event guide or searching by Enterprise IT Events in your app store. The Wi-Fi password is DCW, or the Wi-Fi network is DCW22, and the password is always the cybersecure. That's also a great password. And tonight, please join us at the opening ceremony in the Expo Hall from 4 to 6. So thanks for coming. I kind of meant this to be a more shorter presentation to make it more interactive. And yes, you will hear the word edge numerous times in this, but I'm going to try to at least go beyond the definition of edge and what I think it kind of needs to be. So a little bit about me. I'm Tony. Hello. I probably know a little bit about you on LinkedIn. I had a very different path to tech. I actually spent 21 years in the Navy. That's me up there. Yes, you can grow beards on submarines, and yes, you can smoke cigars, until recently on submarines. So there's a picture of me and my crew underway. But I did 21 years in the Navy. After my CO tour on USS Providence, I decided to get out to spend a little more time with my family. Lucky enough to get picked up right away for Facebook. And at Facebook, I kind of learned that, yes, I knew how to run a nuclear reactor. Yes, I know how to run HVAC mechanical, but a submarine actually has 20 megawatts roughly of IT load on board. So we call the substrate different. We call the overlay something different. Fiber was something different. IP was something different, but I kind of knew how this whole kind of cloud platform worked. So I was able to build on that at Facebook. Unfortunately, for those in the Bay Area, I'm sure you know, Navy person coming out, I had like $1 in savings. Couldn't afford to go with the 20-year-old kids, that had all the RSUs. So ended up moving up to Seattle. Was lucky enough to work at AWS and Oracle. And during my time at Oracle, I started talking to some these data center CEOs, like Brian Cox, Surreal, Chris Crosby. And I was like, wow, that stuff's pretty cool. I like being on that side of the business. So lucky enough, got picked up at Compass last August and working on a new line of business called Quantum, which will be announced on April 5th. So I can kind of talk around it right now, but we'll officially launch it on April 5th. But that's a little bit about me. So, as you know, on edge, and I'm sure you've heard it this week so far, multiple definitions of edge, far edge, micro edge, etc. They're all tied to latency, all tied to distance, and all tied to the company that defines them. I admit it, I've been part of it. I've defined it. I've been to multiple working groups. Has anybody actually not been on a working group here that's defined edge? Anyone? All right, well, that's a quick, it's supposed to be a little back and forth here. But so I helped define edge, and I realize that, but the real problem is which definition is correct. So who out there thinks they know what the definition of edge is? And it could be far edge, it could be micro edge. No one? No one's willing to say what they know the definition of edge is? All right, so I'm gonna have something really spectacular in the next slide, because I think I know what the definition is. And the definition is, I think they're all right. Because I know it's a total cheap cop-out and everything, I get it, I understand that. But for me, as a physical infrastructure person, every customer and platform will require something different. And an autonomous car is going to require something different. An autonomous train is going to require something different. An IoT is going to require something different. My device is going to require something different. My kids playing Xbox will require something different. So I'm going to approach this really from the physical layer. And from the physical layer, does the definition of edge really matter? No, it doesn't matter. So the whole perspective of this is, let's just get past the definition of edge, understand that at a physical layer, now granted, at a network layer it does, and as a platform layer it does, this is really supposed to be on the physical layer, it doesn't really matter. So I think we really need to move beyond this definition and focus on the real problem, which is how do we deliver these kind of solutions for the customer? Because the customer tomorrow, I was one of them, will require flexible infrastructure enough to rapidly deploy a workload anytime and anywhere. Just think about that. Anytime and anywhere. Right now, they can deploy to Ashburn. They can deploy to Phoenix. They can deploy some to Chicago. They can deploy, it's really kind of limited. What if I have an app that's based out of, upstate Wyoming, and that's where it is? Can I deploy it out there? You can't really do that kind of stuff.
Hello, welcome to this Fast Chat sponsored by Legrand. I'm Rebecca Harold, CEO of Privacy and Security Brainiacs SaaS Services and CEO of the Privacy Professor Consult.
This customer wants to build this matrix of infrastructure. We need about 1,000 sites across the U.S., about 2,000 square feet, 3-phase, 208, 200 kVA. How hard do you think that would be? Yes, it will take time. And I say building a hyperscale data center in Northern Virginia is going to be easier than building this matrix of infrastructure in the future. So let's look at an example. So let's say I'm a startup. You know, I just graduated from college. I like this AI thing. It sounds really cool. And my whole premise is, as a startup person, software focused, that I want to take an X-ray and MRI, compare it to a database, to give a prognosis to a doctor on what a patient could have with a percentage. So that software person is going to have to figure out how to get the money. That's part of a startup, so I give you that. They're going to have to figure out a network design. They're going to have to figure out a data center design. They're going to have to figure out their DCI and BMS, physical security. Then there's this whole permitting, zoning thing. Then you get logistics, and you got this whole site prep, construction, utility negotiation. What's that? How much do I pay? Operations, break fix. How do we do all that kind of stuff? And that's just the beginning of it. So the real point is I think we need to separate out the software side, platform side, from the data center side. So ways companies can do this: they can hire experts in each field. By experts in each field, I mean they can hire a data center company, they can hire a real estate company, they can hire a general contractor, they can hire a network-focused organization to build their network. They can, but that requires time, money, and a lot of patience from the board. They can source a lot of those needs to other companies that are out there, but that requires a lot of RFPs, a lot of back and forth, a lot of decision making, or they can have a combination of the above. And the problem with all three of these solutions are really kind of time consuming, costly, and contain lots of unknowns because you just don't know what is out there. And you don't really know what the art of the possible is. Plus, you have limited opportunities to pokioki, which is really error proofing. You have limited opportunities to do Kaizens, which is really improving on your mistakes because you're just building one or two of these, you could be building 10. So is there really another way? So I think the future of infrastructure, you're always gonna need on-prem, you will need large data centers, and you're gonna need cloud, which is the hybrid of right now in today's model. But you are gonna need a little bit more. And this is kind of going back to this framework of a matrix of infrastructure. Because let's go back to the problem statement that I had. That customers will require flexible infrastructure needed to rapidly deploy any workload, anytime, and anywhere. So I really do think the future that fits this niche, they're smaller data centers, and I'm not going to define what that size is. I think if I talk to one person, it's going to be a megawatt. If I talk to another person, it's going to be a kilowatt. So I'm not trying to define what the size is. But we need to really solve the customer problems. And it kind of comes around easy, anywhere, and that's kind of customer problems. But I think what the future of data centers needs, that the hyperscales are doing, is sustainable and remotely managed. And so let's go a little bit into these. So easy. Customers, so this is, back my old company hat on, I don't really want the details, I just want the problem solved. They want the easy button. They don't want to deal with a bunch of people. They just rather go to one single person to solve the problem for them. That's one person to solve the land lease. That's one person to solve the permitting. That's one person to solve the operation, the logistics. They just want a weekly report rolled up to them. That kind of explains how they're kind of doing. So we really need to make this stuff super, super easy. And are we set up to do that today? I don't think so. I think we're very disparate in our own stovepipes, rightfully so. We kind of work well together when we need to, but we don't in other locations. So we need to find a way to kind of bridge that gap to make simple MOPs, to deploy data centers kind of anywhere, which is the next thing. I think we need to be able to deploy data centers anywhere instead of relying on the kind of always, tier 1 markets, cities, maybe even some tier 2 cities. If the Austin Conference Center wants a data center, we should be able to provide that for them. We should be able to bring that data center to them so they can meet whatever latency or platform requirements they mark. But I mean, who here could actually deliver a data center on the top of the hotel right now or in the parking lot right now? No one's really set up to kind of do that. What we are set up for is tier 1 market, no problem. You want something out of Phoenix, no problem. But who's going to build that data center in the middle of Sahara or in Africa that is needed by those countries right now? We're not set up to do this right now. We need to take a better look at sustainability. And the way I look at kind of sustainability right now is you have kind of the companies saying, I want to be more sustainable. I'm going to set goals, 2025, 2030, whatever it is. And you have data center companies that are looking to say, well, tell me what I need to do, because I'm willing to risk the capital. I think the data center companies, and whatever we're doing in this kind of smaller market, we need to be sustainable from the get-go. Why can we do that? We're smaller, we're cheaper, we can build at a fraction of a cost at a hyperscale, and it's much less risk. So the things that we want to look at a 100 megawatt data center, we should be looking at these smaller data centers first. So should we try and PEM fuel cells? Probably. Solid oxide fuel cells on a microgrid sounds great to me. You know, kind of these great composites and coatings that are out there too that use, you know, a small amount of energy to make, a lot less carbon than a steel piece. We should be looking at that kind of stuff in these sustainable data centers. The risk is minimal. So maybe you build a data center for $600,000, it has sustainable aspects, no one wants it. What's the risk to your bottom line on all of these kind of companies? So I think we need to kind of put our money where our mouth is, understand sustainability, and actually build a data center from the beginning where you actually know what your carbon footprint is. That when you get an HVAC, you know where that fan, where the carbon comes from. That when you put the UPS in, you know exactly what kind of batteries are in there, where the carbon footprint is, how much energy it used to make. You have to start this stuff. And it's super simple at small scales, very hard at the higher scales. Finally, remotely managed. And so this is Tony Grayson, you know, ran nuclear plants for 21 years talking. What happens when a breaker opens at home? You shut the darn thing. What do we do at a data center? We get around, we critique it, we look for root cause, we kind of discuss things, we're at MOP, then we shut the breaker again. On these small remotely data centers that are dispersed, let's say you have 500 of them, let's say 10 open breakers, you have to be able to get it back on board, shut this breaker remotely. Because what you don't realize is you're going to have to call, you know, Rich here, who's going to come in a truck. Maybe next week he's going to charge you $10,000. I'm just looking at Rich. He doesn't really own a truck, I don't think, and he doesn't own a site like a on-prem kind of front-hand service. But we have to have this capability to really remotely manage these data centers. We have to have AI in our security system to alert us. We have to have seismic sensors that tell when someone's breaking in. We have to make these things indestructible. They can't be kind of these, I'm going to build this cardboard box out there and hope that my $10 million, no one really messes with it. We really have to build these things remotely managed and sensor kind of dense to be able to kind of do 1,000 of these with a very small man. And you know, you can solve this easily remotely managed by putting people in there. But I really think with these small kind of data centers, it's not a really good idea to solve it with people and or truck rolls. I think you really have to build something robust and the ability to manage it remotely. So that's kind of the whole premise. Hopefully it wasn't too much of a letdown or anything, but I really do think that this is kind of the future of where we kind of need to go. And that's not to be said. We're definitely going to need the hyperscalers, we're definitely going to need the cloud, and we're definitely going to need on-prem. But we have to start bringing data centers to the customers where they kind of need to, and we can't charge an arm and a leg to do it. So what are the benefits? So if this goes back to my fledgling software company, I can now just focus on what I think is cool, which is AI and HPC and GPU and this database and all that kind of stuff. I don't have to worry about that physical layer. They don't want to worry about it. We want to worry about it. So let's take that off their hands. The customers aren't going to have to go to the board and sit there and say, hey, I need a large capital expense, because I really do think a lot of these deals, we need to find a way to make it an OpEx base. So it's a monthly base, everything kind of tied together. It cannot be a capital expense. How am I going to do well as a startup if I have to pay $2 million for some kind of box that I want to go out into the back of the hospital? But if I'm paying, you know, $4,000 or $5,000 a month, that's a lot more easy, and I get the top rate service for it. Suppliers, the benefit of one person kind of doing this is you can actually lower costs through volume buys. So instead of 4 HVACs, you're buying 1,000 HVACs. Instead of 10,000 UPSs, you know, you're buying 10,000 UPSs instead of buying 4 UPSs. Your volume discounts really, really do make a difference. So I'm sure, I'm looking at Vertiv right now, so I think they can back me up on some of this kind of stuff. At least I hope so.
Hello, everybody, and welcome back today at this time we have the pleasure of speaking with two friends from a company called Americase. First is Joel Chacalaco, correct?
That is correct.
Joel, who's the VP of Strategic Business Development. And we also have Chris, and I didn't get your last name, Chris, forgive me.
Chris Egloff.
Chris Egloff, and he is the VP of Hazardous Material Management. Although I still think Danger Man should be your... And ultimately, what we're talking about here today, Americase is an ISO 9001 AS 9100 company that designs and manufactures commercial duty carrying cases for all kinds of stuff. Basically all types of transportation. You got to get it from here to there. You want to make sure it doesn't explode. You want to make sure you get there in one piece. These guys make cases for it, right? And so after looking at your case, I can see that you cover a wide variety of rugged packaging options. So basically we're talking about lithium-ion batteries here, but you go into a broad range of stuff from the defense industry to even moving convention materials and stuff like that. Getting something somewhere safe is pretty much the whole deal, right? So the question is, obviously, for companies, like we had talked about earlier, you don't know what you don't know. So at one point, do companies need to get in touch with you and start thinking about storage and transportation?
So from a supply chain perspective, they need to be thinking all the way back to their manufacturer, right? So whoever is manufacturing their battery, it's not simple to say, hey, our responsibility starts at when the lithium ion shows on the back dock.
Right.
They should really start at their manufacturer, right? Because as soon as it leaves the manufacturer, the bullseye's on everybody.
Right.
Right. So how do we keep lithium ion safe during transport from the OEM to your facility, whether it's a data center, colo, edge, whatever that facility may be? That's really where we need to be engaged from when you're starting to build your technology. So as soon as you get your specs for your battery, that's where you should be calling us in, because again, we want to be there to understand what is the risk, right?
Precisely.
And that's where we should start off at.
And just to talk a second about lithium ion, because all of a sudden we're seeing it everywhere. I mean, the challenge for a lot of technology, not just computer technology, but lots of things like, say for example, electric vehicles, is having a battery system that's as efficient as possible and high power. And that's where the high power aspect comes in. That's where the danger comes in from lithium ion. It's a great battery source, but it's also relatively dangerous. Now, I've seen, and if you're interested in looking at this, there is videos in the internet showing you what happens when lithium ion goes off, and it really goes off. I mean, the battery in your cell phone could burn through this table without much effort. So the question is that how much of a bigger bang do you see in data center level lithium ion batteries?
I want to be clear that batteries are inherently safe.
Oh, sure.
But it is the what if. And the batteries that they are replacing, these big diesel gens with these battery backup units at the server level, if something were to go wrong, if during transit they were damaged or there was a flaw in the manufacturing process in and of itself, and you were to have a thermal event, they are quite volatile when they go off. So you need to make sure you can mitigate that risk in all cycles of the process.
Right, and it's obviously more important during a transportation cycle than it is when they're in place. Now, do you also have to consider when they're in place? Is that something that you think about too, or is it mostly when they're in storage or transit?
Well, you definitely have to think of them when they're in place. I mean, DDR, damaged, defective, recalled batteries, right?
Oh, sure.
So if a BBU is in a rack or in a device, that could go bad.
Right.
So what do you do at that point? Part of our custom solutions is not only just dealing with what they call as on-spec batteries, but also off-spec.
Right.
The stuff that's going bad, right? So we actually have, Americase actually has a special permit to be able to transport those DDR batteries back to a recycler or back to a lab or an OEM lab for analysis and diagnosis.
Yeah, again, without inconveniencing the customer at all. Right, it makes perfect sense.
All you do is you slap a FedEx label on that case and it's ready to go.
So what are people typically using today? I mean, I tell you, sorry, I actually bought some a dozen phone cell chargers. Lithium ions, I don't know, small, 2,000 or whatever. And I ordered a dozen of them, and they came in a dozen separate boxes.
Yep.
And I was like, did I order these wrong? It's like, no, lithium ion is something that everybody is paying attention to right now. So the question is, obviously, Amazon thinks a cardboard box with a little foam around it is sufficient, but what is, what are the solutions that are people using today typically?
Well, I mean, you have to understand that you have two categories. You have known good batteries and then you have damaged defective.
Right.
So from a server standpoint, damage defective is the exception to the rule, the 1 in a million that you might have to ship, and we have packaging for that.
Right.
But the bigger issue, and we'll get to later about the value proposition of what we do is right now it just has to be a UN spec cardboard box, possibly a plastic
Really?
bag on the inside of it, which is a lot of waste. It's not very green, and it's not reusable. So
Right.
there's waste, and it's not very protective. What we do is we come up with custom solutions that you can use over and over again for all life cycles, both on the front side and back side of your use with batteries.
Makes
inside
perfect
the facility.
sense. Yeah, and I remember when I got rid of my last Samsung phone, it had developed an extremely dangerous and interesting bulge, and I like, sure, I'll wrap this up and best of luck. You just never know when you see the case start separating. That's a bad thing, right?
Yes, sir.
Great. So at this point now, there is really very few in terms of specific requirements for a lot of these products, right?
For known good batteries, it's basically a drop test, a UN drop test in a cardboard package.
And that's pretty much it. All right. So if you're a company that hasn't done anything yet, I mean, if you completely forgot it, never came into your mind, what is the process? What should they be doing now, as of right now, to be able to deal with this properly?
I think the first step that they need to do is, of course, give us a call, right?
Oh, sure.
And it's the legwork that is involved here. It's not necessarily a product off the bat, and we don't have these products off the shelf,
Right.
Because every battery, as Chris mentioned, is different from another. So it's understanding the specifications, the dimensions, what they're trying to accomplish, right? So it's a lot of Q&A,
Right.
Between us and our client, saying, what are we trying to do? Are we trying to solve an issue? Are we being proactive to an issue, or are we already in hot water in something? Right. There's a recall, or there's DDRs, or what is the case? So so it starts with that conversation, and we kind of, because of our experience, we kind of walk the client through those questions. We know the right questions to ask.
Sure.
Because we dealt with everything under the sun. So we know the right questions to ask, and we're happy to hold our clients and take them through that journey on their lithium-ion journey, or any type of dangerous good journey.
Right. Now it seems kind of odd, and I guess maybe not, because again, people think of battery, they think AA, C's, D's. Those are very standard packages, but we're seeing batteries coming from all different locations, all different needs, all different form factors. And that's probably what makes your job really hard, is the fact that you could be running into all kinds of things. Now, will there be cases where, say for example, everybody who uses a certain vendor can get a off-the-shelf case?
I mean, I would say 80% of the way we're there. We're already working with some of the largest companies in the world, so we see very similar designs. But there isn't an overarching umbrella. We call that generic packaging.
Sure.
And honestly, depending on how many batteries you're trying to put in a case, you still have to read the regulations. Is it for transport? Is it for storage? There's so many data points that we have to know if we're absolutely not only legally compliant,
right,
but offering you something that ultimately is as safe as it possibly can be with the data points that we gather from. Again, we do everything from testing the batteries, testing them in our packaging, and transport, drop testing, vibration. So we cover all facets of what you would need to know from a battery perspective. So it's not a long road to get to where we need to go, because we've done it so many times, but I wouldn't say that you could just buy a widget and you're safe. There is a lot of customized work that has to happen between us and our customers to understand how we can do it properly.
And it makes perfect sense. Again, I don't know if you have a fiduciary responsibility to your customers, but I'm assuming that I don't know if you have a certain amount of liability because you are involved in this hazardous materials process, right? So I'm assuming that you are also looking after the customer when they don't.
Absolutely.
The customer's also got, like their insurance companies, right? Their risk underwriters.
Exactly.
Right? These are the guys signing a check in case something happens. And they're asking a lot of questions too, right? Great, you got lithium ion now, how are you protecting it? Well, we bought this case. Well, how do we know that case is going to handle the thermal runaway of this battery?
Right.
Those underwriters are going to ask those questions, and those are the questions we answer for them.
Exactly.
And that's the reason why we do one size does not fit all. That's why we do the testing that we do.
Sure.
To provide them the empirical data evidence saying, yes, our product, our solution can handle
that, exactly.
Can handle this, your battery, your
Wow.
specific battery.
So you serve as a verification platform as
Oh,
well.
yeah.
And I understand you're involved in several boards in terms of UN national grade and national level and world level standards.
Yes, sir. So, I mean, AmeriCase has to be on the forefront of what's going on. I mean, from the fire safety codes that are coming down that are being adopted in 2024 that are already in New York and California right now, all the way to the regulations that are going to be pressed upon everybody that deals with lithium-ion batteries. One of them is the UN subcommittee on the reclassification of lithium ions and metal cells. Right now, when you talk about lithium ion cells, it's basically a battery in equipment, out of equipment. Is it lithium ion or lithium metal? Where in the dangerous goods worlds of, let's say, explosives, there could be 1,000 different categories of something between TNT and fireworks, between alcohol and pure 100% liquid nitrogen. All these things are categories to understand how to transport them safely. The battery world hasn't caught up to that. So we're writing regulations to say, okay, this battery might be very inherently safe and it doesn't need much packaging, where this one is very volatile when it goes into rapid disassembly or thermal runaway, and you need to have a very robust packaging to guarantee that it can contain it both on transit and road, rail, sea, and even potentially air. So we are writing those regulations right now. And then we're also on the SAEG 27 board, where we're actually coming up with packaging standards to allow batteries back on airplanes outside of equipment, so it gives the consumers more lenience for shipping their batteries for just-in-time delivery, where right now you can't ship a battery over 30% state of charge outside of equipment on an airplane, commercial or any other right now.
Wow, that's interesting. Now, and again, forgive me if I'm wrong, I seem to remember seeing something about you being involved in the airline industry as well. You also deal with like oxygen generators or other risky products?
Yeah, the ValueJet crash back in '97
oh
really
my God.
put the risk of oxygen on airplanes. So,
well, because again, all airplanes have it. The problem is moving around the unused or partially used or whatever.
Absolutely.
And again, that's what ended up bringing the plane down into the Everglades, if I remember correctly, right?
Yeah, and the regulators actually proposed some of the strongest packaging that's ever been written. I mean, we're talking 1700 degree flame penetration test.
Oh my God.
Extreme drop testing. I mean, to ship an oxygen cylinder right now can cost you up to $1,000 for a package.
Seriously?
Sometimes the cost of the package is more than the bottle itself, but if you have to ship it by air, you have to put it in a container that we design.
That's, perfectly safe. That makes absolute sense. How do companies stay informed? I mean, my God, like you say, the challenge is these things are changing all the time. The products are changing all the time. What they're made from is changing all the time. Their form factors. How does the company keep track?
I'll tell you, first thing, don't use Google.
Well, come on, that's all we have.
Pick up the phone, call my friend here, Chris.
All right.
Like I said, he sits on those subcommittee boards. He's the foremost authority on this.
To be honest, you can't stay informed. There's some companies that we deal with have individual hazmat experts that do nothing but that. But that's still one person in $1 billion company.
Right.
There's organizations that you can join, but usually when you partner with us, we're going to consult with you. We're going to keep you abreast of the situation. Half of my job is traveling all over the world, trying to understand what are the regulations today, what have they been in the past, what are they going to be in the future, and helping them understand all these difficult hurdles that they're going to have to go to be both compliant and safe.
Right. And again, this isn't just about the lithium ion. It's about whatever other potential stuff may show up along the way. Right now, it's lithium ion is probably the biggest consideration, right?
Correct. But we're problem solvers. We're willing to attack any issue and give you some kind of a packaging or containment source.
Even beyond the dangerous goods, we're doing custom enclosures, server cabinets, server cases, edge, mobile edge enclosures, those type of things. So we're across the board.
Okay.
Dealing with clients.
Yeah, and again, it's just not hazardous. You do all kinds of stuff. I mean, moving around conventions and stuff like that.
Anything
rock
that needs
shows.
To be moved or stored safely.
Exactly.
Or of high value.
Yeah, but does a traveling rock show need danger?
I mean, probably not. But if there's business to be had,
I'll think you go for it. All right, danger. And again, are these expensive? Just a quick final question.
Consider what do you think? A good example is one of our clients was a cloud computing company. They needed this because they never built data centers for lithium-ion storage. It was going to cost them about $200,000 to retrofit a warehouse for lithium-ion.
Oh my God.
Our case is a couple thousand bucks.
Right.
So the return on investment is, in the days and weeks. Not even close to the months, not even going to years.
Right. Wow. Yeah. And it's not easy to say. Well, gentlemen, it's been a treat. Joel, thank you very much.
Thanks for having us.
Nice to
Danger Man, Chris, take care of yourself.
Thanks
Gentlemen,
a lot, guys.
We'll be seeing you again, I'm sure.
Have a great day. Bye-bye.
And with that, we're going to take a short break, and we'll get back to you with more fascinating guests in about an hour. Thank you.
Hello, welcome to this Fast Chat sponsored by Hello, welcome to this Fast Chat sponsored by Legrand. I'm Rebecca Harold, CEO of Privacy and Security Brainiacs SaaS Services and CEO of the Privacy Professor Consultancy. I started my career as a systems engineer at a Fortune 200 corporation. There were some huge concerns we were trying to meet because we were trying to get as close to 100% uptime as possible. Now, there were a lot of issues necessary to consider to meet that goal, but they were often overlooked by many organizations, including using high performance power outlet technology, protecting from power spikes, monitoring for efficiency, and having security capabilities to protect and maintain the power source and keep unauthorized access to those settings protected, because those could be very harmful. These concerns are even more important now than ever before, and the increased complexity of data centers increases the risks related to those concerns. Well, today we're going to discuss a few of these issues and how important uptime, availability, reliability of power sources are to meeting operating systems goals. Our guest today is Calvin Nicholson, Senior Director of Product Management at Legrand Data, Power, and Control Division, which includes server, technology, and Raritan brands. He is responsible for overseeing product strategy and product management for PDUs and other related products. Welcome, Calvin.
Thank you, Rebecca. I appreciate it. You've definitely have a great background for this call.
Because of my background and where I started as an engineer, I'm wondering, what are some of the power and power monitoring challenges that data center operators face today with this complex environment we're in?
Yeah, and it really is a complex environment, there's no doubt. And I think that as you look to IT being broader, whether it's edge or storefront or cloud or whatever, you've got to really operate and perform in all these different environments. So what we do is we provide the tools to distribute the power, of course, but also to control on off for reboots and things, and then multiple levels of power quality monitoring. So our goal is to really give our end users the information they need to avoid problems before they would ever happen. And that could be a lag in power, that could be a number of different things, a brown, any of these other things we can really look at both at the in-feed level, so the A and B feed coming into the PDU, and at the outlet level. So maybe at the outlet level, you want to be more concerned with harmonics or things like that. Maybe at the in-feed level, you're just looking at overall, what is the capacity? So I don't exceed the rated capacity of the PDU as an example. So we really give the customer the ability to monitor, control all the power, environmentals, in fact, too, for if it gets too hot or humidity is too high or whatever, another number of other sensors. So we're really giving them the peace of mind to manage all those things within the data center cabinet. And really in the cabinet, if you look at the overall infrastructure, that's where about 40 to 60% of all the power in the data center is used, is really all those devices racked and stacked in the cabinet itself.
Yes. And you talked about our complex environment. Now, I work with a lot of hospitals and medical systems. Talk about edge devices, and patients' lives depend upon having those powered up, right? So that's probably a really important, just one example of a really important example of why this is so important to keep that power going.
Yep, absolutely. We've seen a lot of that with some of the HIPAA rules, the digitization of all the documents, and a number of things. Yeah, so that actually is a big growth area that we're seeing right now on the IT side of things.
Well, can you explain some of the recent advancements in cabinet rack PDU technology?
Yeah, so the PDUs themselves, like I said, have kind of been that last point. The PDUs are typically redundant, right? There's an A and B in feet of power. In a perfect world, in a Tier 4 data center, those would be from two different, completely separate power grids, but that's not always true. And then once you bring that three-phase power into the PDUs, we distribute it to the devices as single phase. And that's where we kind of take control with the monitoring, with the outlet control. Some of the newer features are harmonic distortion. You know, there's a lot of switch mode power supplies, whether it's in the servers themselves, whether it's in the storage, whether it's in the network switches. They often create harmonics as an example. So we can look at that, see where you're losing efficiency, see where there's heating, see where there's other problems being created, and then give you that information back. We're also starting to do a lot of diagnostics. So if you have a server issue, let's say there's a short of a power supply or something like that, and it blows one of the branch circuit breakers on the PDU, we can actually help you by telling you which device had the problem. And also that helps with the diagnosis of getting that branch circuit up and going quickly as well. And if the customer hasn't done a coordination study, in some cases that can blow the upstream breaker, and you may be running all your devices off one power source for that period of time. So just a couple of examples of how we're kind of monitor, making, using the technology today, more accurate technology, and giving our customers more information to run their data center.
Calvin, you mentioned before about the selective coordination, the testing and so on. How does that become more important with all these new technologies and new complexities? Or maybe you could mention something about the importance of those?
Absolutely. And Rebecca, that's really one of the finer points. Customers will have a problem with the server device. It will actually blow the breaker on the branch circuit, and then they'll lose the whole PDU, and they really don't understand why. Well, the reason is the breaker at the PDU and the breaker at the RPP, the remote power panel, are not selectively coordinated. Their trip curves overlap, and therefore when the branch breaker blows, the upstream breaker blows, which can be very dangerous because now you've got one PDU supporting your whole IT load. And that's where you really get into if your devices, your redundant devices, were wired properly, and if you have enough power on that one PDU to support the whole load. So in theory, that could have a daisy chain of events, and you could even lose the whole cabinet. So it's a very critical point. There's no doubt, and one that's not talked about, and like I said, a lot of people just don't really understand.
Well, that sounds like a very severe type of problem to have to deal with. What are some of the other types of problems that intelligent PDUs with advanced metering are able to solve then today?
And that's a good question. And as a follow-up to the selective coordination, if you lose one of the infeeds, one point I should mention, both on the Pro 4X from ServerTech and the PX4 from Raritan, is that we redundantly power the controllers on the unit. So as long as one of the PDUs has power, you still have all your communication, you still have access to the device, you still get your alerts and alarms. You can still talk to that PDU through its intelligent network card. So I probably should have mentioned that in my last answer. But anyway, the problems we're solving is really the main problem that's with any data center. And that's really uptime, right? So you want to minimize your problems. You want to get power data, whether it's sags or surges or any other type of power quality problem, and get alerted to that. Understand where you're having your issues. Understand what the maximum capacity is, whether it's of a branch or of the whole PDU, and look and have alerts and alarms for those thresholds, so that you don't overload a branch or you don't overload a PDU and have downtime issues with that. We also do power factor calculations. We do crest factors, current and voltage just in general, just a number of other power factor measurements that we really do add a new accuracy level. So we're going from a 1% device to 0.5% device. We're also changing our A to D sampling where we can actually capture the image of the waveform when these devices happen. So if there's a problem and a server shorts and it blows the branch circuit breaker on the PDU, we can capture that waveform as a point in time, and you can understand exactly what happened to your current and voltage when you had that problem. So not only will it tell you it's outlet 13, you need to go look at that server, but it'll give you diagnostic information that will allow you to make decisions. We're also doing some new min-max power stuff too. So it's very interesting if you are installing a new server and you understand the load of the cabinet at that point, but you probably need to know what the load of that cabinet was, both temperature and power-wise, 6 months ago or a year ago, whatever your worst case was, then to understand, do I really have enough power available in that cabinet? And do I have enough cooling capacity where I can safely install that server? And we actually track the min-max loads on those devices to where you can look at that information and make those kind of decisions directly from the interface of the PDU itself.
As you described that, I was thinking how this could be also very beneficial for forensics investigations, particularly after like distributed denial of service attacks that bring down, overload and then try to bring down a network. So yeah, that sounds very important and very useful.
Yeah, absolutely. Because we're if you get the right device, we can measure at the outlet level and therefore at the device level. So you can see what the load is on the server, right? And it's interesting for a couple of reasons. One is that the unit's going to use, a server is going to use a fair amount of power just sitting there idle. So you can track that power and see that that device is doing no useful work, and therefore it may be a zombie server that you want to look at because it's not being accessed. But to your point, if there's an incredible load on that server, and it could be something you understand if the peak of your business is on Black Friday or whatever it happens to be, but in general, if you had a denial of service attack like that, you would see that max power load go up on all those devices as well. So it's an interesting point.
I'm wondering, how does this technology then fit and work within an existing data center infrastructures? There's a lot of legacy data center infrastructure still being used out there. So how would this technology fit in and work with those?
That's an interesting question. I mean, the devices we're powering are the devices we're powering, right? So newer servers may have a more efficient platinum power supply, maybe a higher power factor, things like that. They may use less energy. But in general, we're going to monitor no matter what the device is. And then the PDU itself fits into your ecosystem. So we have open APIs that can talk to building management systems or DCM systems. We've actually just introduced the Redfish API, both on the PX4 for Raritan and the Pro 4X for server technology. And some of those features will even be retro to some of our older products. So Redfish API, another very industry standard way to monitor, and it's kind of do the work once, deploy many, in the sense that once you've implemented the Redfish API, no matter what device you connect, if it talks that API, you don't have to redo the work. And then we have standard alerts and alarms. A lot of them are through SNMP and regular tools that people are familiar with as well. So we'll fit into that ecosystem. There's a web GUI where you can see the min-max stuff I talked about. You can see the waveform capture. You can look at all the different power parameters we provide. So there are just a number of different ways that we can get that information to the end user.
Well, thank you, Calvin, for all this valuable information today. I learned a lot, and I know our listeners did as well. And thank you, audience, for joining us on Fast Chat. I'm Rebecca Harold from Privacy and Security Brainiacs SaaS Services. Please join us for our next episode of Fast Chats.
Thanks, Rebecca.
Hello and welcome back. We're speaking now with Dominika Kincevich, Senior Analyst, Cloud Services and SD-WAN at Omdia.
Yep.
Hello, welcome. And you cover a lot of interesting topics, technology, data center, IT, cloud services, covering foundational foundational concepts. Sorry about that, I'm having a difficult time reading today. Such as demand for data center computing, adoption of cloud services, and edge computing, with over 10 years experience as an analyst.
Yep.
Great. First of all, I was going to tease you because it said you covered both cloud services and SD-WAN, and I was wondering if that was a punishment or not. But
that's actually very, very good question. Good comment, I would say.
Really?
I would say, especially 2 years ago, I would say it felt like it, and I think, even speaking to vendors or service providers, SD-WAN was something that was confusing. It was very complex. It is, but I think the understanding was not there yet. I think that
right.
2 years ago. So I think that was the stage when I took over this topic. I think that's where the industry was at, kind of educating and for enterprises, to understand what is SD-WAN and what kind of benefits it brings. And moving forward, like past 2 years now, I think we've reached a level when the understanding is there. I think, quite a lot of enterprises have already SD-WAN. So for me as an analyst as well, it's easier because the conversations are way easier.
Exactly. Nobody's wondering what on earth is SD-WAN.
Yeah.
And I can identify because about 10 years ago, I did a bunch of coverage on software-defined networking.
Yeah.
And at the time, it was the same thing. I mean, I ended up speaking around the world, and everybody's like, what on earth is software-defined networking and why do we want it? Well, it was one of those things that was way too far ahead of the market, and by the time it figured itself out,
it was a concept before there was actual demand, and I think now everyone understands because there is a real reason, there is real demand for SD-WAN,
right.
Especially since COVID.
Yeah, exactly, and that's the thing that I think this is where it differs. I think SD-WAN offers a lot more in terms of services and flexibility for the customer than things like software-defined networking did. And again, software-defined networking was like a science experiment that escaped the lab.
Yeah.
Because again, that was what it was designed for. It's the ability to be able to play around with protocols without having to completely restart everything.
Yeah.
But ultimately, it led to a lot of development along the way in terms of, say, chaining services and stuff like that. And I got to believe
it. And with cloud now, it's a completely different conversation now.
Yep, and I got to believe it was a precursor to what they're doing with SD-WAN too, because again, the ability to be able to substantially manipulate the way your network environment operates and to be able to utilize multiple services without getting locked down with a lot of things.
Yeah, yeah.
So, first of all, I guess, what kind of penetration are you seeing now in the SD-WAN market?
So I think last few years have seen the biggest growth, and as I said, during lockdown, when many enterprises, a lot of corporations have to move to work from home, and since then we kind of stayed there.
Right.
The hybrid work mode is common, and with that, with this distributed workforce, the concept of SD-WAN has been absorbed way quicker, and it has been a few quarters now when we talk about uncertainty, recession, and how is that affecting tech? And speaking to SD-WAN vendors, they don't see an issue.
Yeah.
They still see a lot of projects. Of course, lockdowns have affected, maybe schedule, but they still see huge growth. And obviously, with now more conversation around security layers, there is even more demand and even more deployment. And again, with growth of IoT. The SD-WAN is just the easiest answer for companies to become more efficient, better, increase the performance, and give that, proper digital transformation for their.
Right.
For their
What's the vendor environment like? Because whenever you talk about a brand new technology like this, you see all kinds of little companies popping up. This occurred back in the software-defined networking days,
Yeah.
and it happens actually in every kind of technology. Whenever there's a new and strong premise, you find a lot of small companies jumping in. Are you
Yeah.
also getting the feeling that there's a lot of adoption within the traditional networking companies as well?
I mean, at least with SD-WAN, I think we've passed this phase as well, when there was many smaller companies that were specialized with SD-WAN taken over by larger players in networking.
Yeah.
So if you speak, if you talk about Cisco, VMware, HPE, you actually mean Silver Peak, you mean VeloCloud, you mean Meraki, you mean 128 technology. So the acquisitions, mergers and acquisitions in, especially in SD-WAN market, are happening. All the key ones acquisitions happened. So I would say we are seeing huge consolidation on the market at this point.
Right.
When it
So,
comes to
so now what are you recommending for customers these days? I mean, obviously there's some immediate benefits that can be found with SD-WAN. So the question is, at what point should companies jump into it? When there's time for a refresh in a network level, when there's a pricing differential, or when something seriously drops?
Yeah, I think at this point, lockdown and the pandemic has already changed the way how IT departments, networking departments are planning and creating the infrastructure. And when speaking to vendors, there is a huge difference between large enterprises and small enterprises.
Absolutely.
And how they plan their budgets and how they what decisions they're making around it. So surely the more distributed workforce has accelerated the shift towards SD-WAN. And now speaking to SD-WAN vendors, they are focusing more on SMB market.
Okay.
Because that was at this point
And
very
again,
much untapped.
well, that's where there's the least amount of technical knowledge available, right?
Yeah, exactly.
I mean, anything that can
They need
simplify.
a solution and start tomorrow.
Precisely, anything that can simplify IT for a small SMB. And it's always difficult, right? What is an SMB? Because
Yeah.
I've heard say, well, up to 500 seats. No, SMB is not 500 seats. SMB is 50 seats, maybe.
Yeah.
So ultimately, again, there's this whole varying market that could potentially be addressed by SD-WAN.
Yeah, exactly.
Right.
Exactly.
Let's and there is a crossover to what you also cover in IoT, obviously, because IoT is something that you've been focusing on as well, correct?
Not necessarily. I would say IoT is something obviously that naturally we have to cover because with the growth of IoT and distributed devices, that's where the performance of the connection is important.
Right.
So I think this is where as well SD-WAN vendors are trying to show to the market, to the customers, what are the possibilities is through the IoT. I think this is where VMware at the Mobile World Conference gathered a lot of interest because they've brought the Tesla car and show how they can help police send quickly videos from their police recording, having a little server in the back of the car.
Oh yeah.
So question is, how much audience was coming for the SD-WAN deployment or for the Tesla car, but it just shows, that with the growth of these devices, there is a need for better solutions for networks.
And plenty of potential looking forward, right?
Yeah.
I mean, ultimately. You also cover cloud. So
Yeah.
what aspects of cloud do you focus on? Because again, here's another gigantic
Huge,
topic.
exactly.
Yeah.
Exactly, yeah. I mean, we at Omnia, we are trying to follow, what our customers are looking for. So at this point, we're trying to cover industry clouds as a topic that, has been discussed in many forums, and it's quite interesting because we have two groups of people saying there are industry clouds, and those who are saying this is kind of a concept or something to talk about them, but not necessarily really existing in a real world when it comes to services. So when it comes to cloud services, as you say, it's a huge topic. So we collectively, as a team, cover it in a from different aspects. But from my perspective, at this point, what I'm trying to understand is what's going on with industry clouds. We now look at SaaS market separately from IaaS, and also we try to understand as well local markets.
Oh, sure.
Because all the research houses look at everything globally, but then we do talk to customers, and there is more conversations about local, right?
Right.
There is discussion on digital sovereignty. All the regulations around privacy, security, goes down to local countries,
Right.
right? To understanding the market locally. So we try to do as well more localized research.
Yeah, because that's always a challenge when you start talking about, I focus in areas in the APAC, and it had a completely different market than you looked at in Europe,
Yeah.
or when you looked even in the UK, and then huge differences between North and South America in terms of it. And again, it's not just from a data center standpoint, but it's from a consumer need that some of these things actually grow. I mean, you know, it was interesting in looking at the African market, where for the most part, most population didn't have any access to traditional banking, for example. Well, all of a sudden, a cell phone gives them access to services that they never had available before. So there's always going to be a growing market in the third world, for lack of a better term. But even it's evolving everywhere. I mean, through the EU and everything else, there's a lot more competition and there's a lot of potential.
And also a topic that was a theme of our on the analyst summit yesterday, so sustainability.
Exactly.
And you know, you have many ways to be sustainable, different layers to that. But at the end of the day, it's around resources. And if you combine all these sides of the sustainability, sometimes being local is the answer.
Right.
So as much as cloud brings that, you know, efficiency from being in one place and centralized, you know, processes, sometimes, unfortunately, to be sustainable, you need to stay local.
Right.
So.
And again, the cloud adds an additional factor in terms of availability, right?
Yeah.
I mean, ultimately, if you've got on-prem, you have a certain amount of control over that.
Yeah.
But from a cloud standpoint, what you're really buying is availability.
Yeah.
And that's a difficult challenge for people to get around. And I focused a lot over the last couple of years on BCDR and where cloud fits into that. Because business continuity and data protection, there is a lot of opportunities that come from the cloud that just weren't available before.
Yeah.
And it makes a lot of sense to be able to integrate that into your working environment. I mean, ultimately, I always believe that the best cloud is the combined cloud. It's the hybrid standpoint of, the stuff we need on-prem, we will keep on-prem. The stuff that we have the flexibility of moving elsewhere, but ultimately you have to look at the application.
Yeah.
Whether it's a latency issue, whether it is a security issue, or a nationality, like you were talking about.
Yeah.
Even simple things like recently I was, or actually years ago, I was looking at what things like GDPR did in terms of the way that you conducted business. And it changed a lot of things, but it's something that should have been considered right away. But it didn't really raise its head until it got big enough that people started having problems with it.
Yeah, and it's different between, as you say, regions.
Right.
So yes, definitely. I mean.
Yeah, it's we all spent, because the cloud evolved. We've seen a lot of cloud washing in the early days where, oh yeah, we're cloud. Well, yeah, just because you put it out on AWS does not mean you're cloud. Really, cloud is about a new way of addressing and accessing dynamic resources that wasn't available in the old days, except for what was being done in terms of VMware. But face it, the logical progression is to a more cloud-like environment for IT.
Yeah.
Typically, it's just a matter of, we have all these resources, you need to get to these resources, what can we do to make it easier?
Yeah, and I believe this is where industry clouds are about. It's more of like focusing on, finding those resources within the cloud as well, and help different industries, and especially when you talk about industries that are regulated, right? When you talk about, financial services have a completely different requirements and face different challenges when they do want to move to cloud. And then healthcare. So
you start looking at all the governance requirements, it's unbelievable.
So it's very complex, and it's just this one approach fits all. That doesn't work anymore.
Exactly. It's been a pleasure talking to you, Dominica. Thank you so much for your time.
Thank you so much for having me. Thank you.
And have the great rest of the show.
Thank you.
And now we have a word from the folks at DCK, and let you know that we partnered with, I think I've said that already, but we'll say it again. They've partnered with AFCOM to interview 4 of the DCW's keynote speakers. They'll be talking with Compass Data Center CEO, Chris Cosby, Oracle Industry Labs, Burson, and I can't get his name right again, an author and futurist, Kian Gohar, on Cloudflare's Rebecca Weekly. So check one of those out. One interview on DCW's own Master of Ceremonies, Bill Kleiman, and AFCOM's Jordan Sutliff. And now I have the pleasure of speaking with, and forgive me while I get my paperwork right here.
No problem.
You are Hector?
Yes.
Hector Diaz. How do you do, sir? Pleasure to meet you.
I'm doing great.
Excellent.
Nice to meet you.
And just a quick rundown here, you are an AFCOM member.
Yes.
Excellent. And honestly, it's weird because being an analyst in the industry for as long as I was, I wasn't at all familiar with AFCOM. So now I'm going to have to start keeping track of what's going on there.
Here's a pop quiz for you. What did AFCOM stand for?
And you know, I couldn't figure that out. In fact, I wrote an article for the latest digest that's coming out, and I still don't know.
So it used to be the Association for Computer Operations Management.
Ah, well, then it starts to make perfect sense, right?
Yes.
And that's what. How long is? What chapter are you located with?
I would be in the New York area chapter right now.
All right.
I'm out of New Jersey.
All right.
I'm a past board member for the Denver Rocky Mountain area.
Okay.
I got that chapter restarted with a few colleagues back 12, 13 years ago.
Right. Wow. Mm-hmm. It's excellent. I love communities like that grow organically. And a little bit about Hector, as a director for the data center strategy and architecture at Johnson & Johnson, you're responsible for the overall direction of Johnson & Johnson's owned and operated enterprise data centers, as well as third-party colos. And you have 15 plus years of experience in this crazy industry. Yeah. And again, welcome to the program. And I guess let's start out first of all with what type of data center environment do you have?
Okay, so before I answer that question, I have to make clear that I am here to speak as a member of AFCOM's Data Center Institute. I'm a member of the board of directors for that. I am not here officially as that's Johnson & Johnson.
Fair enough. Well,
representative. So glad to talk to you about the industry in general and everything. I cannot answer.
I can understand that. And it's worth, again, they didn't tell me that up front, so I figured the first thing I do is ask about where you're working and what you're doing.
Sure, absolutely.
So tell me about what you were speaking about, the program.
So the program, if you're referring to the Data Center Institute, it's a group of colleagues that are in leadership positions in both large and small companies internationally. And we are serving as a think tank, if you will, to talk about data center questions. So it's not unusual for one of us to get interviewed by someone like yourself and get questions about what does a data center look like 5 years from now, 10 years from now.
Oh, yeah.
Those kinds of things.
If we knew that, we would be too rich to talk to each other, right?
Right.
But again, the best thing that we can do is kind of keep up with it because the technology is always advancing. Face it, I can't think of any other industry where things move as quickly and as slowly at the same time, depending on what you're talking about. Because again, there's so many things in technology that haven't really advanced as quickly as other parts of it.
Right.
So, what are you focusing now as part of the group?
Essentially, one of our big contributions every year, you may have read a white paper that's been published for several years running. And it's called 5 bold predictions for the data center industry.
I'm making a note because I want to read that.
And essentially, we get interviewed by a professional writer working for the company that owns the AFCOM show and trademark and all that.
Sure.
And it's a lot of fun because we all come at answering these questions from very different angles.
Sure.
Like, I've got a background working with Fortune 100 companies, companies like today's HPE. I was there for many years.
Okay.
I worked for Oracle in the past in a position very similar to what I do now for Johnson & Johnson.
So my view of the world has to do with very large enterprise data centers,
Right.
and there's other folks in the group that deal with, very small. From my standpoint, I
Sure.
look at their data centers and
It's
I
like-
think of that it's a data closet.
Right, exactly.
But they're very insulted if I say that, so I try not to.
And again, you go into some places like a Google data center, and it's like a completely different world.
Yes.
I mean, even realistically, assuming that you work predominantly in a large enterprise level data center, there can be a massive amount of equipment there, but ultimately it's a different type of equipment than you'll see in, say, a cloud data center. I guess the first question is, what are the 5 bold that you came up with this year? Let's drill down that, because I'm fascinated by that.
I wish I could remember them all, but an interesting prediction that was made was that cloud repatriation was very real and starting to take place throughout the industry.
Wow.
And it's interesting because I just walked out of a session where they were talking about this.
And it's something that they've been talking about ever since really the cloud showed
Right,
up.
right.
And it's partly because the cloud was kind of pitched as, well, this could do anything all the time, when we all know, when we're from the inside looking out, we know it's not true.
Right.
But again, it's gotten better, right?
It has gotten better, and I believe that some of what we're seeing in terms of cloud repatriation, if you look at the real numbers from the large 2 or 3 operators, they're all growing. So if repatriation were so big,
You'd see it.
You'd see it, but you really don't. So
Right.
either there's a lot more newies going in and a few people that have been there for a while getting out,
Right.
or the people that are pulling things out, it's significant to them, but not
But not
large
to the
enough to put
larger
a
industry.
a dent on the industry leaders.
Right. And ultimately, because there's a number of reasons why the cloud doesn't work. And this is something that I always spoke about, because I started covering cloud, 15 years ago now. And ultimately it's like any other big name technology. The movement is like, yeah, this is going to change everything. Well, the cloud actually did. And I think what the cloud did better than anything is democratize technology.
Yeah.
You can go out and you can get time on basically a supercomputer with a credit card. You don't need to buy a supercomputer, you don't need to set up and run it, you just need to get access to it. So really it became a new model for access to services that I think leveled the playing field for a lot of different companies, because they really didn't have to invest in the skills and in the technology that was now available on the cloud. But not every production environment was ideally suited for the cloud. And whether it's a latency issue or a cost issue or a security issue or whatever, do you see any particular trend in terms of what's driving repatriation?
I believe the number one reason that I see for repatriation is end users perceive costs not matching their expectation. And I kind of have built my own model to explain to people what's happening.
Sure.
And the way that I explain it is I ask you the question. Let's imagine you're hosting a party. Let's say you have a daughter getting married and you're contemplating as part of the festivities, the reception that you're organizing.
Sure.
You're contemplating whether you want to provide alcohol to your guests or not, right? And there's 3 ways you can do it.
Yep.
You can have the open bar.
Right.
In which case everyone can drink as much as they want and you have no idea how much it's going to cost you.
Right. Which everybody loves, but
exactly. Or you can say, I want to be a nice guy, but I don't have unlimited amounts of money to pay for this, so I'm going to give every person 2 drink tickets, and I limit my expense, and if anyone wants a 3rd drink, they can pay for their own.
Precisely.
Or you can say, yeah, I know people like drinking, I can't afford it, so I'll just provide a bar.
And then you could
and you can
take
buy
care
your
of
own,
yourself.
right? So in cloud computing, what I see is a very high correlation in terms of people that are not happy with what they're spending and people that have implemented an open bar for
right.
their cloud compute. So what I think is really happening is a lack of governance. And even though vendors have tools that can help you figure out how much you're spending, it's not in their best interest that you use them regularly.
Yeah, right.
Right?
Why would
So-
we want to limit our income, right?
So who knows, for companies that are looking at out of control cloud costs, how many of their employees are uploading cat videos or personal pictures
Right.
or the latest novel they're writing or using cloud-based compute to develop software for a new company they're launching
Right.
as soon as they turn in their resignation notice,
Right.
Never mind, and another thing that I tell people is we all in the industry get stock options for getting things implemented.
Right.
Launching something, installing a system. No one ever gets stock options for cleaning up. So what happens is there's a lot of developers that spin up test and development environments, and they stop using them, but they don't decommission them.
Yep, exactly.
So I am paying for that. I heard an example at one of the sessions today of a company that had a group with a $150 million budget, and they got stuck with a $400,000 bill
Wow.
for cloud services because they left all of their
Left it
devs
run
and-
once they went away.
Yeah, exactly.
Wow, it's and again, it's easy enough to do. And the beauty of the cloud, I believe, again, is the availability of services and the ease in which you can get to them.
Right.
But that comes along with an underlying complexity that needs to be followed up on as well. Unfortunately, people aren't as good at cleaning up after themselves as we would like.
Right.
And this is true of all types of users, all types of production environments. So getting a handle on the costs that you're spending in the cloud, I would have to agree, is one of the major challenges. And much less so, but something that people still talk about is shadow IT.
Yes.
You know, I can't get my IT to either cooperate or get me
Here's
what
my
I want.
card.
Yeah, exactly. And then I'll just invoice it. You know, I bill
show
it
you.
petty cash. Yeah, exactly. You know, and I admit to kind of being rebellious about that too, because you know I go back to the early days of computing. I was a BBS sysop back in the 80s. So to me, it was all just things that I could do because I really liked doing it. And when I got into a corporate environment, I was like, why are you keeping me from using this technology to the best of our ability? I'm not ripping you off or anything,
Correct. Yeah.
you know, but why is it so hard to get something done? Well, part of it was because they were a mainframe-oriented company. So, you know, I didn't know, want, need, or have any interest in the mainframe other than from a technical fascination. But as things progress into client server, it still became a challenge as to what are people doing with this equipment, and once you get it in the cloud and you take it outside of your firewall, as it were, then it really becomes difficult to keep track of what's going on. Have you had a lot of experience in running into shadow IT like that yourself?
Yes. Again, I've worked for both Fortune 100 companies. I've worked for little startups with 50 employees or less.
Sure.
And in both cases, you see shadow IT just because people perceive they need to get something done. Again, they get their stock options based on getting things done, getting something deployed, and they can't wait for your purchasing department to go get competing quotes amongst 20 different vendors,
Right.
and on and on and on.
Because I could see both sides of that argument, but yeah, it's, you know, I think that was a little paranoid at first, but ultimately, until you have to write a check for it,
Exactly.
doesn't make sense.
Yeah.
I think that's all we have to talk about
Okay.
today. Thank you so much for
Thank
your
you
time.
much. Good
Pleasure
meeting
talking
you.
to you.
Okay.
Have a great show.
Thank you. Bye.
And are we taking a short break? Thank you. Sorry about that, everybody. We'll take a short break and we'll be back with more guests in a bit. Welcome back to DCW World and Data Center Knowledge and a live show here in Austin, Texas. And for my next guest, I have the pleasure of speaking with Carrie Getz, correct?
Yep.
Carrie Getz, who is a fellow nerd and an educator extraordinaire, as well as a consultant and analyst, and a person who can think their way through all of the complexities we have to deal with today. Am I right there?
I try, yeah.
Excellent. Carrie is a principal and CTO of Strategicom.
Strategicom.
Yep. There we go, thank you. And with 40 years of global experience designing, running, and auditing data centers, IT departments, and intelligent buildings, Carrie is a fractional CTO. Now, I can't imagine you being fractional, but I would say okay. Yeah, right. And multiple companies, international keynote speaker, published in 69 countries, 250 publications, and honorary doctorate in so many things. I won't even go through all of them. Literally, you have more acronyms than I have seen in ages. And the coolest is the Master in Infrastructure Mason. Now, that's a secret handshake I want to learn sometime. A Master Infrastructure Mason with 40 plus certifications throughout her career. Welcome, Carrie. A pleasure to talk to you.
Thank you.
What brings you to the show this week?
You know, I've been a long supporter of this show forever. I truly believe what AFCOM's doing. And to me, you know, the cool thing about this show and other shows like it is that this is kind of one of the longest running apprenticeships ever, this whole industry, right?
Exactly.
Because the curriculum's not there. We all learn from each other. We all kind of build off each other's things. And so these shows are a great way to figure out what the new stuff is happening, what struggles people have been through, what worked, what didn't work, catch up with all your friends in the industry. So yeah, that's why I'm here.
Honestly, the meeting of the minds is always really awesome, and it's great to see an industry where people are willing to do that within the limitations that they have, because obviously
outside of non-disclosure agreements,
which we have signed many of. You know, ultimately, it's a matter of it's great to find an organization like AFCOM that allows people to get together and share information like that.
Absolutely.
So you're an AFCOM member. Where located?
I'm right outside of Tampa, Florida.
Tampa, Florida, nice place to be for the most part.
It is.
Unless it's really hot. I went to Tampa Bay, I spoke there about 3 years ago. The hottest it had been in like a decade. It was like 110 outside.
You know, they did invent air conditioning.
Oh yeah,
we use them in data centers.
But
it's a great thing.
I was like, but you can't walk out of the hotel without nearly passing out in the first 10 steps. So yeah, you're right. Air conditioning is definitely one of the cool things about data centers and the world that we have today.
Pun intended.
Yes, exactly. It's interesting to talk to somebody who's been covering data centers for a really long time. Like you say, 40 years. It's amazing how we get drawn into this. So what brought you into the data center in the first place?
I totally fell into it like everybody else, because you know the industry didn't exist back then.
Nope.
And I was actually teaching in college, and I was teaching engineering classes, and then CAD came out, and I started writing code for CAD.
Sure.
And then one thing led to another, and they had a project. They wanted to tie a bunch of campuses together and asked if I would take on the networking portion, because nobody knew what networking was, right? It was brand new, back in the old frame relay days and the baud days and the dial-up and all that. And since I wasn't afraid of a computer, I said yes.
Sure.
And I have been in the industry ever since. I consulted. I started a lot of networking divisions for a few companies. I was in sales for a while. I was a consultant for probably the biggest majority of my time. I've done a ton of training exercises. So yeah, I've been all over. I worked for distribution. I worked for manufacturing. Done a little bit of all of it.
It's the important thing is having a good conceptual understanding of where technology fits.
Sure.
And how it evolves, right? Because ultimately, there's things that we could do now we would have never tried in the past. And there's things that we
do now that we did try in the past.
That's right.
It's very cyclical. It came right back around. Yeah.
And I think it's like a 7-year cycle, but it could vary based on the type of the type of equipment we're talking about. First thing is that I understand you have a book out, a new book out.
I do.
What's the title, please?
It is Jumpstart Your Career in Data Centers, featuring careers for women, trades, and vets in tech.
Excellent.
Yep.
Well, that's nice. It's love to see more diversity in the data center.
Well, I think diversity is important, right? Especially if we talk about some of the current topics like AI. We have to have that diversity.
Oh, yeah.
We have to make sure that everybody is represented, not just the people you agree with or, you know, the people you don't agree with.
Although it's easiest with people you agree with.
But, you know, you think about it, everybody's needs for technology are different. I've got, you know, family members that are neurodiverse. Their technology needs are different. 5 people in the same friend group are all
Right.
going to have very different. So we have to make sure that all of the diversity is there. And I tell people, my opinion for diversity is really you have to think of it as fingerprints.
Right.
Because that's really how different we are and how many people need to be represented in this industry for it to be right. But my thing was, I started looking, I was talking to some students, and I said, I was going to give them a book on the industry.
Right.
There wasn't one. There was one book that was 800 pages, co-written by 59 people.
Oh my God.
And I thought, well, this is great for a textbook, right?
Sure.
When the curriculum comes out, but what it's not good for is to tell anybody what the industry was. So I kept it intentionally short, digestible in a weekend. It covers the entire ecosystem so you can figure out where you are in the pieces and parts. Pay attention to the stuff that matters, to you, but at least understand where you fit, have those conversations, and hopefully, as young people start out, whether they're thinking about the industry or even the ones that are in the industry, your first day on the job, how much
Right.
better would it be if you had some background and some
Exactly.
context?
A
And then
conceptual understanding of what's going on around
Right,
you.
right. And then you can participate in a lot of those conversations that otherwise you'd be the deer in the headlights,
Yep.
So yeah, that was the intent.
Yeah, if you're afraid of technology, this is not the business for you. I mean,
Yeah, right. Or you're going to get unscared really
I'm
quick.
scared
Yeah,
really
yeah.
quick. And again, my path is the same way you were. I was a hobbyist back in the 80s. I ran SysUp BBS.
Oh, there you go.
And literally, that was before the internet. We were
Yep.
sending messages around the world in 2 days using 1,200 baud modems.
Yep.
And now it's like a completely different world. But the things that we did back then are still relevant today
know.
because people still communicate in the same way.
You know what would be funny though? Is if you took a whole bunch of students, young students, and played the modem noise. And just left the room by itself with the modem noise out there, and just see how long it takes them to freak out.
That's right. Somebody described it as a robot being tortured.
Oh yeah, that's pretty true.
Not a
Actually,
bad
just
one.
about yeah.
That's so.
I could go for that.
Yeah, it's funny how these things have progressed, and again, it comes down to establishing a decent understanding of the way technology works, what it can and can't do, and how it integrates with humans. Because realistically, that's the only true value that our systems have.
But see, that's where the innovation comes in.
Right.
When you put that spark in somebody's eyes, or somebody thinks along different lines, and that to me is really why diversity is so important. If you take somebody that's really good with their hands, and you put them with somebody that's really good at drawing, and you put it with somebody that's going to use it, you're going to get a much better product than just having a guy that draws it and then handing it off to somebody, right?
Exactly.
Because all of this interaction happens, and people talk about how they would use it and what it means to them. And I think for technology, that's the big thing. Look at the kid that made an artificial arm for his friend on a 3D printer and then made it available for everybody.
Amazing.
How great is that? But that to me is really the fire that lights in technology. That's where I get excited.
Absolutely, and again, it's that innovation that. And when I first got involved with corporate IT, enterprise IT, it was a little stifling, because I came in, I had been doing everything on my own, and all of a sudden it's like, well, you can't do this and you shouldn't do that. It's like, why? And it's like, no, we don't have time to tell you why. We just don't want you to do it. And I thought, you've given me this perfect opportunity to do some really amazing stuff, and you're telling me not to do it. What is the point? Fortunately, I believe corporate IT has gotten better, and part of it is because they were kind of forced to. The cloud made, I call it the cloud really made technology democratic, right? Is that no matter what you wanted access to, you could literally go out and find it somewhere. You didn't have to get approval, you didn't have to, go through costing, you could just go out and do it online.
And you didn't have to do it right, which became a big problem.
Which is exactly right. And again, that's the one issue I always had with Shadow IT is that it's fine to try and be a maverick about this stuff, but there's some perfectly good reasons why there's things you shouldn't do.
Sure.
And ultimately, people are never really interested in learning that. They just want to get what they want done.
Oh yeah, yeah. Well, and I think too, shortcuts are there. There's reasons you can do things that are helpful, but you have to test. You still have to put it in the right environment. You have to, do no harm. That should be, doctors have a Hippocratic oath. I think people in technology should have the same one. Just do no harm. Do the right thing. I think some of these people that write viruses and malware, if they focus that energy on something constructive.
Useful. Oh man, so
holy
on
cow,
board with that.
right?
And again, you kind of understand what that psychology is, and You know, people ask me, why would somebody write a computer virus? And it's like, well, why does somebody spray paint a nasty word on a building? You know, I mean, it's a mischanneled destructive or constructive process. And getting people into doing the right thing. And that's something I actually asked Michael Dell at a program about 5 years ago, is that the one thing that you don't see spoken about any time is ethics in computing.
Well, okay, so I'll go one farther. Ethics in computing and consumption as a consumer. We teach people how to consume tech, right? Because now they're currency to the whole entire technology world. But we don't teach people what their footprint is.
Right.
We talk about the carbon footprint. We know it's a problem in this industry, but there's nothing that says, hey, student, if you want to send this Snapchat, I did this with a group of students the other day. I said, I want you to go out and look up right now how much power it takes to do one snap.
Right.
And I said, then I want you to take, how many snaps do you think you do a day? And they said, oh, you know, some were 10, some were 20,
right.
some were spending
Yeah.
too much time on Snap. And I said, okay, now take that and multiply that. Now multiply that times 365 days. Now, how many people are on Snapchat? And we looked up what happens in an internet minute. We looked up how many people. I said, now multiply it by that many people. What is that number?
Right.
I said, now back that number out. How many households could have power for an entire year
With
on
just that
number? And holy cow, they were like,
oh my God,
I can't
right.
believe, what? This is crazy. And we started looking at, you know, kilowatt hours but all of that is important, and I think we have to teach people how to be better consumers. We have to teach people how to use tech for good and how to be kind. If you look at, you know, suicide rates of kids right now and some of the ways that technology is being used to be harmful,
Right.
I think it's terrible, and we all, as the grown-ups in the room, need to sort that out and make it better.
Oh, absolutely. And it's, again, one of those things where this can be for good or for evil, like anything else.
Yep.
And again, it's a matter of helping people understand where the line is, because it can get blurred really easily.
Can.
You know, it's I'm going to pirate this song or I'm going to pirate this game. Well, does it hurt anybody? No. Does it hurt
It
anybody?
does. It
yes.
hurts the person. Yeah.
You know, because again, it's not as
It's somebody's
clear.
work, yeah.
Yeah, it's not as clear as it should be, and it's kind of unfortunate. And I don't think that we've done the best job of doing that. I think, you know, education is focused on key issues, which I
Sure.
completely understand, but ultimately understanding a philosophical approach to the world, understanding an ethical approach to the world is something that we should be instilling in our students,
for sure.
especially on the IT side of it, because it has such a major impact worldwide.
It does. It does. And it's going to have an even bigger impact with AI and some of the new stuff
Oh,
coming
yeah.
down the pipe.
And that brings up something we were talking about a little earlier, is AI. And, you know, again, I completely understand why it's an important and interesting topic, but I think it's also a little dangerous. And I don't think that we're respecting that as much as we should.
Oh, I think it's a lot dangerous. When you have people that actually help develop it say, hold on, we need to put the brakes on it.
Should tell you something.
Maybe you should listen to that. No, I do. I think AI has the potential to do a lot of really great things.
Right.
Medically, you know, coming up with diagnosis for weird diseases that people can't figure out what it is, and better drugs. I saw today where they used AI to come up with a drug that would help a certain medical condition that had kind of stumped them in the past.
Right.
So I think it definitely has the potential to do good. We need to make sure that humans can always pull the switch.
Right.
We also need to need to weigh our convenience against our right to privacy. And,
Precisely.
you know, granted now nobody really has privacy anymore. If you're online, you have
Yeah,
no privacy, right?
So long, it's gone.
But we as humans need to be able to put the brakes on that and say, hey, I'm willing to give up this much, but you don't get to get the whole kit and caboodle, right? And I think AI puts a lot of tools in nefarious actors' hands.
Right.
And it's like the radar guns and radar detectors, right? You've got to have that checks and balances.
Yeah, and that's a hard thing to establish in the technology industry. This has been an awesome conversation. It's been a treat, Carrie, talking
Absolutely.
with
Thank
you.
you so much.
And have a great rest of the show.
Thank you. Thank
I
you.
hope run to you again sooner
We
or
will,
later.
I'm sure.
All
Thanks.
right. Take care.
Take care.
And now, perhaps a word from our sponsors over at DCK. Oh, at DCK, we enable data center operators to build resilient, cost-effective, and secure facilities by offering information and energy source information on latest target design trends, regulatory issues affecting data center industry, energy sourcing, and with a focus on Bravo, renewable energy, sooner not later. And here is the man right here. Time to move over and let the big dog eat. This is Bill Morelli. How do you do, Bill?
Pretty good.
He's
Nice
a good
to be
man.
speaking with you again,
yeah,
Steve.
finally. We've spent time on the phone a lot and on the web a lot, but this is the first time I've ever been able to see you in person. How you doing? How's the show going?
Show's going fantastic. Very excited to be here, and obviously the Omdia Analyst Summit yesterday was a big success for us. A lot of great interest from the audience, and now getting ready to open the expo hall and get the next stage of the show going.
Excellent. Bill is the chief research officer, which is the chief cook and bottle washer, right? I mean, all technology goes through you, right? Yep. As head of enterprise research sector, Bill manages core strategies, as personnel analysis, commercial planning, and pretty much everything. His focus areas include AI, cloud and data centers, cybersecurity, enterprise IT, and IoT. He specializes in IoT use cases, which I completely appreciate, and looking at convergence of technology trends. Welcome to the show. As Chief Technology Officer, you have a bird's eye view of all through the internet, all through the data center environment. What are you seeing that's the most interesting? What is the most intriguing on that? Because it's not easy to say, right?
Sure. Well, it's constantly evolving.
Right.
You know, we were talking yesterday when we were at the show last year. Everyone was expecting metaverse was going to be the big thing that was impacting data centers.
Not so much.
That kind of fizzled out a little bit.
Right.
But what we're now seeing out of nowhere is generative AI. It's taking over the conversation. So now this year, very sharp focus on, okay, how big is this going to get? How much of an impact is there going to be to data centers? How much do we have to create capacity for that? Or can it be absorbed by existing capacity? So I think that's the interesting piece for me in my role is it's not always the stuff you think is going to happen, it's the stuff that comes out of left field and all of a sudden the technology made a significant advance and now we put a much heavier burden on the data center to carry the load.
Right, because unlike a lot of industries, things can change in the time. You know, you can spend so much time planning, you can spend so much time getting things set up, getting an environment working, and by the time you've gone through that, it's entirely possible that it didn't work out. I mean, if you look at, and again, I recognize the challenges Meta had to deal with, but they had already in the process of building another huge data center in Mesa, Arizona. I mean, a huge facility, and the question is, how will they be using that now? And I'm assuming that, ultimately, whether the metaverse plays out as they thought or not, there's still a lot of other things that Facebook et al. Has going on in the industry, and they've got some really great facilities and some smart people doing that.
Well, I think that's the key point, and certainly one of the key messages from this show. Data centers are fundamental to how we do business today. It doesn't matter that if you're in manufacturing, if you're in retail, if you're in insurance.
Right.
There's some elements of cloud and data center that you are relying on to do your job on the day-to-day. And we certainly saw during the pandemic that was reinforced tenfold. So the exciting part about this is it's an industry that's only going to get more essential as we move ahead.
Right, and I have to believe, and I've always said that the COVID epidemic really we could have been in a lot more trouble 5 years or 10 years earlier. But we are fortunately in the position where enough workloads, enough communications and connectivity was available via the internet that we were able to make a really rapid adjustment relatively quickly. 100%. The same thing happened to you and your team, right? I mean, ultimately,
absolutely.
We've spent a lot of time flying around. I mean, I was on the analyst side too, and you end up doing 8 weeks or 9 weeks of travel a year, and then it's gone. But you still need to be able to keep that contact. Unfortunately, that was difficult back in the day, but now we're getting back to it again. I believe DCK, not DCK, but the data center world was one of the first ones to restart after COVID.
We were very early on. We had our first kind of post-COVID show in August of 2021, which was a good start. Last year's show was here in Austin for March of 2022. Great showing, and the community really came out and supported it. This is a group that really likes to get together in person, show each other the latest technologies, learn from each other. It's really a community that tries to help each other grow and sees it as a community effort.
Right, and I know we touched on this on the way in, but let's circle back a little bit because, again, you have a view of everything. So looking forward, and we're in 2023, we're almost halfway through it. what are you seeing in 2024? And again, obviously this AI issue is going to be big. You know,
Yes.
and these buzzwords come up in the industry all the time. And I could see AI evolving in such a way that it actually becomes useful for a lot of things. But the question is how to avoid it being used for the not so useful things.
So that's going to be a whole minefield. I think we're going to learn. We'll stumble our way through, as usually happens with a new technology.
Right.
There's going to be, right now there's a lot of excitement about it. We'll see some people trip and make some mistakes. We'll see some course corrections as folks figure out, okay, what's the best application for this? What's the right fit for generative AI where it can really solve a problem? We're seeing a lot of applications in basic coding where bringing in generative AI really does increase efficiency, increase speed.
Right.
There's other types of applications where it's less clear how much of a value add generative AI is and when it starts to just become an echo chamber. It's not creating a new idea, it's just synthesizing a lot of existing ideas.
Exactly, and I always found it interesting that even when analytics first started showing up, that how soon will the analytics you make start affecting the new analytics that you're getting, right? So when do you start finding out when the analytics is actually, like you said, an echo chamber? And the same thing holds true with AI to a certain extent. In doing research on this myself, I find that the most frightening thing about AI is the algorithms and the packages that they're using. They're kind of a black box. And one of the biggest challenges of getting that AI needs to surmount is getting rid of bias. And it's hard to find that because again, when you look at the nature of all the data that they're pulling, everything they're trying to pull in to do this AI, more is not always better. And there needs, and again, I don't know how to do this because it's a very complex problem, but how do you find the right data to use as your sample sets to begin training these systems?
Well, there's a lot of work that's being done with what are the right ways to create synthetic data sets, and that way you can try to manage that bias and have it, but still have a data set that's useful for training. There's, I think, a lot of oversight and work that still needs to be done around the governance of AI and ethical AI, and that's one of the things when our Omdia research team that specializes in this has a lot of focus on and attention on, especially now where we're seeing this significant leap forward in the capabilities. I think transparency can be a really key piece. As you said, a lot of those algorithms become black boxes because that's then the secret sauce for the company behind it. So it's kind of balancing that need and understanding the commercial reality of the business with how do we make this as transparent as possible so that we've got confidence in what the AI is telling us, what the engine and the algorithm is telling us.
Because I remember reading, and I mentioned this earlier with another speaker, was that IBM had a slide, and I want to confirm it, that said, do not leave important decisions to a computer because there's no one that can be held responsible. And especially when you start talking with issues that affect humans. And face it, most of our technology decisions are now affecting people.
Yes.
So the question is, what are the checks and balances that need to be in place? And it's hard to say because realistically, we don't have the tools yet for that. I remember when I first started looking at quantum, and the one question I had is that, so what tools do you have to look for bias? And it's like, well, we don't have tools for bias yet because again, it's still too early. And as humans, we do that. We rush forward on really cool stuff because that's how things get done. But then the ramifications start coming in, and that's the one thing I think we need to be aware of. I don't believe that most computer college curriculums involve ethics. And it would be interesting to find out if that is a part of most education when it comes to IT in general.
I think we're going to see an increasing focus on that, particularly around AI.
Right.
And that is certainly ethical AI has become an actual topic of conversation, not just two words that are strung together. But that's actually a field of study now that people are focused on, and they're looking at what are the best ways to use this technology. These aren't a group of Luddites. These aren't folks who are afraid of technology. They're looking for the best way to use the tool in a responsible way.
Right.
And so it's a real passion of Natalia Modeska, who's our AI research director for Omdia. And so you'll see a lot of content from her kind of around this topic as we look at, what are the governance structures, what are the management structures that you want around, whether it's generative AI or traditional AI.
Right.
it's the same conversation for all of it. What's the right way to use the tool? What's the right way to train the tool? And how do you make sure that the results you're getting are the results that you want?
What we need is a reality checksum. I think it's
Yes.
that you can hold it up. Oh yeah, okay. Well, we're close. Because again, all of this starts to get into some really gray areas. Because again, the world is not black and white, and digital computers are. But the quantum environment is going to be back to an analog environment again, where the best it can do is give you really good guidance really quickly.
Yes.
And that's what, again, I've been following quantum, you've been following quantum.
Yes.
There's still a ways to go, but it's amazing what it'll be able to do when it actually gets here. So, and shifting the tone a little bit, what are you seeing in terms of embracing diversity in the data center and IT in general?
So I think you certainly can see it at the show.
Right.
We've been having the Women in Data Centers reception for the last several years at the show. I think it's a really good way to showcase just how much the industry has changed in the last decade, and we're continuing to see that. Carrie Getz, your last guest, was a fantastic example of that.
Right.
And Carrie certainly has been involved in the data center industry for years, but for many meetings, for many AFCOM meetings, for many data center world events, she may have been the only woman who was representing the industry.
Exactly.
And now we've got actually a whole group of women who are in leadership roles at companies, who are driving innovation and change, who are engineers, who are developing the new technologies. They are playing in every facet of the industry. That's not to say job done by any means.
No.
And I think that's the key thing for us. One of the things we implemented for the Data Center World event was our Gen Next Advisory Board a few years ago. And that was a really conscious effort to go out and hear from younger members, a more diverse group of members who are just coming into the data center industry, which historically has been fairly conservative, fairly staid, and say, okay, what are you looking for out of these events? What kind of meetings and networking opportunities are you looking for? What kind of career opportunities are you looking for? How do you see that evolving over time and bringing a different and a fresh perspective to the conversation? I think the industry as a whole has been very willing to embrace that for a variety of reasons, not the least of which because a lot of folks are aging out of the industry.
Right.
And we're now actively looking for, okay, where's that next generation of folks
Right.
who want to come into the data center space?
Right, that can share the fascination and enthusiasm about it, but also bring the brilliance to it. Because again, this is where we get all of our great stuff from, is people who are brought into this, who love it, and because it really speaks to them. Which is an interesting point that we talk about as well, is we're looking at, and have been looking at, a shortage of personnel at data center level, at IT group level. Are you seeing any shifting in that as well? Because obviously COVID changed everything. There are a lot of people that just didn't go back to their jobs or were exited out from their jobs. What are you seeing now in terms of new people coming up? Are you seeing that that a lot of these jobs are being filled now?
It's an interesting time in the industry, as you well know.
Yep.
Certainly we're all aware that the tech industry in the last 6-8 months has been going through pretty significant shifts. A lot of tech companies pulling back, a lot of layoffs happening in the space. A lot of those are highly skilled technical people who are looking for different roles in the industry. I think that in and of itself creates an opportunity. If we've got roles that people can reskill and retrain for, and certainly now people don't view careers the way they did 40, 50 years ago.
Exactly.
Right? I'm going to go work for Raytheon. I'm going to work for them for the rest of my life.
And I'm going to retire and go down to Boca.
Exactly. And now folks are like, well, look, I'm going to do this for a while, and that's really interesting.
Sure.
Industry's going to shift, technology shifts. I'm going to do something different, and that's interesting too.
Right.
That doesn't mean that we don't need to still bring new people in. It's not like you go to college and you see data center on the curriculum. One of the things we do here at the show is we've got a power-up program where we bring in high school students. We have data center professionals who come spend the afternoon with them, talk to them about this is what working in the data center industry is like. This is what being in a data center is like. These are the kind of roles and jobs you can have, and they get folks excited about that as a career and see it as a real career option. So I think those kind of programs are increasingly important for us to help address the issue.
Yeah, to instill a sense of wonder about this, to find a connection to what technology is. I found it years ago. I was fortunate enough to do it, and that's the way the world has gone. And that's all we have time to talk about today. Bill, it's a treat talking to you again.
Very
you have the
much so,
rest of the great show, and I'll see you again, I'm sure.
Excellent. Thanks,
Take
Steve.
care. And are we on to another guest? All right. Oh, excellent. And our next guest here, are you John?
Nope.
Nope.
Butch.
Butch. Oh, okay. I'm sorry. They added some people for me today, and I need to be sure I've got the right person in place.
I can be John if you need me to.
Okay. Well, yeah, that's the way I am too. Is that if you can give me a minute, I'll come up with any kind of personality you want. Thank you very much. All right. Yeah, okay. I see that I did. That's my fault. Apologies, Butch. You are from the University of Kentucky. Did I get that right?
Yes.
Excellent. I was going a little bit about the University of Kentucky. It was founded in 1865 by John Bryan Bowman, who was as the Agricultural and Mechanical College of Kentucky. The University of Kentucky has the highest enrollment in the state with 30,000 students or more, perhaps now.
About 32K now.
Yep, and the institution comprises of 16 colleges, a graduate school, and 93 undergraduate programs, 99 master's programs, 66 doctoral programs, and is classified among the doctoral industry, doctoral universities with the very high research activity. So that makes your life incredibly interesting, does it not?
Most days.
I would say, and of all the different areas that I talk to in IT, I think that the academic is probably one of the most complex, partially because you've got so many new and interesting minds looking at and accessing all of your equipment, but also from a research standpoint, being able to step to the edge of the envelope is got to be fascinating for you. So what are you involved with? You've been there for 22 years, correct?
Well, I've been in the data center for 22. I've been at the university for 39.
Oh, no kidding. So did you start there academically and then move through?
No, I went to college at Eastern Kentucky University because they had what I felt like was the best electronic program at that point in the mid-'70s, and just ended up working at UK. And I've always been in some form of IT.
Right, and your career and mine, I think, are very similar because I just found technology in the middle 80s and just grabbed onto it. So I started building computers really early. I was fascinated by where the technology was going. I ran a BBS. It was all these things that, once you stepped into it, technology just carries you away, especially if you like it.
Right. Well, it's interesting the things that we've seen then because, I mean, I remember 8-inch floppies.
Oh, yeah.
And the first hard drive I ever saw was a 5 meg Winchester that cost about $6,000.
Oh, no kidding. Yeah, I still have the first terabyte or gigabyte drive I ever bought, and it was, it weighed probably 20 pounds, and it was, but it was so much data. We thought, well, what are you going to do with all that space? And I was in photography at the time. I said, I'll fill it up in probably a year and a half. Everybody thought it was crazy, and now what the average hard drive these days is 5 to 6 terabytes. That is, it's moved along like that. RAM, everything else has been evolving along the same way in the data center. So let's go through a little bit of what you do at the University of Kentucky.
Well, my primary responsibilities are the data centers, power, cooling, space, access control, the physical aspects of it.
Right. Layer one, so important.
Right, yeah. I don't really determine what goes in. It's my job to make sure it can be turned on and kept cooled and kept
stays
online.
On. Exactly. So how good are they at involving you in the decision-making process? Because again, this is the one thing where, okay, our facilities guy, they just take care of us. But ultimately, it would help if you were part of the planning process, if you were part of the development process as well. Do you find that you get that opportunity?
Most of the time. We still get surprises every once in a while, but over the year, we've gotten people to understand we need to know ahead of time what's coming in to make sure we have space, that we have power.
Right. What kind of data center environment do you have now?
Well, we have two facilities. One's the basement of a building built in 1928.
Oh, nice.
And the space has been many things over the years, from a lunchroom to offices to some other stuff. And then the second space is the basement of a parking structure built in 68 that started out as a GTE telephone switch.
Oh.
And has involved, it's our communications hub, I guess you would call it. That's where all of our main fiber drops are. Or still have a phone system there, but it also has some research computing, some enterprise.
Well, and it's really nice. Obviously, I've seen a lot of repurposing of these telecom environments like that. A lot of the challenges are kind of taken care of, like you say, connectivity, but then there's also switching over from telecom to what data center technology is. Telecom used to be all DC voltage, it was all a completely different type of environment, and now you're using, I'm assuming, standard data center technology for everything.
No.
No, really?
We still have a 5E analog telephone switch that we're trying to get rid of that has a pretty good sized DC power plant with it. So we're still moving lines off of that.
Yep.
I want the space. That's 2,200 square feet of space that I want to repurpose for racks. So that's a project that's ongoing. You have challenges with, you're going to add more equipment. You need the power, but you also need to be able to cool it.
Cooling,
which means space. And in the parking structure, space is at a premium.
Oh,
so
no doubt.
It's difficult if you need to add a condenser or something. It's difficult to find space for that.
Right. So is it mostly raised floor, or is it?
The parking structure's on slab.
On slab.
The other building, McVeigh, is on a raised floor. 2/3 of it's a 12-inch. The room with the research computing is an 18-inch.
Right. So how are you dealing with some of these high-density environments, right? I mean, because, it's easy to see a 40, 50 kilowatt rack show up, isn't it?
On paper, we've got 40 kW racks on paper, but they don't pull that.
Right. And again, there's a lot of variables involved in that.
Yeah. Well, there's spec based probably on max config, max usage, and in real world, it's probably about 60% of that probably is what you see.
At this point, because again, that can vary based on the amount of research or whatever projects are running on it.
Yeah, but our higher density loads, we have in-row cooling in addition to cracks, or we couldn't handle it.
Yeah,
otherwise.
that's the only way that you could deal with it, especially in an environment like you have where you just can't move things around wherever you want. So basically it allows you to isolate some of these higher loads, right?
Right.
Are you doing anything like hot aisle containment?
Yeah, and most of the places. There's a few things we can't move.
Yeah.
So, but in general.
Like that telephone switch.
Well, yeah. But for in the higher density areas, we actually have kind of poor man's containment. We
Sure.
have plastic strips that we use to help contain the cold air.
Yep.
And that helps us keep it under control.
And in some ways, it's really as basic as it gets. You blow cold air at the hot stuff, right? I mean, but ultimately, that's where you look at modifications like in-row cooling for protecting higher density racks. The way that airflow moves through an environment can be a real challenge. So do you have to map all that out before this stuff comes up? Are you responsible for that?
As far as where it's located, yeah.
Yeah.
I've got my assistant and I will sit and talk about the power. We'll talk about where the floor space is available, and then we'll say, okay, if we do this, can we cool it?
Right. So what are you using? Are you chilled water for your in-row, or a refrigerant?
Yeah, it's chilled water. It's a XD system, but it's basically chilled.
Right, it makes perfect sense. I would see refrigerant working in some places where you can't have the luxury of having water involved in it, but for the most part, everybody is using water cooling. So, okay, so moving along to the next challenges is, are you also involved in placing and setting things up, making it, firing it up, or do you have a team that goes from that point on?
We have individual teams depending on what the project is, network team or the systems team, whoever's responsible for the hardware will coordinate with us. We'll assist, but other than just getting it in the rack and getting it plugged in, we just turn it over to them.
All right, so now where are you running into problems? Because obviously you said that there's space issues. The weird thing about data centers is that as we've been going along, the stuff has been getting tighter, but it's been getting hotter.
Right.
So the trick is, are you still running out of space as well, or is it because some of the old stuff just is still there?
I've got plenty of space. I'm coming close on running out of power.
And
in fact, we've got some research equipment that we're not going to let them turn on until we do another power assessment.
Oh, no kidding.
Because you don't want to have a cascading problem if you start dropping circuits.
Absolutely.
And so we'll have that conversation here in the next month or so. But our biggest issue is really just being in old buildings.
Right.
I've got a study going right now to look at renovation versus consolidation versus what a new cost would be.
Right.
And course, there's no money. It's just going to be just going to be a really good exercise and discussion.
Right.
But at least.
But you're magic. You're expected to do it, right?
Well, my job is to give them the information. My director and the CIO can discuss, where the funding comes from.
Right. And so what are you seeing in terms of big stuff coming in? Are you looking at really high density analytics level machines?
The high density stuff is research.
Okay.
The GPUs, they're just
for analytics and
right.
such.
What they actually do with it, I don't know.
That's right. But again, so it's the companies like NVIDIA or even IBM or HP that have special daughter cards and stuff like that. That's really hot stuff that is running. I mean, honestly, you're talking about individual units at 3 or 4 kilowatts sometimes.
Right. Well, we basically don't let them put, over a certain amount in a rack because we can't cool it.
So are you really good at blocking off open holes in your racks too, keeping airflow moving right? It's hard. It's
not
hard.
Really
right?
good, no.
Because again, that's one thing that people don't take into account when it's following airflow.
Yeah, I think we pay more attention in the areas that are higher density because it's more important there.
Oh, sure.
Right, but do we do everything now?
No. Do you find that your racks, you're filling all of them, or are you leaving a lot of that empty space just because of power and cooling?
It depends on the system.
Exactly.
The research computing, very few of them are more than about 2/3 full, just because at a certain point it's more load than we're going to put in. Over on the enterprise side, we have a lot of racks that are full.
Sure.
And I try to work around the ones that have gaps. We got a couple empty racks that we put blanking panels in and things like that.
Sure. Right. And because again, a lot of those are just basic 1U and 2U servers,
right.
Correct? So as far as keeping track of the way that your environment is, do you have any kind of monitoring or visualization system?
We have several systems.
Cool.
Or
not.
Well, we, as I was talking with one of the other guys, love to have a single pane of glass.
Yes.
But it's not there yet.
Right.
So we use a couple different sets of temperature probes that we just place strategically so that we know what the temperature typically is there.
Right.
And then we alert if it varies significantly. We use Libre Site Scan to monitor power and cooling.
Okay.
We have a couple other systems that we just kind of cobble together for specific things. Like I've got CTs on my panels in one of those facilities. Raritan, one of their devices.
Oh, sure.
Just so I can see what's happening, because that's the space that I'm really worried about power. And to not get too much in the weeds, but when you're balancing 3-phase power, your mains out of the UPS versus what the individual feeds are, then you're dropping down to the PDU level. It can get pretty interesting trying to stay in balance.
And again, that's one thing that people aren't aware of, is that when you start using 3-phase, it's operating differently than standard 2-phase or single-phase 120. Right. Yeah. So ultimately, and I always tell a story of at a retail company I was working for, when they built a new building, the utility actually swapped 2 of the legs. So it was not running in the proper cycle. Because again, if you look at a good 3-phase circuit, it meshes beautifully. But if you invert 2 of those, it ended up killing our mainframe.
Well, we shut down the building.
Really?
On that, because when they installed the maintenance, they installed a new UPS.
Sure.
And when the startup they came to do that, they said, "Oh, your A and C are reversed." And so, okay, told the electricians. They went to lunch. The electricians fixed it. They come back, check it. It's good. Start it up. It runs for 5 years, no problems.
Right.
We're going to change batteries. And we're also going to move the battery cabinets, relocate them. So we're going to go into maintenance bypass.
Right.
And when they, did the sequence with the breakers, as soon as they closed, it blew.
Bang.
It took out the UPS, which tripped all the way back to the main.
Oh my
of that
God.
transformer. And what had happened was the electricians took a shortcut. Instead of going back to the panel and swapping A and C like they should have,
right.
They swapped it inside the UPS. And it. Just nothing carried. I mean, you still had 3 phases.
Right.
And everything was fine.
But it just wasn't right.
Until you closed the bypass breaker and you put A on C and C on A. And yeah.
That's not good.
It was an exciting day.
Okay. Yeah, because again, these are the things that most companies aren't aware of, or most operators aren't aware of either. The challenges of dealing with the these hidden. And then I've been just learning a little bit about the challenges of harmonics. And this is something that, and that's I'm assuming an issue in 3 phases, maybe even more so than in single phase, where you've got different demands drawing off of different legs that can create all kinds of harmonics throughout the environment itself. Is that something that you're monitoring, or is that not really an issue?
We've not had an issue with it.
Right.
At this point, anyways.
Because again, not all equipment is sensitive to it, but then other. What? Just out of curiosity, what kind of backup system do you have for power? And
we have in one building we have just UPSs. We have 2 feeds to the building and tie gear. So if we drop one feed, opens a breaker, closes a breaker, and ties the whole building to the feed that's up. That building doesn't have a generator, but we've got plenty of UPS behind it.
And knock on wood, you won't run into a problem where.
Well, I got a story on that too, but it'll take 10 minutes.
Okay.
But the other facility, the parking structure, has got all the communications gear. We have similar system, 2 feeds, tie gear, UPSs. We also have a generator there.
Right.
So that's a pretty good system.
And diesel generator, I'm assuming, yeah. Because again, there's a lot of new options that we're looking at, whether they're talking about diesel hydrogen or even turbine-powered generation, but I don't think that's for everybody. I mean, we're talking about some relatively large installations there. How many times have you run into the need for your failover systems?
We lose a power feed sporadically.
Sure. And that's from your utility provider, right?
Well, we actually have 3 substations on campus.
Right, okay.
And so we'll get 2 feeds from, one from sub 1, one from sub 2, or the other buildings, sub 1 and sub 3.
Right.
And so periodically, a backhoe, a squirrel, utility will knock down a feed. But, usually it just transfers, except for, well, like I said, it's a 10-minute story, so we won't go there. But yeah, we've had an event where we got totally knocked down.
Oh man, and again, and even in the most carefully designed places, I've heard where, say for example, I believe it was the Hong Kong stock market. Even though they had all the stuff in place, the interruption period was enough to throw off all of their systems, so their databases lost concurrency. And it was a nightmare because again, they thought that they had it perfectly coordinated, but ultimately they ended up losing two providers at once. And those I remember talking with some folks over at Switch, and they have in Las Vegas. They have a large facility, and they're talking about resilience. And they said, "Well, we're resilient to most things, but we're not resilient to Godzilla-level problems." Yeah. And literally, there's stuff like that out there. I mean, face it, we've seen an environment where people can go out and shoot out a substation. Literally spending $10 in bullets to kill maybe $1 million in public service equipment. So we're looking at an environment where it's not as assured as it used to be in terms of protecting your power and stuff. How much dwell time do you think you have that you can support with your emergency systems?
Talking about the UPSs.
Yeah.
Yeah. Probably about 40 minutes.
Right. Which is enough to exit as much stuff as you can?
No, because if you're going to take the gear down correctly, without potentially messing something up, you got to do sequential stuff.
Right.
And it take an hour probably to get it down clean.
Right.
If the people were on site when you need them.
But that's always the if, right?
Yeah.
I mean, when you're used to running facilities like that, you just never know. Yeah. And I'm assuming that you have a good testing and verification system, or is it kind of like, we do as best we can because we got to keep the lights on and plenty of other things to do?
We got to keep the lights on.
All right. Well, all the time we have today. It's a pleasure talking to you, sir.
Right.
Thank you very much. Go Kentucky, and have a great show.
All right. Thank you.
Thank you. And now we're going to step away to another break. Thank you very much for watching, and we'll be back soon. Hello and welcome back. Today we're talking with a gentleman from the U.S. Air Force. And the mission of the United States Air Force is to fly, fight, and win air power anytime, anywhere. Whether full-time, part-time, in or out of uniform, everybody who serves plays a critical role in helping us achieve mission success. That being said, I'd like to introduce Mark Worley, who is a Senior Systems Administrator for the U.S. Air Force. Welcome, Mark, and thank you for your service, even though it was quite a while ago, right?
Oh, yes, sir, it was. Late 80s is when I was actually in the military. But yeah, I've been working at the Air Force Weather Agency through a couple different incarnations since about 1998. Started as a contractor there, and then moved into a civilian position, or a DoD civilian position, where I'm actually working for the government directly.
Wow. It must be fascinating work. I mean, when you look at the challenges of weather prediction in general, good grief, it's like, I got to believe, mission critical kind of work for the Air Force.
Right, yeah. I mean, of course, this isn't a lot of people don't think it would support the mission, but, you know, if there's like over in the desert, if there's a sandstorm coming, can't get those planes in the air, so, you know, the mission's got to be scrubbed. So it is actually very important for protecting all the assets from the man on the ground to the plane in the air.
Absolutely. And so where do your responsibilities lie? Do you focus on specific data center areas, or are you mostly in the development aspect of it, or administrative?
Right now I'm more in the administrative portion of it. As we're moving towards more of a cloud presence, we're shifting a lot of our administrative stuff is shifting towards data center management, because we're still going to be there's still going to be some hardware there in the building, and there's got to be someone to maintain it.
Right. So, and it's fascinating because this is something the cloud isn't new anymore.
Correct.
But its capabilities are still being researched and figured out, right? There's still a lot of things that can't go in the cloud, but then there's a lot of things that should eventually go into the cloud. So how much of its understanding of the cloud environment do you personally have to deal with?
Right now, I'm still just learning it, and there is an awful lot still to learn. Of course, the goal is to get everything in the cloud, but realistically, most of the people in my work center don't believe it's going to happen realistically for several years, if ever, quite honestly, because, you know, as you know, I've been looking at in some of these sessions here, like for the cloud repatriation and everything else. Some of these other ones, there are some applications that simply don't function there.
Right.
So so that means we're still going to have to keep that data center, but we're also going to have to look at things such as, you know, what can we get that we have with the cloud, such as, you know, the 5 nines of availability, the disaster recovery, everything else like that. So we're still going to have to keep that in mind for the things that we cannot go in the cloud.
Right. And again, that's the one thing, because I focus a lot on DR and business continuity over the last few years, and the cloud is a blessing when you think about what the cloud can do in terms of being able to provide not only flexibility of data protection, but also workload protection, to be able to migrate something dynamically from an on-prem to a cloud environment. But that's also a tricky challenge, and I'm assuming that's part of what you're dealing with, is the challenge of trying to translate on-prem into the cloud.
Correct, yeah. I'm not really I don't really know all of what the developers are actually doing.
It's all right, neither do I.
Yeah, but I know they're developing some applications that are going to be cloud native. They're trying to get some applications to just, you know, the lift and shift.
Right.
With, of course, various levels of success, which is normal. But yeah, it is actually interesting what all is going on there. But
right. Are you dealing with a lot of repatriation like we were talking about earlier?
Not at this time. Right now, a lot of our migration is still in its infancy.
Right.
So we haven't really found the things that can't move to the cloud yet. So we haven't actually repatriated at this time. But we do still have to maintain the data center in the meantime.
Sure.
And of course, to do that, you know, we're leveraging a lot of virtualization within our local data center. You know, basically a local cloud. For the developers to get into, to get things ready to migrate to the larger cloud.
And the area that you're involved in, do you do weather around the world? Is it something that this is a centralized weather center, as it were, for the Air Force?
Yeah, yes, this is the 557th Weather Wing, which is the main distributor for weather for both the Air Force and the Army.
Oh, no kidding! Wow.
Right. And of course, we have tie-ins to the Navy with with hurricane hunters and everything else. So yeah, I mean, weather is global.
Yep.
So.
And those guys are crazy. I'm just gonna say right now, those guys that fly airplanes into hurricanes.
Yes. But I mean, look how much what we've learned from
no
them
kidding.
doing that.
I know it takes so much stones to do that. I can't say enough about those guys. But it's to me fascinating because I mean, hurricane hunters have been doing this for a long time.
Yes.
Since the '60s, if I remember correctly, and they're still just flying into their guts.
Yeah, exactly. Just to drop the little sensors and everything else, so we can learn more about this.
Exactly right. So are you involved in processing that data as well?
No, our organization is. I myself am not.
Not particularly. So again, we're talking about the main weather.
Right.
Again, what was the weather wing again?
It's the 557.
7 weather wing.
Yes.
Fascinating. And so, obviously the weather is something that's really dynamic. Right. And it is probably probably the most challenging things to predict. So I'm assuming that they've been adding a lot of high performance systems to be able to work these problems.
Yeah, we have, for a while there, we actually had one of the top ranked supercomputers actually in our data center, but since then we have one that's some that are co-located that we're using.
Sure.
Some of the, and if I remember right, they were measured in like petaflops of how much data they're processing for us. Because as you said, when you're dealing with weather, it's very graphic intensive.
Yep, and very complex in terms of the way the calculations run.
Correct, and because anymore they're calculating micro weather, where you're at the bottom of the hill and 100 feet up, the climate's different.
Completely different.
They calculate down to that level of granularity at times.
And again, I'm assuming, because again, given the nature of the Air Force and its mission, they really need to have as granular of a process as they can get.
Correct.
And again, part of it is monitoring, the other part is being able to predict. And again, even though they're married, they're still two somewhat different things.
Right.
So your group does both, I'm assuming, yes?
Yeah. Yes.
Wow. That's got to be a lot. And I'm trying to imagine, how big of a data center facility is this that you're running right now? If you could tell me.
If I remember the numbers right, the one we actually have in our building is a 12,000 square foot one.
And that's basically filled traditional servers for the most part.
Traditional servers for the most part, yes.
And are you also moving in some of the high density stuff, like say you said you had a big supercomputer there before.
Right.
But the funny thing about a petaflop computer is that now you can go out and get one for $250,000 and put it into a rack.
Right. Now, at the moment, we're more focused on the cloud, so that's where we're trying to drive all of the high density stuff. Well, like I said, we have some that's co-located that we're leveraging, and other than that, we're looking at the cloud migration a lot.
Yeah, because again, for the most part, being able to leave that processing in a place that is optimized for it is a lot better than trying to build an environment, especially something as mission critical and as complex as a weather managing supercomputer, right?
Right, exactly.
So, when did you start the migration into the cloud? Because I'm assuming again that there's a military cloud or a mil-spec cloud out there for you. What provider offers it? Is that AWS? Or I know that they were talking about dealing with the awarding of contracts.
Yes.
And I know Microsoft got something, and then there was just a lot of. So has that settled down now?
I know I know a lot of it is going to the AWS.
Sure.
Ours specifically has a lot going there, but I've also seen some stuff I believe going to possibly Microsoft Azure. I don't know if I've seen anything on OCI yet, but once again, I just see a small portion of the whole picture.
Right, exactly. And again, keeping track of your small portion, it's no small task. I mean,
correct.
How many racks are you responsible for? Do you have any idea?
Not off the top of my head, unfortunately.
No, I expect you to count them up in your head as you go along.
I'm still more the sysadmin side, not the data center.
Right.
So I'm just gradually working into that piece.
So from a sysadmin perspective, is it both a combination of providing providing services from their computer systems, but it's also part of the administrative process and the data center management process?
Right, yeah, that's where it's at. Of course, we handle the local VMware infrastructure that allows our developers to get in from a public location into our internal network so they can do their development in a secure environment.
Right.
and this especially came to a big head, obviously, with COVID going on.
Oh, no kidding.
Because instead of having our parking lot full, everyone in the building, it's like, yeah, we've got
Nobody
5
here.
people in the building. So,
Exactly. So, I'm assuming you're one of the critical people that was allowed to go into the building, right?
I was on the list that if they needed a physical presence, yes, I had to go in there. If someone has to, do an actual hard shutdown on a server or something, somebody's got to do it.
Somebody's got to do it, exactly right. And I'm assuming that it also changed your production environment as well, because once people were working from home or from whatever remote location, you had to be able to service all of those people.
Correct, yes.
So are you also responsible for the networking and connections for that as well? Because again, you're doing a lot. You said some of the stuff is being done on VMware and
Correct.
as part of your normal production environment.
For the most part, we just handle what's in the building. Other than that, we're working with other agencies. Of course, we work with the communication squadron on the base, and then there's a larger groups over that. So
I got to believe it's a relatively massive group of people that are involved in it.
right, yeah. Just like any other organization, there are different tiers depending on where you're at. Which, of course, the coordination with that is a challenge in and of itself at times.
Yeah, exactly. And again, it's a matter of there's undoubtedly so many things that you can't share, but boy, there's got to be so many things going on that require multiple levels of approval, multiple levels of clearance to be able to get through.
Yes, exactly. Yeah, there's the of course not only with the budget, but where the money goes is very important.
Right. Do you have any budgetary responsibilities?
No, I don't want
Hallelujah,
any.
right?
Oh
my
best
God.
I have on that is possibly pass recommendations to my boss, who winds up passing up the chain, and hopefully one day it hits the budget.
Yeah.
But, we'll see.
And again, have they been pretty good at giving you the opportunity to explore into new stuff or to actually expand as you need?
Yeah, they've been making training available for us to do with any of the cloud services that we can. We've got a lot of training opportunities available. Of course, right now things are still in flux, so we're in our shop. We're doing a little bit of a shotgun approach. We're just trying to learn a little bit of everything.
Right. You got to get an idea conceptually first, and then you can be able to expand upon it.
Exactly.
Yeah. So and it's not you. Every company has to deal with the challenges of cloud migration.
Right.
And again, the trick is, after a while, understanding what works there, what doesn't work out there. And I always say the cloud is a tool in your tool belt. It's not an end destination, even though it would be useful in some cases. Ultimately, you need to look at the cloud as a tool that you can reach for when you need it the most.
Right, exactly.
Excellent. This has been excellent, my friend. Thank
nice
you very
meeting
much.
you, sir.
Pleasure meeting you too.
Thank you very
much. And carry on. And that is trouble right there.
Hello, young man.
My man,
Fancy
how you
seeing
doing?
you
Good to
here.
see you, Roy. Boy, it is. What has it been? 3 years, probably.
Must be at least
Have you been
3.
actually making it over here? Because I got to believe you lost all your miles. You are the miles king.
No, because I was with Air France KLM. Once I'd done 10 years, I'm platinum for life.
Oh, no kidding.
So I've got all my privileges still. So absolutely awesome. But yeah.
Oh.
No, it is. It must be about 3 or 4 years since we've bumped into each other.
Oh yeah,
Good
no
to
kidding.
see you.
Yeah, good to see
And
you
you're
too.
looking good, mate.
Thank you. You too. I'm not with 451 anymore. I ended up because they were bought by Standard & Poor's, and they stirred the pot big time. And so I was trying to decide what to be what I wanted to be when I grew up, and it was a choice to get involved a little bit in publication. I hadn't done that in a while, and all of a sudden this neat stuff shows up. Are we rolling? I'm sorry. Hello. I want to introduce. This is a friend of mine. He's a brother from another mother. My friend here, Roy Elliott, and you are currently an analyst at Omdia.
Yep.
And how we go back quite a few years. How has your coverage changed?
It's not changed significantly. I focus more on cloud and data center now.
Oh, sure.
But I still do the DAC people. I still talk to
It's
the
all-
data people because it's all
It's
Steve,
a rich tapestry, right?
It's all so connected.
Exactly.
You can't talk about that without that impinging on that, without that impinging on that. It's just, it's IT. It's a big melting
thing.
pot.
Right.
And if you're just sitting in your silo and you're blinkered, then
you're missing a lot of the picture.
As we found.
And yeah, it's exactly. And again, you and I share that in common in terms of the fascination with the big picture.
Yeah.
You know, ultimately understanding what a storage requirement is, or what a networking requirement is, or computationally what's going on. This is something that we've always talked about, is being able to have the big picture, and then still to be able to drill down to specific areas that make a lot of sense.
Yeah. And it's connecting those dots.
Yes.
That is the real key to people understanding. Because the last 2 days, I've been doing something that I wasn't expected to do. I've been hosting Data Center Build.
Oh, no kidding.
And that is a conference specifically for the data center construction industry.
Wow.
I don't know anything about construction, but 2 days, I was just a host, so I was just introducing people.
Sure.
So I wasn't there as an expert. But 2 days of being at that event, I have learned
so much.
Yeah. For example, there is 4 gigawatts of data center capacity being built this year.
No kidding.
And you think 4 gigawatts? That is
massive.
It is.
Exactly. I've been I've been writing a bunch of stuff on the sustainability of data center. Because again, it's pleasing to see that we're thinking in those terms. So much of what we do is evolving along the way, so much is responding to the business requirements, but to get to a point where we can actually start making things more efficiently, it's one of the things that I'm finding fascinating. And so I've been looking into things like alternative power, alternative fuels. The thing that surprised me the most is water problems.
Oh yeah, water's a big issue. Power was a really hot topic in there.
Oh, no doubt.
Particularly the debate between nuclear power.
Oh yeah.
And having those small nuclear, I think there's less than 300 megawatts.
Right.
You have a fence. You don't need the permits. You don't need the.
You don't need the huge enclosure facility.
You can put them. And the guy on the panel was saying, people in America would be surprised how much of the land is actually already allocated to that type of small nuclear plant.
No kidding.
They probably don't know it.
But
the piece of land next to them, probably the government has already said there's a permit if you want to build one for that.
Oh, no kidding. And again, I think that the nuclear industry got a bad break over the 60s and 70s, and part of it was because we were still children with handguns. Let's call it that way. But ultimately, they know a lot more about nuclear energy today. And like you say, some of these small reactors can do some amazing things, much more efficiently, much more ecologically, and safer.
Yeah, and well, the other point that was made, and it was something that I hadn't actually thought about, when they said is, well, most of the U.S. Navy runs on nuclear power.
Sure.
So when the ships and the submarines are in dock, you've got a nuclear power plant
sitting right there.
Sitting right there. So
yeah. And again, we're so many generations in. It's not. There has been so much into it, and I've been fascinated by it because I was doing a lot of research into nuclear because it was like, why are we so negative on it? And you start looking at the relative safety of the nuclear industry, but then you see the other side of it, which is that there is some really ridiculous things that's happened. But partially it's because it gets commonplace. If we remain visible to the government or whoever's involved in managing it, it's not a problem. But we still see things like medical equipment that got thrown into a scrapyard, and people are prying it open and pouring out cobalt, radioactive cobalt on the ground. It's like, oh, this is so bad. But again, this is when you look at some of these equipment goes back to the 60s and the 70s, when they kind of thought we had these things controlled, but after 10 years, the stuff just disappears on you.
And so the advantage of some of this new stuff, and it was really fascinating listening to that Data Center Build, is that you can even get down to sort of like the nuclear battery option.
Oh, wow.
Which has absolutely got nothing. You just have it there. It gives you powers for so many years.
Right.
And then the truck turns up, picks it up, replaces it,
right.
takes it away. And it's sort of like, why aren't we using that more?
Yeah, exactly.
As a power source, it's green.
Yeah.
It's environmentally friendly. And you've got no issues with permits or anybody worrying about hot water, steam, and leakages.
And it's totally consistent. It is good for its entire life cycle with practically no problems whatsoever. But again, it's a matter of getting over this the mentality that all nuke is all bad.
Yeah,
and really.
And then that was the point of the big message from the conference. There was, the data center construction industry and the construction in general has got a really bad press. But when you hear of the stuff that they're actually doing, the work they're doing on diversity, the work they're doing on making the job sites much more welcoming and friendly.
Right.
There was 2 separate sessions, both on day 1 and on day 2, which were all about how do you make the job site, acceptable to women? Because only 3% of the craft people are women.
Wow.
And they've got an issue with labour. They can't get the labour. Well,
Right.
if you've got 50% of the population that you're not even
Looking
appealing
at.
to,
Yep.
then you've got a problem.
Right.
And there's some really good work. There's some really good sessions about what they're doing, how they're working together.
To get diversity into the because again, you got to admit that IT was pretty much a guy type of business for the first
Oh, yes.
50 years, right?
Well, look at us.
Yeah, exactly.
We've been about for so many years, and we are the typical. We're the white old male.
Old males, that still track this stuff. Oh
Yeah.
my God! But again, so much interesting stuff is going on in the background, and there have been groundbreakers like Admiral Grace Kelly. Oh my God, Grace did so much for developing the nuclear navy. I mean, ultimately, if you look, when you start drilling into the amount of input that women have offered in science, so much of it is in the background when really these are people that really made some of the biggest breakthroughs in Earth. So the idea that you're going to not include them as part of your targeted group of employees doesn't make any sense at all.
I mean, it was really good. I mean, the final session was done by Nancy Kovac, and she's a brilliant ambassador for getting more women into the industry, how they get greater diversity, how they can do sustainability, and she's been in construction for all her life.
Right.
And you listen to somebody like that, and you go, I never realised that about that part.
Right.
Because a bit like you, I've always engaged with data centers as it's been built, it's got the servers and the storage in it. So how do we manage it? How do we operate it? What software do we put into it?
Right.
Not how the hell did it get built?
That's exactly. Do we do a slab or raised floor? All these different. And I've had the fortune of studying some of that in the last 2 years since I started doing other things. And again, I've been looking at the whole ESG movement, which is great. Yeah. The idea of being able to look at governance and look at sustainability as part of it. And the things that seem to make sense, you look at it as like, say, I followed up on hydrogen, and we've been hearing about hydrogen for decades.
Yeah, the problem with hydrogen, that we're discussing it there is, the use cases of it are probably quite niche.
Right.
So natural gas is a transit energy source.
Right.
Before we move into something else. Renewables are not reliable because the sun doesn't shine.
Right.
It's not always windy. And you've got massive problems in the distribution network, particularly in countries like the US.
Right.
You've got stranded power. Because, one of my co-hosts lives in Minneapolis. He said he was driving through Ohio. It was as windy as hell, but nearly all of the wind farms were shut off. Not because there was no wind,
because it was
it's
too
because
windy.
they'd got all the power in the grid they could take, and they
Right.
couldn't export it to where they
Right.
needed it.
And storing that power is, again, very, very difficult in the way that we have our grid structure set up. So, this is where I've been looking at and been hearing about things like microgrids, where they have the ability to give back, they have the ability to be utilized as needed. It breaks out and it spreads out the amount of responsibility for the electrical grid in general. Yeah. And it gives us many opportunities, because again, you're talking about small nuclear plants that could be utilized for this. When I started digging into hydrogen, right now you can go out and GE will sell you a 500 megawatt turbine generator system that is as fuel efficient as anything out there and will eventually run purely on hydrogen, which means the only output is water vapor and heat. And it's built into a two-stage environment that they reclaim the heat and then they generate power off of that too. So we're talking 500 to 700 megawatts of power from a single turbine. Amazing that we got these technologies available to us.
And it's just a matter of actually deploying it and getting it. Because one of the other sessions that was really, really interesting was Alan Howard's panel that he was running. And Alan's another analyst at Omdia.
Sure.
And he looks after financing. And the discussion about the financing, how you actually finance the data centers, and the green financing that's out there, and how a lot of that is greenwashing. That was a fascinating discussion because that led down lots of different routes to understand the risks and rewards of how you finance these data center builds. Because in times when inflation is high and capital costs are high, to build a data center and then lease it, you've got to actually sort of get a massive amount of capital to do it.
Right.
And that was a fascinating discussion. Must admit, a lot of it went straight over my head because I had absolutely no idea what these guys were talking about. But the people in the audience did, and they were really, really fully engaged with it. But
Again,
you're right. You look at this whole industry now, and it's an industry in transition. And I don't think it's my concern, but my look to the future is how are we going to embrace all of this change and grow it and not revert back to type?
Right.
And then it's a big issue that we've got is we can very quickly, when things go wrong or start costing more money, revert back to type. And I think it was something that Chris Cosby in the keynote said at that event is you can't be sustainable if you're slow, you've got to be fast, and don't have big projects and big ideas.
Right.
Small incremental steps add up, and once they all add up, they make a big difference.
Right.
So, just go doing that. You've done something. Move on to the next. You've done something.
Right.
You've made a change. Design labor into the building and running of a data center. Don't sort of assume that you've built it and then think about things afterwards. Manufacturing has been designing that from day one.
Right.
So all of the production lines have the goods coming at the right time for when the production vehicle or whatever they're doing gets to that point. It's not the same in data centers.
Right.
We don't do that.
Yeah.
We need to. So there's a lot going on, and there's probably far too much going on to keep track of it. But it's good that it's happening.
Well, and ultimately, if you look at the way that the data center is evolving now, it's not as bespoke as it used to be.
Yeah.
I mean, especially when you start, and again, it depends on the way that it's tasked. If you're talking about a colo, if you're talking about enterprise data center for a specific company or a bunch of companies, or if you're talking about a cloud scale, they have different needs, they have different targeting, they have different requirements. But for the most part, you're still seeing the simplicity of having a relatively common set of tools for them to go with. One thing that fascinated me earlier, I should say last year, was the idea of prefabrication in the data center. And it wouldn't be something that you would think of, right? But there's a lot of elements of a data center that could be prefabricated and also support the idea of being able to do incremental growth like you're talking about.
Yeah.
All right.
And what you have to think about with that, it was a good comment that came in the last session, was standardization. If we standardize what we're doing with that, so if you're doing it here, you do it that way, you put this UPS in, you extend it like that, it can be the same all over. And then you can address your labor problem by having people that can understand the same process in a standard approach and deploying it. So that's key. But one thing that, because I know we're coming to wind up, that to add on to this is the data center business is being challenged by data sovereignty. As we spoke about years ago, it's now beyond what the EU thinks about data sovereignty. Data sovereignty for the EU is it doesn't like the US Cloud Act, right? It doesn't like the law enforcement being able to say, oh, right, I want the email that Roy sent that's in a French data center because I think that's germane to something we've got.
Right.
Yeah, the EU doesn't like that. So sovereignty to the EU means the data stored in the EU, it's processed in the EU, and extraterritorial access is denied.
Precisely.
So that's what the EU's done. But lots of other countries around the world are now jumping on the data privacy, data residency, data processing.
Right.
And that's so they can get data centers in their location.
Right.
And then they can tax it and get money from the digital economy.
Of course.
And it's fascinating to see. I was in Dubai last month speaking, and I did a bit of research on countries that have come up with digital sovereignty and digital privacy rules. Oman 2022 had put one in. Egypt in 2022 put one in. South Africa.
Wow.
Vietnam. Saudi Arabia didn't have an exact one, but they'd done some work on it. So there was lots of smaller countries coming up with that approach.
And starting to get on board with the whole digital revolution.
And what they're saying is that means you now have to put a data center in my location. So AWS have got local zones now, which
Right.
initially was LA for the film industry. They've now got that, so they can drop that into a country. So I think Morocco is the first country they're dropping it into.
And meet all the compliance issues necessary.
Yeah.
Roy, I'm afraid we've run out of
we've run out
time.
of time. What a
We
pity.
could talk for another 4 hours. I'm serious. We have talked so much in the past. Roy, it's a treat to talk to you again,
Good
my
to see
friend.
you
I'm
again,
glad to
Steve.
see you back on this side of the pond.
I'm glad to see you.
Congratulations on the new king.
Oh, thank you very much.
It's-
I didn't see it because I was flying over.
You're
it.
flying over, right? Take
But
care.
never mind.
And I think that's all we got for today, everybody. We'll be back tomorrow with a couple of chats at the conference room. And that being said, thank you. I've been Stephen Hill. It's been a treat speaking with you today, and keep watching.